Hi, I'm Adi Arun, and I have created a course where you'll be taken through the perplexing algorithmic journey of creating a complex 2D version of the game Minecraft with Flutter and a bare bones game engine package Flame. This is a jam packed, all in one 24-hour long course made with 600 hours of dedicated work, which will leave you well on your way to becoming a better developer. In this course, we'll cover every prominent feature that makes Minecraft the game it is, including procedural terrain generation with Perlin noise, biome generation for deserts and birch forests. This is of course expandable. Structure generation for trees, cacti, flowers, etc. Chunk rendering and unrendering logic. Dynamic crafting algorithms. An intensive inventory storage algorithm mirrored on a versatile inventory UI, day-night time cycle paired with a parallax sky, hostile mobs including zombies, spiders with their own AI, a large arsenal of tools and weapons with specific functionality, gravity blocks like sand, world saving with Hive, an interactive launcher for creating worlds, and much more. All of these complex features and code are packed and explained line by line with captivating animations. But this is not it. You can expand on my take to Minecraft, as this course was designed to encourage your creativity. If you have any problems while coding, you can reach out to me on my Discord server. Okay, so now let's add a zombie component to our game, which will be 2 blocks tall and it'll be constantly playing the walking animation. So this is a sprite sheet that we'd be using for our zombie animations. The first 2 rows are for the idle animation. The idle animation will play when the zombie is not aggravated on the player, meaning the player is not exactly near the vicinity of a zombie, but we don't really care about this for now. We'll just be focusing on the 3rd row, which is our walking animation. Right. And you can find this image inside assets, images, sprite sheets, and then we have a mobs folder with 2 files, sprite sheets spider and a sprite sheet zombie. So the sprite sheet spider is a similar one, the exact same format, but for a spider, like this. So we'll be adding all of our mobs inside of a folder inside lib called mobs, because eventually we'll have tons of mobs. So just to organize everything and stuff, we'll be adding it inside here. And let's create our file zombie dot. And this will just be a component, so class of zombie. And this will be fairly similar to our play component. So let's go up here into our play component, components, and then play component. And the play component extends from entity to get all of the logic, properties, and functions or methods of a base thing or a base existence in our game, like damage, gravity, falling, etc. And there is a player dimensions property. The dimension defines the actual individual grid that Flame should look for while working with sprite sheets. So in our case, let's actually first go into the player sprite sheet. And so the dimensions for the player sprite sheet is 60 by 60. So 60 in width and 60 in height, so a square. So that makes sense, right? So we have 60 covering one exact player, another 60, another 60, 60, right? But for the zombie, it's not exactly a perfect square. It's kind of like a rectangle. So we have 67 pixels as the width and 99 pixels as the height. So that will be the size of each grid. That will be our dimensions. Now let's go inside play component again. And so we'll define 2 animations, one for the walking animation and one for the idle animation. And for now, let's just define the walking animation, right? We'll add a hitbox so that it will actually be able to collide with things. And the anchor will also be bottom center so that we can move the position accordingly later. And yeah, that's about it. And we'll be adding a falling logic because we want our zombie to fall, a jumping logic because we want our zombie to jump, and kill entity logic, that too. and we won't be having health and hunger logic exactly, but um, we'd be having set all collisions to false, etc. So let's start beginning to create this. So zombie, we first need to extend it from entity, right? And let's define the walking sprite sheet. So sprite sheet, walking sprite sheet equals sprite sheet. And for the image, we need to pass in an image. So we could either do flame.images.load, which would require an asynchronous environment, which this currently is not. So to actually define this, we'd have to do this inside the onload, or else we could load it in the first, just as we are doing for tons of images right here. And then we could then use flame.images.from cache to actually use the image. So let's go up here into our actual sprite sheet and let's copy its relative path and let's load it. Await flame.images.load, and then we'll paste this in here. Let's fix up the slashes and we can remove the assets/images reference. Cool. So we have loaded our image once. So now to use it, we don't need an asynchronous environment. We can just do flame.images.from cache. So flame.images.from cache, and then we'll pass in the path again. Let's remove assets/images first and make these forward slashes. Cool. So we have loaded up our image. Now we need to actually define the grid that each of our sprite will be in. So that is the src size. So just as we did for the player, we can make a separate variable for it, because why not? So vector2, we'll call it zombie dimensions, or let's just call it dimensions, and this will be a vector2. So the width of each grid should be 67 pixels and the height should be 99 pixels, right? And we'll just add this as the dimensions. So now it knows what the actual size of a grid is, and let's see, we have some kind of an error here. Dimensions, okay, we'll make this a late initialization, right? And a semicolon here. Cool, so we have defined our walking sprite sheet, and now let's go inside the onload. The onload, we have to override it, and it's a future, and onload, this is asynchronous. Cool, we also need to call super.onload, and here first need to add an hitbox, because we want our zombie to actually collide with things, right? So if we want something to collide with something else, we always need to add an hitbox to it. So rectangle hitbox, right? And then let's just set the animation to a walking sprite sheet dot create animation. Oops, create animation, and the row will be the third row. So 1, 2, 3, but when programming with counting from 0, so 0, 1, 2, so that would be the second row. And the step time, let's just give it as 0.1 or 2 or something. We'll change that later, right? So we also have an actual sprite for it, and let's also give it a size. And let's actually do this inside of an on-game resize, so that it'll be responsive, meaning it'll change the size every time the screen size actually changes. That is because our on-game resize gets called every time the screen size is being changed. So on-game resize, we'll call this, it's a vector2, we'll call this new screen size or whatever. We need to call super on this, super on-game resize, new screen size, and we'll set the size to, let's say, dimensions multiplied by game methods dot instance dot block size. And this, this will definitely break our game, but I'm just, let's first just have it as this so that it'll be an actual responsive demonstration. We'll change this afterwards. And one more thing, now, we have an actual sprite, but it doesn't do anything. So inside of the void update, we actually have to implement all of the logic. So like the falling logic, the jumping logic, etc. So we'll do falling logic. Let's just search for everything up with the logic keyword. So let's go all the way down here. So we have falling logic, jumping logic, kill entity logic, and tons of stuff. So we'll have our falling logic first. Oops. Entity kill entity logic. Then the jumping logic. And at the end of each update, we always have to set the collisions to false. So we'll also do that. This is just because our collisions work. And let's just add an instance of this to main game. So let's just go in here and then do add zombie component, or we just call it zombie. Right. Let's not restart our game and let's see what we get now. Okay, so we get an error. So try to access an image, sprite sheets, mobs spritesheet.png that does not exist in the cache. So that would mean that actually loading it wasn't successful. So that doesn't seem to be any problem here. Let's try that again. Okay, it seems to have worked that time. Cool, but where exactly is our zombie? We cannot exactly see it. Let's try going into our zombie component and then changing the size to something reasonable. For now, we won't make it responsive, so size equals dimension. We'll eventually make it responsive, but for debugging purposes, see if everything's working for. Okay, there it is. So we have our zombie, and it is extremely small, right? But it doesn't seem to be working too well because it's colliding with everything in our game, so we need to fix that. And this is actually quite easy. We just need to go inside of our entity, inside resources, or we can go that by holding control and then hovering over entity and then clicking on it. Now we only want to do all of these logic if what we are intersecting with is a block, because we only want collisions to happen to blocks. So, or collisions to be detected with intersecting with other blocks. So if other is of type blocks or block component, right? So everything that we want to collide with, like these are all block components, but this right now is an item component. So this simple if statement will do, and then we'll paste all of the code back in here, right? Now let's see if that works. Yep, it does. But again, it collides with things that we don't exactly want it to collide with, like a flower. So we have defined all of this logic for a player actually. So let's actually just copy paste all of this from the player. So inside of the player component, up inside of the on collision, we have some if statements, and we just copy this. Or let's copy this entire thing. So what exactly have we done here? So we did this because we didn't want to assume that our, whatever we are implementing with our entity does not collide with an item component. So, we specified that our player will not collide with an item component or uncollidable blocks with an if statement here. So we checked if it is a block component and it is actually collidable. Only then we're doing the collision. Okay, so this is, correct behavior for a player or new mobs that we're going to add. But maybe we'll be adding some sort of unique different mob that might want to collide with a block component or an item component or something, where in that case we wouldn't want to have that if statement inside of entity. So we'd want it to collide with everything, and if there are any restrictions, we're only doing that inside of a local level inside of the on collision of that, so that it only applies to that and not all, every different child that inherits from entity. So let's, control Z all of this. No if statement here. And we can actually go inside our play component and then copy paste that code in, and everything should work fine. So we'll copy this, go into a zombie, and then paste it in here. Oops, not the if statement, the entire on collision function actually. So back into a play component, copy all of this, and into a zombie, and let's paste it in here. We're overriding the on collision inside of our entity, and then we're only doing whatever that we have inside here if what we're colliding with is a block component and it is actually collidable, right? So cool. So now we're doing it in a zombie level and it's not applying for everything that's extending from entity, right? So this is a better way of doing it. Let's auto restart our game, and everything should be working fine. So the zombie did not exactly collide with that dead bush over there, and cool. Now let's make the zombie 2 blocks tall. So inside of the zombie dot dot, we're going to set the size to dimensions multiplied by brackets, then the actual block size. So game methods dot instance dot block size dot x multiplied by 2, and we'll put this in brackets again, divided by dimensions dot y. Right, let's auto restart our game and see how that looks. Okay, so now our zombie is exactly 2 blocks tall, but it kind of sunk for some reason. Okay, we'll fix that. So, what exactly happened right here? So we are multiplying the dimension with kind of like a magnification factor. So what the size we want it to be divided by the current size, right? So this actually makes our dimensions like proportionally get, that type of bigger. So let's say we had a component with the width as 1 and the height as, okay, width as 2 and the height as 1, and if we wanted the, what the new height should be as, let's say 4, we are dividing that by the current dimension, so 2, so we get 2, and we're just multiplying our dimensions with that, so this will become 4 and 2, so it's proportionally getting bigger. So that's what this logic does, right? So that works. And now let's actually work on the actual logic that will be specific for our zombie. So what should we want a zombie to do? We want the zombie to follow the player and then collide with it and then eventually attack it. And if it's colliding with something else along the way, like here, it's trying to walk past here but it hit somewhere here, then we wouldn't really want it to get stuck there. We want it to jump, but it seems that our zombie has fallen through the wall because there's something wrong with the collision. So let's fix that. Let's try going up here and then changing the anchor to anchor dot bottom center, so it actually detects the collision directly from the bottom, and let's see if that made a difference. Okay, so everything seems to be working, and yeah, I guess that fixed it. Now let's add a zombie AI or logic that constantly follows our player and also avoids blocks if it's in front of it. So let's put a zombie AI or a logic inside of a function, and let's just call it zombie logic. Right. So here we first want to check if the zombie is to the right of the player. If yes, walk right. If not, walk left. And then we also want to check if the zombie is colliding with something. We can know with our move method, right? So our move method returns false if the zombie is meant to go to the right but is unable to if it's colliding with something. So if it is false, meaning if the move method is false, meaning it has collided with something. So if the zombie is colliding with something, we'll just make it jump. So yeah, that's pretty easy. So we're gonna put an if statement. And then how do we actually check if the zombie is to the left or the right of the player? We can check that with the x values of both of the player and the zombie. So if the zombie's x value is smaller than that of the players, we know that the zombie will be at the left. For example, here the zombie's x value is like 0, 1, 2, 3, 4, 5, 6, 7, it's something like, let's say 100 or like 300, and the player's x value is probably like 500 or something. So 300 is smaller than 500, so it's at the left. But if it were right here or something, the player's x value would be smaller than the zombie's x value, so the zombie will be at the right. And it's actually get the player's x value inside of a double. So double player x position. We can get this with our global game reference. So global game reference dot instance dot game reference, then dot player, the player component, dot position dot x. So we just reference the player component variable or the instance inside of our main game, and then we just access the position of it, just as we can access a position inside of a onload. It's a, that it's the same position, and since position is a vector too, we are able to access the x value, right? So now we have the actual x value of the player inside play x position. So if, okay, so let's actually put some comments here. If to the left, so if you want to check if the zombie is to the left, we'll do position dot x. So position relates to the current instance's position, which is our zombie. So if the zombie position dot x is smaller than the player x position, if yes, move to the right. If not, move to the left. So move to the right and move to the left. Right, so we're just gonna do move. And yeah, for now let's just do this. We'll implement the jumping later onwards. So move and cool. And for the DT, we'll be calling this inside of a, the zombie logic. We'll be calling this inside of the update where we have access to the DT. So we can just do double DT as a parameter, which we can pass in here. And thus we can pass in the DT for our move. And then we want the zombie to be significantly slower than the player. So let's do game methods dot instance dot player, or let's go inside of a player component. And this is how we are actually getting the speed inside of our update and changing our speed. We have the logic here. So we're just multiplying the player speed inside of constants, which is like 4, meaning 4 blocks per second, and multiplying that with the block size. So it actually goes, let's say if the block size was 10, it'll go 40 pixels, so 4 into 10. And then we're multiplying it by dt, so that only occurs over 1 second. So if you multiply anything by dt, it's going to change it to that thing's going to occur over a second, right? So let's copy this, or actually the entire thing, to get our player speed. So this is our player speed, and let's go to the zombie, and we're gonna put this inside brackets and then paste this in here. And this is the player speed, and we want it to be significantly slower than the player, maybe like 1/4 of this or 1/3 of the player speed. So divided by 3. And so we want here the zombie to moving to the right, to be moving to the right. So we said the component motion state to component motion state dot walking right. And here let's actually copy the entire thing and paste it again, and just change the component motion state to walking left. So this is getting called every frame of our app. So inside the void update, And we're first getting the player's X position. We're checking if it is smaller than the, if the zombie's X position is smaller than the player's X position, meaning it's in the left. If it is in the left, we're walking right at a decreased speed. And if it is to the right of the player, we're walking to the left again with the same decreased speed. Right, let's restart our game. And now the zombie should be actively following the player. So let's go here. And it is. Cool. And if we go to the left, and yeah, that works. Now let's actually hot restart our game again. And let's quickly go up to a second inventory slot. And while the zombie approaches here, we're gonna place, okay. And if we break this now, the zombie is not able to move to the right because there's a block colliding to it. But we want the zombie to jump over it. So, how do we actually detect if the zombie is colliding to the right? Rather than just doing if it's colliding right, we can do it another way. So inside of here, our move either turns true or false based on if it has successfully moved. And in this case, it has not successfully moved. So we'll cut this, put it in an if statement, and check if it has not successfully moved by putting in exclamation mark here. And so here, so this will get called if the player has not successfully moved, just like now. And here we want to just jump. And same here. So let's actually cut this, do an if statement, paste this in here, and then put an exclamation mark. So true will be changed to false and false will be changed to true. So it's like the opposite symbol. And if it has not, changed the actual position successfully, we want it to go inside here where we will make it jump. And if it jumped, it's gonna, still gonna try to go to the right. So it will go over that block and then go on again. Right. So now let's actually go inside of our play component and see how we actually are making the player jump. So inside of a movement logic, here if the component motion state is component motion state dot jumping, we're setting the jump force to blocks, 60% of the block size. Let's actually put this inside of a function inside of entity. So we'll cut that from there, go to entity, and we'll just call this void jump. And this is it's not a really complicated function. We're just setting the jump force to some value here so that this is more readable. So now inside of a play component, we can go inside of here and then do jump. So now if someone is reading this, they'll know, oh, okay, so if it is colliding to the bottom and the component motion state is jumping, the player's actually got to jump. So now we can do the same thing inside of a zombie. So if this is the case, then jump. If not successfully move to the left or right, then jump. Same here. Then jump. Right, let's restart our game now. Okay, let's go up here. Let's place a block here actually. And as you just saw, it jumped over that. But now, okay, and it did that again. Right, it shouldn't have been exactly able to do that. But we get some issues here. It's like, super jittery and stuff when it gets super close to the player. This is because once it's in the center, it'll either be a little bit to the left or a little bit to the right, meaning it'll try to go to the opposite direction based on our logic here. So we can check that, we only want to do this if the player or if the zombie and the player are quite a distance apart. Like we don't want to check for this logic or check for the movement logic if they're like literally at the same position. So that is what's causing this issue. So we can put this entire thing again inside of an if statement. Let's paste this again. And here we'll just check if the difference between the player, okay, we'll put this inside brackets, player X position minus zombie, or our zombie's position, so position dot X then the absolute value is greater than, let's say, 10 pixels or something. So what does that mean? So if the zombie was here, let's say at x position 400, and the player was here at the x position 500, 400 minus 500 would be negative 100, and negative 100 dot obs, or not obs, abs would change it to positive 100, and it will check if 100 is greater than 10. If yes, it's gonna do this. But let's say the zombie and the player were like super close like this. So let's say the zombie's x position was let's say maybe 500, and the player's x position was 499. So if the player's x position minus zombie's x position, which is 1, if it's greater than 10, it's not. We don't want to do this. So now it should be a little less jittery and a bit smooth. Let's see. Okay, and it definitely is. Cool. Now let's try placing. Okay, let's like try going here super quick, and then let's place a barrier. Now it should be able to jump through that, but we don't really want it to do that. We only want it to jump through a 1 block wall, right? We don't want it to jump through like 2 blocks. That is because the zombie is able to jump whenever it wants. So inside of our jump, we'll put another logic just to check if the player is colliding with the bottom. So if it's colliding bottom, then do this. So it'll only increase the jump force, which is responsible for actually decreasing the player's y value or jumping. We let the jump force increase only if it is the players are actually, or the entity is actually colliding with the bottom. So what was happening is that when it was trying to move to the right and it was unsuccessful, it would constantly change the jump force to something high. So it'll just like go up super high. But now it shouldn't be able to do that. Let's actually break that block, and it did. But let's see that again, because it was kind of hiding there. Okay, let's go up to the left. Right, cool, that's fine. And we can fix that just by changing our jump force to like something like 55, so that it would jump at a little slower rate. Let's see if the player is still able to jump at a reasonable height. And it's not, but okay. So we have a problem here. If we set this to something like a 0.6, what's going to happen is that the zombie will be able to jump fairly high. But we actually, 0.6 is not enough in general. What we had right now for our jump in was 0.6. So 60% of the block size. But that was not enough because, at times the player wasn't able to jump like fully through the, to the top of a block to actually go to the left or the right. So yeah, it was super hard, but we want it to be this high. But not exactly for a zombie. So we'll put some kind of like timer between the jumps. Like right now the zombie is able to constantly jump every time it's on the ground. So if we go here and up to here, see, it's able to like constantly jump like super fast and stuff. That's what's causing the problem. Let's place a few more blocks again. And see, it's able to constantly jump like that. But we don't want that. So we'll put some kind of a timer. So let's go inside of a zombie, and we'll create a timer component. Okay, before that, we'll create a boolean value called can jump, and we will default this to true or to false. And every 1 second we will set this to true. So every 1 second only, it'll be the player or the zombie will actually be able to jump, right? So it'll only be able to jump at specific period. So it wouldn't be like super overpowered as it's right now. So let's create a timer component that will fire every second and then set the can jump to true. So timer component period will be 1 second. Repeat true because we want it to constantly run, and then on take is where we define what's gonna happen when the timer's up, so we want to set the can jump to true. And now inside of our zombie logic, we'll only jump. So if can jump, we'll jump. So, and can jump only gets set to true each 1 second, and after we jump, we'll set can jump to false. So our logic works. So let's say the zombie was trying to jump and then can jump was not true, then it wouldn't jump. But each second when the can jump is set to true, it'll jump, and then it'll set can jump to false. So it'll only jump again in the next second. So that is how we're actually creating a timer. So if can jump, and then can jump equals false equals. Okay, now let's test this out by running our game. So hotly start. And let's quickly run away from the zombie and then place a few blocks. Oops, kind of forgot to change the slots there. Now in the second slot, let's run away and place a barrier. So it's only able to jump every second, right? Cool, so that works. Now let's make it so that the zombie only approaches the player when the player is within a specific reach. And we'll also make it play different animations depending on if the zombie is aggravated on the player or not. For example, right now it is not aggravated because the player is not near the zombie. But if it is near the zombie becomes aggravated and it plays the walk-in animation and then goes towards the player. So we'll keep track of the data which defines if the zombie should be mad at or aggravated at the player in a boolean value inside of our zombie called is aggravated, and we'll default this to false. So is aggravated equals false, and we'll basically just set this to true if the zombie is within reach of the player. And this is something that we had already implemented for our placing block logic. So inside of our, let's go inside of our game methods inside of utils. Let's do Control P and then search for game methods. Right here, so we have the function player is within range. This takes in a position index. It compares it with the position index of the the player, and it checks if it's smaller than or equal to max reach, and if it is basically just within this radius, or it returns true, and if it's not, it returns false. So let's just implement that inside of our zombies. So here we'll create a new function for this. So void check for aggravation or something like this. And let's go down here, and we're just gonna do if game methods dot instance dot player is within range, and then we'll pass in for the position index, we'll pass in the position, and we'll divide that by our actual block size. Or we can use another method inside of a game methods called get chunk index, not this. Let's search for index. So get index position from pixels, and then we can pass in position right here. Right, so we're checking if the player is within reach to the index position of the zombie, and we're getting the index position through the get index position from pixels function. Right, and if it is within reach, we'll basically just set is aggravated to true, and if it's not, we'll set is aggravated to false. And we only want to do all of this logic if is aggravated is true, right? So only if the player is within reach of the zombie. So the zombie, if the zombie detected the player from like 50 blocks away, it wouldn't like spend all of that performance and that time getting into the player, and it'll be like super hard and stuff. So we'll check if the zombie is aggravated, only then do this logic. Right, now let's all restart our game. And okay, we have the zombie and it's not approaching us because one thing we did not call check for aggravation inside of our update. So it's always being set to false. So now it should be updating. And let's go away from the zombie actually. And now if we go close to the zombie, it follows us. But after we leave that range, it stops following us. Cool. Right, so this is way more balanced since our game is in 2 dimensions. Right. And here we'll now change it so that let's first go inside of a sprite sheet of the zombie. And now we'll make it so that it plays in different animation based on if the zombie is aggravated or not. So if the zombie is aggravated, it will be moving. So we want to play this animation. And if it's not, moving or not aggravated, we want to play this animation where the zombie is actually looking at the screen. Right. So let's go inside of a zombie dot and let's define another sprite sheet. Let's just duplicate this down. Actually, we don't need another sprite sheet. We'll call this just zombie sprite sheet. And we'll define a few animations like sprite sheet. Okay. So here what we've done is we've set the animation to, which is of type sprite sheet animation to our create animation method on our sprite sheet with our row as 2 and step time as 0.2. So let's actually remove this and we'll create a variable, a global variable in here called sprite animation, or we'll call it walking animation. That same thing. So zombie sprite sheet dot create animation, the row, it was the second row, and then step time 0.2. Right, so this is the walking animation. Now if we set the animation to this, nothing should change because this is the same thing. We just created another sprite. What we did was we just created a new variable for this animation and then we set it to here. And now we'll duplicate this down by holding Shift Alt, then down arrow key. And we'll call this idle animation. And this will be the 0th row. And now if we hot restart our game, we shouldn't see anything different with our zombie. And we're just doing this to check if it actually works because we changed some things in the background. And okay, so the animation actually plays, so it works. Right, and let's try changing this to idle animation. So we get something kind of trippy here. So the zombie just, sometimes appears and then disappears. This is actually intended because, actually not intended, but it should be happening because we implemented it wrongly because it's iterating through each grid inside of this row. So this grid, this grid, this grid, this grid, and then back to this grid. And since these grids are empty, it's not displaying anything where something should be displaying, right? So let's change that. Let's go inside of our zombie again. And we won't be exactly using the create animation to create the idle animation. But we'll use sprite animation dot sprite list. And inside here, we can pass in a list. And inside this list, we'll pass in one single sprite. That will be the first image right here. So this one. So we'll use our sprite sheet to get this image and then we'll create a sprite and then we'll add that to this list. So we use this exact same method for our item component. So down here somewhere, actually up here, is that our item component. Inside the animation, yeah, we used sprite list, sprite animation dot sprite list, and then we passed in the actual list of the actual sprite. Right, so that's exactly what we're doing right now. So to actually get the sprite, we can do sprite sheet, or what's the name of our sprite sheet? The zombie sprite sheet. And then we do get sprite, and then the row is a 0th row, and the column is also the 0th row. And then the step time will be 0.2 again. Right, now let's see if it works. And it does. So we just created this animation in a different way using sprite animation dot sprite list. And the sprite list basically just, iterates through each sprite to create the animation rather than each grid of our sprite sheet. And then we're getting the sprite by passing in 0, 0, because inside of a actual sprite sheet, the actual sprite that we want lies in the 0th row in the 0th column. Cool. So now let's make it so that it displays this when the player is not aggravated, and displays this when the player is aggravated, or actually the zombie is aggravated. And we can know that inside of a check for aggravation. So if it is aggravated, the animation should be walking animation, and if it's not aggravated, the animation should be idle animation. Right, and we'll default this to be the walking animation, or okay, I guess the idle animation is fine and it makes no sense. Right, now let's all restart our game. Okay, and if we go out of its reach, as you can see, it displays the idle sprite sheet. So okay, let's go here now, and yeah, so it's displaying the idle sprite sheet or the sprite animation. And if we go here into the reach, it's displaying the walking animation. Right, so that's working. Now let's make a zombie attack the player with a cooldown every time it collides with the player, just like now. So we'll make it so that it damages the player every 0.75 seconds. So we want to harm our player or inflict damage on our player every time a hostile mob, or just a zombie for now, comes in contact with the player, right? Like right now. So this will be logic done inside the on collision. And okay, so let's go all the way up here. Right, so we'll do it here. And we'll have another if statement for this. So this if statement is just for all of the block collision and stuff. So block collision, and what's down here will be for our other collisions. So if other is a player component. So if you forgot, other is the callback that gives the instance of the actual thing that's colliding with the player, or with that or this component. For example, if the zombie comes in contact with a block or collides with a block, it's going to pass a block component as other. So we can access everything inside of a block component. So here we can do other dot health, idle animation, and all of the things inside of the player. Like here, see, we have everything that we defined. So here we can just do if other dot health, or actually other dot change health by, and then we'll give a negative value of some sort, like -1. So that should be it, right? Yeah, let's hot restart our game. Okay, so oh my god, we suddenly died. Let's try that again. Let's kind of try to escape it. Okay, I don't think the zombie can follow us here. Okay. Right, so it's doing constant damage to us. Like there's no limit on how much it can actually change our health by, right? There's no cooldown. That's because it executes it every time it's in collision with the player component, right? So we need to put some sort of actual cooldown, just as we did for jumping. So let's define an entirely new variable called boolean can hurt or can damage. We'll set this to false and we'll set it to true each 1.5 second. So, or let's make it each 0.75 seconds. 0.75 seconds. And here we'll set can damage to true. So we have a value that will be set to true each 0.7 seconds. So we can use that as a cooldown. Oops. And here we'll only damage the player if we have can damage. Right? So this will only happen once every 0.75 seconds. And after this has happened, we'll set can damage to false. Right, so now that should give us an actual cooldown. Okay, so now we're like losing hearts a lot faster, actually a lot slower. But we're actually regaining them back too because of our regeneration. Yeah, let's actually try losing some hunger points. Just we gotta wait for that. But it's damaging us a lot slower. Yeah. Now let's add knockback to our game so that the zombie will actually change the position of the player based on which direction it is colliding the player in. So if the zombie is in the right and the player is in the left, it's going to move the player to the left. So that is knockback, right? So adding knockback is really easy. We basically just want our player to move in the opposite direction that the zombie is in. For example, if the zombie is in the right direction of the player, we want the player to move to the left. And if the zombie is in the left, we want the player to move to the right. And that is when it damages the player. And how do we actually make our player move? Of course, with the move method that we can access, that is for our player inside other dot move, right? And for the speed will be the actual distance that we want our player to travel. So let's make this something relative, like half a block or 60% of a block or something. So every time the zombie attacks a player, this will be the knockback. Game methods dot instance dot block size multiplied by 0.6, so block size dot x. And the dt, let's just provide in like 1 by 30, it doesn't matter. We're just replicating our frame rate because it's usually around like 30 fps or maybe 45 or something. And the component motion state will be the direction that we want it to move in. And this will be based on the zombie and the player's position. So let's go down into a zombie logic. And let's copy all of this. Just this. And let's go up here. And let's paste this. Now inside of here, we'll check if the zombie's position. So position dot x. So if the zombie's x position is greater than the player's x position. If yes, we want it to move to the left, right? If the x position of the zombie is greater, it means that the zombie is here. But right now, the zombie is in the left side. So the x position of the zombie is less than of the player's. Okay? And so if this is the case, okay, we want the player to move to the left, right? So the zombie's x position is greater than the player's x position. So move to the left, component motion state dot walking left. And the inverse of this will be component motion state dot walking right. Cool, so that is it. Let's out restart our game and see if this works. Yep, and it does. We're being driven around by the zombie. Cool. Now about here. Yes. Right. And, eventually we might have tons of stuff here. So we don't really want to do all of the logic inside of the on collision because the on collision is just for detecting logic or not logic, collision. So let's create a new function that will actually deal with all of these. So let's go here. Under void update, it doesn't matter where you do this, but let's just create a function called inflict damage to the player, right? And here we'll just put everything that we just did. So from the if can damage to everything. So let's just paste this in here and call inflict damage to player up there. And we also need the other, which is going to be a player component other, right? So now we'll just call inflict damage, inflict, and I probably spell it wrong. Let's see. So it's inflict. Why are we not able to access it there? And never mind, I can. My bad. Now let's restart our game and everything should be working the same. And it is. Cool. Now let's make the player turn red every time it actually takes damage. Now if we go up to a player sprite sheet, we see that there is a separate row which is the exact same as most of the rows, like same in player idle sprite sheet, yeah, but with a red color. So this is the animation that we want to display when the player is currently hurt. So we'll set a boolean value called currently hurt to true every time something damages the player. And if currently hurt is true, we'll switch over the normal animations to be its alternate red colored animations, which we want to play when the player is hurt. And we'll set is currently hurt to false each second with a timer, so that once hurt it doesn't always turn to red. Okay, so let's go into our entity actually. Inside of our resources entity, and we'll add the actual variable here. So boolean is current, or let's just call it is hurt, and we'll default this to false. And a good way of knowing every time something is hurt is by going inside of a change damage or change health by function. So we're only actually changing health through our change health by function, rather than directly just setting the health to some value, right? So every time this actually happens, we know that the player is actually being damaged. So here, let's check if the player's exactly being damaged, because this can either be used for damaging the player or healing the player. So that's pretty easy. If value is a negative value, or if value is smaller than 0, then the player is, the intention is to hurt the player, right? Or the entity. So we'll set is hurt to true. Right, so every time some sort of damage is gonna happen to the player, is hurt will be set to true. And we want to set it to false each second, or each maybe half a second. So I don't suppose we have an onload here. So let's create one. Override. Future. Void. Onload. Asynchronous. It's also called super.onload. Right? So now we'll add that timer component inside of our entity. So timer component, and the period can be like 0.5, so half of the second. So every half second is hurt will be set back to false. So if the zombie attacks the player, it'll momentarily turn red, and then after half a second it'll go back to its original state. So, and we'll set the repeats to true because we want this to happen over and over again. And on tick, we'll just set the is hurt to false. So is hurt equals false. Now before everything, let's just go into our play component and then display this value. Where's our play component? Yep, here. And inside of the void update, we're just gonna print is currently or is hurt. Right, let's hot restart our game. Let's quickly move away from the zombie when we spawn. Okay, so right now is hurt is false, right? And let's actually wait for the zombie to hit us, and it just hit us. So is hurt is true, so we get occasional trues. That's from that if statement. Cool. Now let's remove this and then make our animation change according to if is hurt is true or false. So first we need to define the actual animations for all of that. So we have walking animation and idle animation, but we want the hurt variations of that. So here this will be the idle animation is taken from the 0th row, and the hurt animation will be taken from the first row. So let's do that. Inside of the play component, just gonna duplicate this down. Let's hold shift alt and then the down arrow key, and let's call this the walking hurt animation, and this will be the first row. Same thing for the idle animation, the second, or again the first row. So idle hurt. Cool. So before that, let's actually test out our actual hurt animation. So let's go to the areas where we are actually setting the animation inside of the void update. Okay, so here we'll change the walking animation to walking hurt animation and everything to hurt. So idle animation, idle hurt animation. Okay, that should be good. Let's hot restart our game. So now the animations that usually play should be the hurt animations. So yeah, the red variations. Cool. Let's revert this back to its original state. So the normal, so idle animation, walking animation, and walking animation. So here we'll put in a statement. So if the player is hurt, so everywhere that we're actually setting the animation, we'll check if the player is hurt. If the player is hurt, we'll play the hurt variation of the animation that we were going to set. So here, what did we want to do again? Okay, so this is for our walking animation. Here we'll check if the player is hurt, right? Meaning something has damaged the player. We're going to set this to the walking hurt animation. And if it hasn't, to the normal walking animation. Cool. And let's paste this in here. And here too. This is for the idle animation, so we're gonna have to change this. So idle hurt animation and the normal idle animation. Let's not restart our game. Okay. And yes, so now every time something damages the player, it goes on to its the hurt animations. So even that also happened when the player took some fall damage. So let's actually build up a few blocks, right? And let's try to fall off. And yeah, as you can see, their animations still play. Now let's do it for the zombie. So let's go into our zombie dot. Now let's create spiders. Spiders won't be any different than a zombie except for a few places. Now I'm gonna show you what I mean by that. Now, okay, let's change the dimensions to 131 and 60. These are the dimensions for our spider sprite sheet. So this one here. Yeah. And let's go down to the zombie again. And we'll simply change the spider sheet zombie to not spider sheet, sprite sheet spider. Right. And this is what's mainly going to be different, nothing else. And we'll add like extra logic so that the spider will be able to climb through stuff, but other than that, nothing's different. So, okay, we forgot to actually load it inside of a main game. So, actually, you guys don't have to do this, but maybe load it. I'm just doing this to actually demonstrate. So, Shift Alt, down arrow key, sprite sheet, spider. Let's not restart our game again. Okay. So, yeah, we've got a huge spider. It just fell through the wall because I think it was too big. Let's see that again. Okay, that's it actually for a spider. So it's it would like just work like a normal spider. It would move, it would take damage. I mean, it wouldn't take damage because we still haven't implemented that. It would follow the player and stuff. So what's mainly different is just the path and a few functions that we can actually change. So let's go up to a zombie again and revert this back. So zombie, and then yeah, what we're going to do is just as we did for a class somewhere here in the resources. Yeah, so first for our entity, what we did, because we were creating new things, right? Like other than a player with the base functionality like collision and stuff. So what we did was we copy pasted all of that code inside of player to entity, and then extended player with entity so that we'd get all of that same code inside here, and with the added extra advantage that you could create new classes that could extend from entity. So the same way, we will create a new file called hostile mobs or hostile mob dot, and this will have a class called, actually let's call it hostile entity, and this will have a class called hostile entity again, and it will extend from entity. And now inside of zombie, what we're going to do is we're going to start copy pasting things. So let's click on this split editor window here, right here, or the icon, and then while having the right side selected, let's click on hostile entity. So in the right side we have the hostile entity. Cool. So the dimensions will be a part of hostile entity. So okay, before that, we want to take in the path of the sprite sheet from the constructor of a hostile entity. So we'll have a final string path, and we're going to require this from the constructor. So required this dot path. And why do we have this here? So we'll have walking animations and all of these animations, same for everything. So we're gonna wait, let's paste all of this in here, right? And oops, we forgot a semicolon here. And what we're going to do is we're simply going to change this and replace it with path. So we get the same kind of sprite sheet like walking animation or idle animation, because all of the formats are the same, right? So if you quickly go up to the sprite sheet inside of mobs, you'd start to find a pattern. Like we have the idle hurt, walking hurt. Same here. Inside our zombie, gotta wait for this to load. So the idle hurt, walking, and walking hurt. Again, the only thing that's different is the path and the actual grid size. So let's also take in the grid size, which is a vector 2. Let's call it src size, vector 2, or okay, src size. I'm pretty sure it's scr size or something, but whatever, it doesn't matter. Let's require that too. This dot scr size, and we gotta import all of this from sprite sheet, flame, etc. And for the dimensions, we put in src size. Okay, now it was indeed src size. Now even okay, so if we put the src size as 6799 and pass in this path, we'll get the walking animation and the idle animation for the zombie, right? And if we give a different src size for the spider and give the path such as that for the spider, we'd get the walking animation, idle animation for the zombie. Not the zombie, the spider, right? And now let's copy all of this again. This will be a part of hostile mob because it's not specific to a zombie. because we want this to happen for all hostile mobs like spider. And we're gonna import all of this, inflict damage on to the player. Pretty sure that's a function inside here. Can jump, can damage, is aggravated, all inside here. Yep, this onload too. Let's actually start cutting things. We don't really want those there, right? And okay, let's paste this in here. And since we already added this inside of our host entity, we can remove this. Same for all of this. And let's actually call this a sprite sheet and not zombie sprite sheet, because this will be specific to all the mobs and not just a zombie. So, sprite sheet. Okay, cool. Now in the update, okay, other than the zombie logic, we'll have everything inside here. So let's just copy paste this. Actually, let's leave the updates to be figured out for the hostile entity. For example, maybe we are creating a super unique mob which doesn't have falling, so maybe it's a levitating mob or a flying mob. So we wouldn't want to add the flying logic inside of the update, but we'd want all of the things here. So let's not exactly create the update here. Inflict damage to player should be inside the hostile entity. First, this will be something in common to all of the hostile entities, because we want all of those to do damage. And it seems can damage. Okay, we cannot use can damage. So I'm pretty sure we did define it. Yep, we did, but that was inside the function. Oops, we accidentally defined this inside of the on collision. So let's define this outside. Right? Import rectangular hitbox. And import all of this. Game reference, component motion state. And let's remove the brackets. And game method. Oh, sorry, that was global game reference. Cool. Now check for aggravation. This should also be a part of a hostile entity. So just think of it this way. Do you want a spider to do the same things? If yes, transfer it from zombie to hostile entity. And zombie logic? No, zombie logic is something specific to a zombie, so we don't really care about that. And dimensions, same. This is also something specific to a zombie. So yeah. And what we're gonna do is we're now gonna extend from entity, but with hostile entity. So this fixes up most of our issues, because we have all of those inside here. And then we'll change this from dimensions to src size. So right now, this is the same thing that we just had before we split the functions into a different parent class, because we have all of those same functions just inside this working environment. Now we need to provide in the path and the src size, because it does not know what kind of animation or which kind of image it should use as a sprite sheet. So we're gonna do zombie, then colon, then super, or we can just do, okay, never mind, colon super, and we're gonna do okay, path as, let's copy the zombie sprite sheet path and paste it in here. Now the scr size or src size, this was vector 2 6799. So that's it. So what did we do again? We split all the functions that will be a common for most of the hostile entity into the hostile entity class, right? Like the dimensions, path, animations, the collision logic, the can jump, can damage, is aggravated. So these are all things that we'd want for different hostile mobs when we add them in the future, like a spider or something. And we extended zombie from that entity or that class instead of just entity. And then we're simply, the only thing that's inside of here is just for the size, so let's actually save all of this and then close everything. So the only logic we have inside of a zombie right now is for the size changes, the actual zombie logic, and then the update, right? So everything else is actually you know way better implemented. So if we wanted to create a spider, what would we do? We simply create a class called spider, extend it from hostile entity, give it a texture path and a src size, then just we'd work on the logic, and then we add some stuff that we want our actual component or a zombie to do, like falling, killing, jumping, etc. Right, it's that easy. And dimensions.y again to src size. So now if we hot restart our game, nothing should have broken, even though we changed tons of stuff in the background. So taking a time to hot reload because we did tons of stuff. And right, so we get a zombie, we don't get any errors, so that's cool. Right, it's aggravated is working, and it can also knock back the player. Right, so everything's working. Now let's create a spider. The spider will also be a hostile entity, meaning it'll attack the player. So the cool thing about a spider is that it has the ability to actually climb through barriers. So just like it did right now. Cool. Okay, so let's create a file for it inside of mobs. Spider dot. And this will be a class called spider, which will extend from hostile entity. Right. And we need to provide in the path and the src size for the texture, right? So we're gonna have to do it in the constructor. So spider, but not our spider's constructor, but our parent constructor. So super, and here we need to pass in the path. So let's go up here into our actual sprite sheets and then into the mobs and here. So this is our spider sprite sheet. Let's copy its relative path and add it here. Slashes and here. And now for the src size, this will be the size of each grid of our sprite sheet. So it's 67 in width and 99, actually not that, it's 131 in width and 60 in height, right? So completely different from a zombie grid. Now before you actually add this in here, make sure that you have loaded it up inside of the main. But I have, and I'm pretty sure we have. So yeah, sprite sheet mob slash sprite sheet spider. We'll make sure you have that or it's going to give an error. Now let's copy and paste everything inside zombie, and I mean everything. So from the update all the way down to the on-game resize. We've made our lives a lot easier for us by implementing a hostile entity. So it's way more cleaner. Okay. Now in the update, we're gonna remove the zombie logic because we want to replace that with actually let's not entirely remove it. We'll change the name to spider logic. Change this to spider logic 2. And here we're gonna import global game reference first of all, and component motion state, player speed from constants, and game methods. So this logic, all of this is actually just to follow our player, right? To, the zombie or the spider in our case now is gonna try actively hard to avoid all of the blocks and then get to the player. But the only thing that will actually be different for a spider is the jumping part. We don't want the spider to jump, but climb, like constantly jump. So climbing is the same as constantly jumping. We'll get that to that a bit later. But for now, let's fix up the size. So as we know, the responsive size is the current src size, which is the each grid of our hostile, not a hostile, a sprite sheet. So that'll be our original size, but we don't want that to be the size. We want it to be exactly of the, let's say we want a spider to be as tall as one block. So game methods dot blocks dot x or let's just put y for better readability, doesn't make a difference, divided by src size dot y. And so the size that we want divided by the size that we currently have multiplied by the size that we currently have again, right? And let's hot restart our game, and let's actually add an instance of this to main game, just as we did for a zombie. We're gonna add a spider. Let's see if this works. And it does. So we have a spider. Cool. And now the spider is not aggravated, so it's in its idle animation. Let's actually put a barrier around the spider. Let's draw them in here and put a barrier here. Okay, so when this happens, they just try and jump, but they wouldn't be able to make it. But we want a spider to be able to climb through this, right? So that will be the advantage of being a spider. So let's do that. Okay, so the only thing that'll be different is that we won't be using jump to do it, but it'll be somewhat similar to jump, except we won't be checking for a bottom collision. See, we ran into this bug loads of times because we forgot to actually set only jump if the player is colliding at the bottom, or if the entity is colliding at the bottom. We didn't set that if statement, so what happened was, if anything came up, the player or the entity would just go straight up it, because there was no limit to the actual jump force. So that bug is going to be the fix to our solution, or the fix to our problem. So we're going to multiply this by 0.4 or something, because we don't want it to be that quick, because it already has this huge advantage of being able to climb through stuff. So we don't want to make it like even better or faster or anything. So this should do it. So if the move wasn't successful, or when it should climb, it's just going to set the jump force to some value constantly. So the y value will decrease, and that should be it. Let's go somewhere. So spider is still not able to exactly come through, because okay, let's see what the issue is. So we are setting the jump force to a value that's always constant, or setting it to some kind of value constantly every time it wanna jumps. So the only probable happening could be that inside entity we have set some logic inside of a jump logic. Okay, so here is our jump logic, and there doesn't seem to be anything restricting a spider's constant jumping. So oh, okay, so obviously we have a cooldown here. We don't want the cooldown, so we don't want to implement the can jump, right? So that is a problem, because the spider's only able to set the jump force to 0.4 every 0.75 seconds, right? We want to do it constantly, which would make it give the effect of climbing, right? So, and as you can see, the spider is able to climb, but something just happened. It automatically disappeared. I think that's a bug. Let's figure out what's happening. Let's do that again, actually. Okay, so let's figure out what the bug was. First, let's go into main game and then remove the instance of the zombie, because we don't really need that right now. And we'll add the spider inside here. So only after 1 second after the game has loaded up. So we'd have a little time to prepare everything. So, okay, cool. Let's put up a barrier and see if it can climb through it. And it can, but once it just went down, it disappeared. So that was probably because of fall damage. So okay, we'd make it so that the spider does not take fall damage. So let's go into our spider here and into the hostile entity, then into entity. So inside of the falling logic, or here, when the entity actually collides with the bottom, so with bottom collision again, Okay, right. So here's the logic for actual falling. So we'll only do this if we have a value set to true. Like let's say bool do fall damage. We'll default this to true, and only if this is true, we're gonna do fall damage. So if blocks fallen greater than or equal to 3 and do fall damage. So now everything should be working fine for a player. We should still do fall damage because it is defaulted to true. But for a spider, what we're gonna do is we're gonna define it here that do fall damage, or we can set this inside of somewhere. Okay, let's do that inside the constructor. So curly braces, and I guess we can't do that exactly there. So curly braces do fall damage equals false. So the spider won't do fall damage. Let's remove the semicolon. So what did we do? So this is the constructor. So it's the same as what we do here usually to get what's inside of here. Like this gets called every time an instance of whatever the class is gets created. So at the beginning, it's gonna set for fall damage to false. So the spider won't take fall damage. So let's see if that works. Go here. Make a barrier again. And now if it touches the ground, it shouldn't exactly die, and it isn't. Cool, but it still isn't exactly climbing, so we've got to fix that. So inside of our spider again, here. So the problem is that we are setting the jump force to something, but we're not incrementing the jump force. We're going to do plus equals. So, let's say we're setting the jump force, let's say this value is 50. So every frame, we're setting it back to 50 and not adding 50 to the existing jump force. So plus equals to will fix our problem. And let's go here. And it is, able to climb through it. Let's break all of this. Okay, now it's okay. Now it has passed that, so it can actually climb through stuff. Let's see that again with a bigger barrier this time. All right, it is able to climb through stuff, but that's like super fast. We don't want it to be that fast, so we're going to change this to something like 0.1. Right, now let's make a barrier again and test it out. Okay, now it's like too slow kinda. So I guess we're gonna have to put it to some reasonable value, maybe 2.5 and 2.5. Let's not restart our game. And again, there's a lot of testing involved. It's not always like you'd get the right values every time. So yeah, and let's build up a barrier again. Let's see, spider. Come on. Okay, so crawling is working. Now let's make it so that the mobs don't exactly spawn at 0, 0 and then fall their way into the ground. So we'll first select a random chunk either at the left or the right of the current player chunk. So if the chunk index of this were 3, the left chunk would be 2 and the right chunk would be 4. Then for each mob, we'd pick a random x value. So from 0 to 16, so 0 to the actual chunk index. Then we'll iterate from the top and see and iterate till we find a block that is actually collidable. And if it is a collidable block, we're going to be returning a vector 2 with the x as that random x value that we just found and the y as the actual index of that block. Okay, so first things first, let's create the spawn index position field, which will be a vector 2 spawn index position, and this will define the actual index position that the mob should spawn in. For example, spawning is basically just appearing, just like how we're spawning a zombie or a spider inside of our main game by doing add, that's what we call spawning. So anyway, the spawn index position will just like, just be like the index position for our block components. So yeah, let's require this. And we're doing this inside hostile entity because now it will apply for both the zombie and the spider and all new instances of hostile entity that we create. So this dot spawn index position. Now we have to require this from the constructor of a spider and zombie. So, one thing we could do is define fields like vector2, spawn index position, and then require that inside a spider and then pass in it to the super. But that's kind of tedious. And then we'd also have to take care of some overriding issues because we cannot have two different variables inside same variables or same variable names. Have the, we cannot have two variables having the same name. Yeah, so another way of doing it is by doing required inside of the spider constructor super dot spawn index position. So we are directly requiring a field inside of a parent with the constructor of the child, right? And we can do the same thing for the zombie. So let's paste this in here. Cool. And yeah, now let's go inside of main game into our area where we are actually adding the spider, and then let's give it a spawn index position. So to see if this works, let's give it a vector2 of 0, 10. So 10 blocks from the top. So now it should spawn at the bottom or maybe inside the ground or something. So currently it was just spawning at the top, right? But it didn't. And okay, that is because we didn't actually implement anything to do with it. All we're doing is we're getting a value called spawn index position where we want our mob to spawn, but we're not doing anything with that position. So let's go inside of the onload here, and then we'll set the position to, okay, so inside of a block component, what we're doing is, okay, let's go into a block component here. To actually get the position inside of the on-game resize, we're multiplying the actual block index with our block size. So that will give us the our position in pixels. So let's do the same for our hostile entity. We're going to do position equals spawn index position multiplied by the block size. To get the block size, we'll do game methods dot instance dot block size and dot x because this is a vector2. And now let's hot restart our game, and now we should see the actual implementation of a spawn index. And as you just saw, the spider appeared on the ground. So somewhere it usually just falls from the top, right? Let's try that again. It should appear right on the ground, and it did. Cool. Now if we make it 11 rather than 10 inside of our main game, it will spawn one block underneath. So 11. Now this would definitely break some things, but let's see. And yeah, as you saw, the spider appeared here and then, came back up. Cool. So that's the implementation of a spawn index position. So we can do our logic and then provide in a spawn index position. So let's actually add the logic that will find our mob spawn index position. First things first, we need a zoomed out view of our world. So let's go inside game methods, inside of utils, into our block size, and we're going to be returning vector2 dot all 20 or 30 whatever instead of our usual responsive size. So now what should happen is that all of our blocks will be small and all of the positions will be small. Okay, now we can see everything really clearly, right? Cool. So now we want to create a function that will pick either the left chunk. Okay, so let's say this is the chunk that the player is in, the current chunk. So we'll create a function that will pick either the chunk on the left of this chunk or the chunk on the right of this chunk and then spawn a zombie there, because we don't want our zombie to be spawning in the direct view of the player, because it'll be kind of weird for an entirely new thing to just appear out of thin air. So we'll make it spawn somewhere here or something, and eventually when the player goes there, it's going to encounter that zombie. Cool. So first we'll create the function, and it's going to pick either the left chunk to the current chunk or the right chunk to the current chunk, and then it'll pick another random position that will be a value from 0 to a chunk width. So let's say it picked out this chunk, and then we want to pick out a random x value for the zombie to spawn in, like here, 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 or here. And then what we're going to do is, after we have an x value, a random x value picked up, we're going to iterate to the bottom of the chunk. So we're going to start here. We're going to check if the zombie can spawn here. So there is no block, so the zombie can't spawn there. We'll go down again. No block, zombie can't spawn. We'll go down, still no block, and it'll eventually come here. And then we also want to make sure that the zombie won't spawn on top of uncollidable blocks. For example, if there was a tree here and the zombie spawned on top of that, it would fall and then take damage, right? So we don't want that to happen. So it'll check, we want to check for blocks that are collidable. So it'll go down till our sand block, which is the block that the zombie can spawn on. And if that is possible for the zombie to spawn, it's going to return that position as index position. So with the random x value that we selected and the y value that we just got from iterating through all of the blocks at the y-axis. Cool. So that was kind of complicated, but I swear it's not. Let's go down here and then create the function for it. So it will return a vector2. So we'll have a vector2, and let's call it get spawn position for mob. Right. And now first we want to either pick the chunk to the left of the player or the right of the player. So we first need the chunk indexes, right? The chunk index is like 0, 1, 2, 3, 4, 5. So if this was the second chunk, we'll know that we can actually get the chunk to the left of that by doing that chunk index -1, and then that to get the chunk on the right of this, we'll do this chunk index +1. So to get the chunk indexes, we're going to do the chunk indexes will be a list, and let's call it chunk indexes. Oops. And to get this, we have this property inside of global actually our world data. So global game reference dot instance dot game reference, and now it's like we're inside main game, and then we can access the world data where we actually have all of the currently rendered chunks or the chunks that should be rendered. Let's use the chunks that should be rendered, or we'll actually use the currently rendered chunks. And to get the chunk on the left, we'll do dot first. This is a list of 3 values. Okay, so all of the chunks that should be rendered. For example, if the player is in the second chunk, currently in the second chunk, we also want the first, the second, and the third chunk to render, right? That's how we're doing things. So we either want to spawn it at the first one, so the 1 chunk, or the third chunk, or the last chunk. So how do we actually make that random? Easy. We'll use the random class again that we already have inside Flame. Not Flame, I think this is in Flutter, and it probably is. So anyway, we're going to do random.nextBool, which either returns a true or false. So now we can add a ternary operator by putting a question mark. So if this is true, it's going to do this. If it's not, it's going to do whatever's at the side of a colon, right? So we're not going to do list of chunk indexes. We'll just get the chunk index. This will either give the left or the right chunk of the, relative to the player. So currently rendered chunks dot first will return the chunk to the left, and currently rendered chunks dot last will return the chunk to the right. Cool. So now we actually have a chunk index, or the chunk value that we want the mob to spawn in. So we have done till our part of choosing either the left or the right chunk. Cool. Now let's actually get the chunk from this chunk index, and that is pretty easy. We can just do get chunk, and then pass in the chunk index. This will return a chunk, and just if you have forgotten, a chunk is of type list with rows of lists, or rows of blocks. So list of lists of row, right? And let's call this chunk, right? And we seem to have a problem here. Okay, not a row. Oops. Type blocks. which can be nullable. Right. Now let's pick a random X position for the zombie to spawn in. So let's say we have this, okay, let's say we have this right chunk selected, or we got the right chunk from this logic here. And if we got the right chunk, what we want to do is find a random X value. So let's say let's say the chunk started from here. So if the random X value was 0, it'll be here. If it were 2, it'll be here, 3 here, 4 here, and so on. So we want to find a random X position, and that is pretty easy too. We can again use the random class. So we're going to do, and this is going to be an integer. So integer, and let's call it spawn X position. And this will be random dot next int, and we're going to give a max value, which will be chunk width. So this returns a random value from 0 to the actual value provided into the function. So if we provided in 10, it would find a value between 0, greater than or equal to 0, and smaller than 10. So if we provide chunk width, it's going to get a value from 0 to chunk width. So if it was 0, it'd be here. If it was 16, here or there or somewhere. Cool. So now we have a way of getting a random X position. Now we want to figure out a possible area where the zombie can actually spawn. So let's say we got this Y or this X, and then we're just going to be iterating through all of these rows of blocks into the same X, and then we're going to check if it has a block that the zombie can spawn on. So a collidable block, and then if we reach a block, we're going to return the index of that. It's that easy. So we need to iterate through each row of blocks inside of us, inside of our chunk. So let's do a for loop. So we want to start from 0. Let's say row of blocks index equals 0. We're going to do this, or we're going to do this until we reach the end of, the last row of blocks, which is the bedrock. So to get the index of that, we're going to just do chunk.length. And then we're going to do row of blocks plus plus. Now we have a value that will go from 0 to the chunk height. So whatever the chunk height is, let's say this was 20, then the chunk height will be 20. So it'll go from 0 here, and let's say this is the 0th X position that we got from a random function. And if this is 0, we'll check if the 0 of this row of blocks is, has a block. If it doesn't, we're going to go into the next one. If that has a block, we're going to return that. But if it does not, we're going to go here and so on till we actually find a block. So to actually get the current block, we're going to do block. And this can be null because it can be an empty space, right? So blocks current block, or we're just going to put an if statement and check if the chunk of, first we need to point to the row of blocks which we're iterating through. So row of blocks and row of blocks index actually, and then the random X position that we just spawned, or that we just found out by doing random. And so now we'll get an actual block. And we'll check if this block is actually a block. If it is actually a block, and then it is collidable. So we also need to check if it is collidable. Okay, it's not equal to, it's actually is. So we want to check if this is of type blocks, then we use the is operator. And now we also want to make sure that if that block is collidable. So let's copy this and then do block data dot get block data for, and then pass in this block, then do and then pass in this block, and then do dot collidable. So if it is collidable, then we're going to be okay. Before that, let's have an integer spawn Y position, and we'll set this to 0 just to default it. And then inside here we'll set the spawn Y position to our row of block index. Let's add an exclamation mark here because it could be null. So what exactly are we doing? So we're first fixing on an X value. So let's imagine that it's this one. And we're starting at 0 and going till chunk height. So at 0, we'll first check in the first iteration that if this block is a block and it's collidable. So it's not a block. So we're going to go to the next one. Is this a block? Nope. Next one, next one, next one in here. And now finally here, it'll go in here and check if it is a block. It is a block. And then it'll also check if it is collidable, but it's not. So it'll go again down here. Is this a block? Yes. But is it collidable? No. Now finally here, this is a block and it is collidable. So this row or this row in the Y, so let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If this were 10, this will be the, the row of block index will be 10 here. And where was that again? Spawn. Okay, yeah. So the row of blocks index will be 10 here, and then we're simply setting the spawn Y position to that. And at the end of everything, let's simply return a vector 2 of our two values. So one, our spawn X position, and this is of type integer, but vector 2 only accepts double. So we're going to do dot to double, and then the Y position. So spawn Y position that we just found out, and dot to double. So we'll get the index of the first actually spawnable block. Right, cool. Now we have to take care of one more thing. Now this is something that will be global. Like if the spawn X position is 0 and then let's say the Y is 10, it doesn't always mean here. If this was the starting point of this chunk, 0, 10 would be this here, but it's not the 0, 10 of our entire world combined. So if we were spawning something at 0, 10, it would spawn here at the actual 0, 10, not relative to a chunk or anything. But we want to make it spawn somewhere that's relative to a chunk. So we're simply going to go here. Oops, lost it. Mob. Okay, we're just going to be multiplying the spawn X position. Actually, we're going to be adding this to a value of chunk index multiplied by the actual chunk width. So if the relative position was, let's say, 4, so let's say we've picked this chunk here, and if we wanted to spawn the relative fourth one, so 0, 1, 2, 3, 4, if you wanted to spawn here, it wouldn't exactly spawn it here, but it would spawn it at the actual 4x of our entire game combined. So 0, 1, 2, 3, 4, so here somewhere. But now we are also accounting in for the chunk index. So if this is the second chunk index, what it's gonna do is it's gonna add 4. Again, lost. How do I keep losing it? So it's gonna add 4 to the chunk index, which is 2 multiplied by chunk width. So it's gonna add 4 to 32. So we'll get 36, which will be that exact position where we want to spawn it in. Right. So that should be it. Now let's go inside of our main game. And then for the actual spawn index, we're going to pass in game methods dot instance dot get spawn position for mob. Right. And one more bracket. Cool. So now let's restart our game and see where a spider spawns. So our spider should spawn at the surface, but it doesn't exactly. It spawns on the bedrock. Okay, so something's definitely wrong. Let's go inside of our game methods and then figure out what we did wrong. Again, we lost the function. How do we keep losing it? Okay. So, oh, all right. So after we actually find, okay, so we want to return, we want to spawn the mob in the first actual spawnable position. So if we had a grass block here, it'll iterate from the top to here, and then it'll choose this as a spawnable position, right? Then it shouldn't go down again because we already found a position. Why would we need to go and check for more spawnable position? So, or positions. So if we actually found a position, we want to break out of this loop, right? So that is why it was spawning on the bedrock. So let's see that again. Okay, cool. So the spider spawned on the surface and it picked the right chunk, and then the X random X position was something like 5 or 6 or 7 or something. So what exactly happened here? It went inside the get spawn position for mob. It picked a random chunk index from the chunks that are currently rendered. So in our case, it chose currently rendered chunks dot last. Then it got that chunk. Then it generated a random X position. So 0, 1, 2, 3, 4, 5. So I think it got 5 when we did this actual random thing. And then we defined a spawn X position, actually a spawn Y position. And then we set, okay, and then we actually checked from the top, and then we went down till we found a block that was collidable. And then we returned the Y index position of that, and we spawned the mob in here. Now let's do that again. Let's already start our game. Now it should pick more random values, and yep, now it's there. Let's actually go into our main game and then add tons more spiders. Let's duplicate this down, shift alt down arrow key. So now we should see more spiders spawning correctly. Yep. So yeah, we have spiders spawning right on top of blocks and at random expositions. So let's see that again. And yeah, cool. So right now we were a bit unlucky and we didn't get any spawns in the left chunks, but we did get a few in the right. Cool. Now let's apply the same logic to our player so that it spawns at a block and not at Y level 0 and it falls to the ground and loses half of its health. So we're applying the same logic, but we're making it so that the chunk it's going to spawn in will be the 0th chunk index, of course, and then only at the first column. So we won't have any random Y position action going on. Okay, so now let's go into our game methods. And let's copy all of this code, like all of it, and then let's paste it down again, right? And we'll change this name to get spawn position for player. And we don't need a chunk index. We know the chunk index will always be 0 when the player is starting out, right? And same here, we want the spawn X position to also be 0 so that it spawns at the starting of the chunk, and rest everything will be the same. Now let's go to the player component, and inside the onload we're gonna, at the end of everything, let's add a position equals, we need to get the actual index position, so game methods dot instance dot get player spawn position for player, then multiplied by the block size. So to get that again, we gotta do game methods dot instance dot block size dot x. Right, so that is it. Let's restart our game. Now the player should be spawning directly on somewhere, but it's not. So we get some kind of an issue. Invalid value, only valid value is 0, 16. That is because, by the time we are inside of the player component and then creating the player, the world has not loaded yet. So we'll create a simple await statement. Just we'll do await, and then we'll do future dot delayed. Then we're going to give a duration of seconds 1. So this will just wait 1 second before doing everything inside of here. So by the time the world should be loaded up. So yeah, so that worked. We spawned exactly on the first block of that chunk. So let's go over what our function actually is again. Inside of game methods, let's go to a function spawn position for player. So we are getting our chunk index as 0 because we'll always spawn at the 0th chunk index, of course. Then oops, lost it again. Yeah, then we're setting the X position as 0, 2 because we want to spawn at the first column, right? That's why we're setting the X position to 0. Then we're just iterating from 0 till we find a block that is collidable, and then we're setting the index position to that so that the player spawns there. So let's try that again. So now the player won't exactly just fall and then lose tons of hearts doing it. Right, cool, so that's working. Now let's make it so that at any given moment at night time, there will always be 3 mobs spawning, meaning since I just killed that a spider, a new one spawned. And we'll only spawn these mobs during night time. And we'll define the number of mobs that should always be present as the mob cap. So at any given moment, mob cap number of mobs should always be spawned. Okay, so first things first, let's go inside utils, then into constants, and let's define our mob cap. And this will be a constant, an integer, and mob cap. And for now, let's put it as something like 3. So this is the amount of mobs that we want to spawn at any given moment. So if you kill, okay, so let's say we had 3 zombies at a night time, and then you killed one, then one more should spawn. So at every given time, when a mob should be spawning, like in, when it's night time, there should always be mob cap number of mobs. Right. So now let's go inside of our main game and into the area where we are spawning all the spiders, and let's delete all of that. Right? And inside of the void update, let's go here and then add the logic to actually spawn our mobs. So we're going to put an if statement, and we only want to spawn the mobs when it's nighttime, right? So we want to check if it's nighttime. We can do that by doing world data dot timer manage. Okay, it's a sky timer, and then world data dot sky timer dot sky time. So if the sky time is the sky time of night, so sky timer enum dot night, then spawn the mobs, right? So print spawn mobs. Okay, now let's actually go into a sky timer and set the default time as, let's go in here, let's set it to night time so that it'll be a little easier for us, so that we don't have to wait for nighttime to come. And now if we go into our debug console, we should get tons of spawn mobs printing. Right, that's working. And okay, I'm just going to our main game again. So here we'll have all of the logic to actually spawn our mobs, and it wouldn't be really appropriate if we put all of those here, right? This is purely for our main game update, which does some important things like update the timer, item rendering logic, chunk rendering logic, and stuff. So we'll create a new function inside a new file that will have the function for actually spawning the mobs, and then we'll just call that function here so that everything will be neat and clean. So let's go into resources and then create a new file, mob spawning dot, and here let's create a class called mobs, and let's actually just call it mobs instead of mob spawning, because that's spawning mobs isn't the only thing that's gonna be here. And here we'll have the actual function that will spawn the hostile mobs. So this will not return anything, so it'll be of type void, and let's call it spawn hostile mobs. Right. So we want to spawn mobs here till there is a mob cap number of mobs in our game. So we need some kind of way to keep track of all the mobs in our game. So let's create an integer, call it total mobs, and we'll set this to 0, and we'll increment this value each time a new mob or a new hostile mob spawns, and we'll decrement this value each time that mob dies. So let's call this total. Okay, no, that's fine. Total mobs is fine, because eventually we want the mob cap to be 3 or whatever we'll put it in the future, and not the hostile mob cap. So maybe we are passive mobs in the future, like mobs that don't attack the player. So if yes, we still want to follow that logic, because we don't want to, loads of mobs in our game at one given moment that'll, totally lag out our game. So assuming that total mobs directly points out the number of mobs in our game, we can do this logic here. So So we can check if the total mobs is smaller than the mob cap or smaller than or equal to the mob cap, then, spawn some mobs. So let's just add a zombie into our game. So we can do that by using a global game reference dot instance dot game reference. Then we're going to do add, and then let's just add in a zombie for now. Oops, zombie with the spawn index position as get. Okay, so we first need to go inside game methods first. Game methods dot instance dot get spawn position for mob. Okay, cool. So what are we doing here again? We're checking if the total number of mobs in our game is smaller than or equal to the mob cap. So if it is smaller than mob cap, we're adding the mobs. And every time we add a mob or every time a mob exists in our game, we'll like increment the total mobs. So let's go inside a hostile entity right now. And inside the onload, we'll just set, we'll increment the total mob count because, the onload only gets called when a new component is being added. And the hostile entity is either a spider or a zombie, for which we want to increment our total mob count when they're added in the game, right? But before that, let's go into our world data, and then just like a sky timer, we'll add this new class into our game. So mobs equals mobs. So we can actually access the global instance of it. Okay. Now let's go inside hostile entity. So every time this is actually created, and let's not actually do this inside onload, we want to do it as soon as possible. As soon as an instance of hostile entity is created. And we cannot always assume that onload gets called like at the exact time that instance gets created. But what we can assume gets created is the constructor. So let's go inside the constructor of this. So this gets called every time an instance of hostile entity gets created. When it's created, we're just going to increment the total mob count. And to access the total mob count, we need the game reference. So to global game reference dot instance dot game reference. Then world data, then mobs dot total mobs plus plus. So we're incrementing the number. So if a zombie or a spider gets spawned into our game, it's going to go here. It's going to call the constructor, every time an instance is created. And then it's going to add 1 to the current total mobs. Easy. Now we also want to remove it when they die. So, okay, let's not add the logic for that right now. And let's see if this works. But before that, we actually need to call our spawn hostile mobs, right? Let's go here and then do world data dot mobs dot spawn hostile mobs. Cool. Let's hot restart our game. So we should see 3 zombies spawning, but we get an error, no element. Okay, so get spawn position for mob. Okay, so we can fix this by going inside of our sky timer. So this is actually happening because we are spawning our mobs before our chunks has been created. So we're going to set this to evening, and then let's go into our total time in a day, and then we'll set it to something like 30, so, or maybe like 20, so the time passes really quickly. So now let's hot restart our game. We should start at evening, and we do, and any time now it should be night, and it is. So we have 1 zombie, another one, and another one. Okay, actually we have more. Okay, that's because we did smaller than or equal to mob cap. Anyway, that's fine. Let's change that to smaller than a mob cap. So instead of mobs, let's do smaller than mob cap. So even though the spawn hostile mob is being constantly called inside the update, so every frame of our app, spawn hostile mobs is being called, but still only 3 are spawning. So that is exactly how it should be. So every time a new mob gets added, we are incrementing the total mobs, and we're checking if the total mobs is smaller than the mob cap. Only then we are adding a mob. So if we kill the zombie, for example, it should spawn another one, right? So let's temporarily add some kind of logic that we can use to kill a hostile mob. So let's go inside hostile entity. And okay, to do that, what I just did was I did Control P, then I got access to the palettes. Now we can search for any of the things in our game or a folder, and we can go into that. Like for example, if we wanted to go to the sky timer, we can do sky timer and then go inside there. Now if I want to go to the hostile entity, I'll just type in hostile entity and then click on enter. Okay, anyway, so we want to kill the hostile entity every time it is clicked on, or at least that's what we're going to be doing for now. So, to detect clicks, you guys know how to do that. We're going to extend from tappable. That gives us all of the logic that we need to actually, okay, it's width. So that will give us all the logic that we need to actually detect taps. So let's copy this on tap down. And let's go all the way down here. Into here. And then we're going to do at override. Tap down info. Then inside of the killing logic, which is actually inside of the entity. So let's see, what are we doing in a killing logic again? So we're checking if the health is 0, and then we're removing from parent. Okay, cool. So we want some kind of way to know if the component is being removed from the game. So just like a onload, we have another function called onRemove, right? So let's go into a void onRemove, and we can override this and also call super.onRemove, right? So this will get called every single time an object is being removed from our game. Not an object, a component gets removed. If we did remove from parent, what it's just going to remove it from the game, right? So if that happens, it's going to call the onRemove before the component actually gets deleted. So here we're going to set the total mob cap, or we're going to decrement it, right? So let's say that there were 3 zombies and the player killed 1. So if the player killed the component is going to get removed, and before it gets removed, it's going to go inside the onRemove. So there we're going to set the we're going to decrement the total mob cap, or the total mobs. So it'll be 2, so that another zombie spawns again. So here we need to access the actual total mobs. So global game reference dot instance dot game reference dot world data dot mobs dot total mobs minus minus. So we're decrementing it. And in the on tap down, let's just damage the zombie. So change health by, let's say, -5 or -10. So once we click on it, when we click on it once, it's going to instantly die. So let's see if that actually works. Let's wait for it to be night. Okay, it's night now, and we get okay, we have some zombies there. And actually it's lagging because we set our zoom to full, right? Actually 30 pixels, right? So let's go inside of our game methods and then change our block size so that we won't have the zoom effect. So game methods and then block size. Where are you? And we're just gonna uncomment this. Let's all restart a game now, so everything should be working normally. And let's wait for it to be night again. Okay, it's night now, and we have a zombie, right? Let's click on this. So okay, killing that actually works. And on second thought, let's make it have in the zoomed out block size again, because we want to see the mobs actually spawning, right? Okay, cool. Anyway, nighttime, come on. Okay, it's night. We have a few zombies here. And let's kill this one. So another one should have spawned. Okay, we have 3 here. Good. Let's kill this one. Right? Now, when it's nighttime, another one should spawn somewhere. And as you see, that one spawned. Now, let me kill this. Yep, now another one should have spawned. Maybe it's here. No, it's not. Let's count all the zombies now. 1, 2, 3. So, always when we kill a zombie and then it's nighttime, it's going to spawn another one. Keeping the mob cap always 3. So, let's wait for another one to spawn. It's not on the right, so it's got to be in the left. And yeah, so there are 3 zombies again. See, now that we killed that one, a new zombie just spawned. Cool. Now, okay, let's go into our mobs again inside of resources. And then rather than just adding a zombie, we want to randomly add either let's say a spider or a zombie or any hostile mob that we'll eventually have in our game. So let's create a function for this called void add hostile mob. Okay, and here we want to randomly either add a zombie or a spider. So, that would be pretty simple. We just need to do random.nextBool and then do some kind of logic like that. But what if we add in a new hostile mob? We would have, we would need to change our logic. Or maybe eventually in our game, we'll have hundreds of hostile mobs. Maybe if you want it so. Then, we got to think of some logic that'll be expandable. So let's create an integer. This will be called mob, and this we'll get this as a random. Let's use a random class, and then we'll do next int and then do 2. So this will give us a value between 0 and 1, so including 1, right? So now we'll check if the value is 1, or if the value is 0, we'll add a zombie. If the value is 1, we'll add a spider. So let's say we wanted to add a new mob, then all we do is change this from 2 to 3, and then we'll have another if statement checking if the mob, okay, let's call this mob value or mob number, another logic checking the mob number. If that's 2, then we'll add that mob. So we have a random, way of adding a mob. So this will be a switch statement because all the logic will be based on the number, the mob number. And now we can add the cases here. So if the case is 0, we're gonna add a zombie. So let's make it so that this returns a component, and okay, let's say return random hostile mob. So this returns a random hostile mob, and we'll add it inside here, right? So we'll just change the return type to hostile entity, and if the case is 0, we'll return a zombie with the spawn index position as get spawn index position. So we first need to do game methods dot instance dot get spawn index position for mob. Okay, now let's actually copy that or everything inside here actually. And now if the case is 1, oops, when is after this? Okay, yeah. So when the case is 1, oops, case 1, then return a spider, right? And we'll set the spawn index position to get spawn position from mob. So let's just cut this and paste the same thing that we have there, right? Cool. So we get a random value between 0 and 1. And okay, we also need to add a default so that it doesn't think we're returning something that's null. So we're gonna create a default case default, or just default, oops, default, then return, let's say our default mob, let it be a zombie because it's the first thing that we added, right? Okay, so we have a random number. It'll go either between 0 and 1. So if it is 0, we're returning a zombie, and if it's 1, we're returning a spider. And here we can remove zombie and then do return random hostile mob. Cool. And we have a default because when we only have 0 and 1, our game kind of thinks that, okay, maybe mob number could be a value, going up to infinity or whatever the max number of value could be, right? So we don't have the case for that, so nothing will be returned. But we're specifying a return type of hostile entity. So that's why we're putting a default, so that if none of the cases match, we'll return a zombie. But this won't exactly happen if we implement this correctly. Maybe if we made this 10 and we got the mob number as 9, and then we didn't add a case for 0. We only have the case for 0 and 1, right? So maybe we don't have a case for 9. So if yes, it's going to go into the default, right? So let's make this 2 again, and let's hot restart our game. So now we should get a random mob, 3 random mobs spawning at night. So let's go into the center so we can see everything. Okay, so we have 2 spiders, and let's see, we should have 1 more mob somewhere. Oh, we don't. So there's something wrong there. Unless 2 mobs spawned in the same position. They didn't. Okay, let's kill the spider. That's spider 2. Okay. And okay, yeah, so we actually have a zombie. Cool, so we have 3 mobs. Alright, that's working. So let's go over everything that we just did. So inside of our main game, when inside of the void update, we're checking if it's nighttime. So if it is nighttime, we're calling a function inside of a class that we just created called mobs. We're calling the function called spawn hostile mobs. And here inside of the mobs, we have a value called total mobs, which gets updated every time a mob gets added or removed into a game. For example, if a zombie gets added, it's going to increment this value, so it'll be 1. And if that same zombie gets removed from the game, it's gonna decrement that value to be back to 0 again. Or maybe just if the total mobs were 3, it'll change it to 2. And in spawn hostile mobs, we're checking if the current total number of mobs spawned is this smaller than mob cap. If it is smaller than mob cap, we want it to be the exact same number as mob cap, meaning we want at any given time we want mob cap number of mobs to be in our game. So if it is smaller, we're just adding that, we're adding a random hostile mob into our game with this switch statement that we just created. Right, cool. Now let's work on combat. This will be really similar to our mining speed logic. The tool that the player holds will define the amount of damage done on a mob. We want more damage to be done for the better weapon that the player has held. But again, we don't want to do minimal damage for other tools. So we'll define tiers with all sorts of tools. The higher the tier, the more damage should be done. Now in our tools dot, we have different lists that define what type of tool an item is in. And just like that, for our weapon, we'll have different lists containing the tier of that weapon. And you can find this inside my GitHub. Okay, so a wooden tier weapon will do 2 hearts of damage. A stone tier weapon will do 3 hearts. An iron tier, 4 hearts. A diamond tier, 5 hearts. And a gold tier, 6 hearts. So a wooden tier weapon contains a wooden sword. And then the actual tools of the next tier or the next type of tools. So the stone pickaxe and the stone shovel actually belong to the stone tool category, but it's inside the wooden tier weapons because we don't want these to do as much as damage as a stone tier weapon, right? Because these are fairly inferior compared to like an axe or a sword. And just like that, inside of stone tier weapons, we have the shovel and the pickaxe of iron. And just like that, we have the diamond shovel and diamond pickaxe inside of the iron tier weapons. Yeah. So one other thing, an axe is always stronger than a sword in Minecraft. So as you see here, we don't have the axe inside of the wooden tier weapons, but we have it added inside of the stone tier weapons. So it'll do 3 hearts instead of 2 hearts. And then the same thing. So a stone axe is in iron tier weapons, and an iron axe is in diamond tier weapons. And a diamond axe is in gold tier weapons. Okay, and this is actually quite balanced since an axe requires more, raw materials to craft than a sword does. So let's go create our file. So, we have created a tools.dart inside resources to actually handle all of our tools logic. So just like that, let's create a new file, weapons.dart. And here we paste in everything here. So let's copy all of this and let's paste this. Right, we need to import items. Good. So now we'll just check if the current held item in the inventory is in any of these. So if it's in the wooden tier weapons, we'll do 2 hours of damage. So we'll return 2. If it's in stone tier weapons, 3, iron 4, diamonds 5, and gold 6. And if it does not, if the item that's currently selected does not contain in any of these, we'll just return 1. So just 1 heart of damage. Okay. And, we'll copy most of this from our tools.dart get mining speed change function. So let's copy this entire thing. Right? And let's paste this inside of here, inside weapons. And this will return of type integer because we're only doing integral kind of damage, like 2, 3, 4, 5, 6, and not anything like 5.5, 2.0, something like that. And we don't need a parameter, we'll remove that. And let's change the name of this function to get damage for, yeah, or do get damage, okay? Because we're not going to be passing anything inside here. We will get the current held item automatically from a global game reference. So let's import all of this, right? So we already have the logic here. We first want to check if it's an item, because all of these are items. And if it's also a tool, then if the item data for tool type, okay, we don't really need this. Or any of this actually. Let's remove this too. Okay, we'll just check if the current held item is an item, right? And if yes, we'll change the wooden tools to wooden tier weapons, stone tools to stone tier weapons, iron tools to iron tier weapons, diamond tools to diamond tier weapons. Oops, not prevent duplicated handling mode dot to nothing. Diamond tier weapons, and gold tools to gold tier weapons. And then if the current held item falls inside a wooden tier weapons, how many damage should we do? So, this function will return the amount of damage that an item does to a mob. So if it's in the wood, we want to do 2 hearts of damage, stone 3 hearts, iron 4 hearts, diamond 5 hearts, and then finally gold 6 hearts. Cool. And else we're returning 1, again else we're returning 1. So if the player hits a mob with a with his fist, or maybe like a dirt block or something, it's just going to return 1. So only 1 heart of damage. Cool. Let's hot restart our game so everything is saved, or let's just save this. And let's actually implement this when we are actually doing damage to a zombie. So let's go inside of a hostile mob, or not a hostile mob, a hostile entity.dart file, and then into the tappable. So how do we actually, detect if the player is attacking a mob? So, when we are clicking on a mob, right? So let's say I have a weapon selected, and if I click on a mob, that means that I'm attacking the mob. So that's why we have done this with tappable. And let's go inside the on tap or on tap down. Cool. So here we're changing the health by -10. So, it's instantly killing. But let's change this to get damage. And we'll do minus get damage. And then this is an integer, and change health by takes in a double. So we'll have to change this to a double. And we're doing minus because we want to take away the hearts and not add to it. Cool. Now let's go inside of our main game and then give the player tons of weapons so that we wouldn't have to craft them. So inside of this huge list of things, let's remove most of it. And we're going to give the player some weapons. So maybe a wooden sword, then an iron sword, a diamond sword. Oops, forgot about a stone sword. And finally a gold sword. You guys can also test this for all of the other items that we have in our tiers, but I'm gonna just do it for the swords for now. And now let's see. And okay, one more thing. Let's go inside of our game methods and then set the block size back to the responsive size that we had, and not just the hard fixed 30. So let's search for block size. And where is it? Yep, here we'll uncomment this. And that should be working. Let's restart our game. Okay, cool. Right, now let's wait for it to be night. So some mobs spawn. Oh god, that was quick. Okay, right, so let's quickly take up a gold sword and then kill these. Okay, so that instantly killed them actually. Okay, so we have a few more zombies. Let's get on it with a wooden sword, and then let's try clicking on this. So that did kill it. So let's try clicking on it again. So 1, 2, 3, 4, 5. So 5 hits killed it because it had 10 hearts, and then each hit with a wooden sword does 2 hearts of damage. Right, let's quickly try to heal by getting an apple or something, please. Okay. Oh god. Okay, we're dead. I'm gonna have to restart this again. Let's try it out again. This time we'll try with some diamond swords. So let's go here. So 1, 2. So it died in 2 hits because our diamond sword does 5 hearts of damage. Yep, so that's everything working. Now let's try with our iron sword. So this should take technically 4 hits because each hit takes 3 hearts. So okay, 3. Alright, so that took 4 hearts. 4 clicks to actually kill that zombie. Cool. Now let's add knockback and the damage indicator to the mobs. And let's also make it so that when the chunks that the mobs are in unrenders, the mob actually disappears so that it actually decrements the total mob count so that new mobs can spawn. So both in the sprite sheets of our spider and the zombie, we have the respective rows for the damage indications. So we have the damaged idle animation and the damaged walking animation. Same for the zombie. So yeah, so let's implement this. Let's go to zombie first. And okay, let's create a new function for this called void animation logic. Right? Now we first check here that if the current animation is the animation equals to let's check walking animation. If it's a walking animation, and we'll check here if the zombie is currently hurt. So if it's a walking animation and the zombie is hurt, then here we'll play the hurting walking animation. Now if this is not the case and it's the, let's say, else if animation equals to idle animation, so in that case, and if the zombie is hurt, you want to play the hurting idle animation. So this is a better way of actually doing a hurting logic than the way that we did for a play component. We'll definitely change that later. But for now, let's actually implement this for our hostile mobs. So let's go inside hostile entity and then define a new animation for it. So we have the walking animation, which is the second row. Let's duplicate this down by holding Shift Alt, then the down arrow key. And as we know, the hurting walking animation or walking hurt animation is the third row. And let's duplicate the idle animation down to Shift Alt, down arrow key. And the idle hurt animation is in the first row. So 0 of 1. This corresponds to the y-axis or the column. Right. Now let's go inside zombie again. And then we'll change the animation to animation. Oops. So if the current animation is walking and the zombie is hurt, then we set the animation to walking hurt animation. Same here. If the current animation that's playing is idle and the zombie is hurt, then we'll set the animation to idle hurt animation. Right. And we want this to apply to both our spider and the zombie. So we'll cut this from the zombie and add it to a hostile entity. So all the way down here, let's add it here. And then inside the void update, if we have one here, do we oops, not void update. Okay, we don't. So let's actually create a void update. This will be overridden void update. We have a dt as a parameter, and then we also need to call super. Right. And here we'll add the animation logic. And it's that easy. Let's restart our game and then see if it works. Okay, so our game has loaded up and we have a zombie here. So let's try attacking this. And when we click on it, the animation does not exactly change. Let's try it for the spider. And okay, it doesn't work. let's see what the issue is. Okay, so let's try going into our zombie dot and actually calling animation logic from here. Same for a spider, and then let's see if this works. Animation logic. Right, and now let's restart our game. Right, we have the mobs here, and yeah, okay, now the markers actually work, and it's actually indicating if a mob's been hurt. So let's try it with this, but when we click, it doesn't exactly work. So the indication's not exactly functioning. So let's go here into a hostile entity, and then into the idle hurt animation. So something is wrong here. So we have the sprite sheet. Okay, so X and Y. That's really odd. So we can fix that by making this 1 and this 0. So we're targeting the first row. My bad, that was a mistake I made. Now everything should be working. Right, we have a zombie in its idle animation state. Now if you click on it, yep, so that is working. Now let's actually add knockback to it. So to do that, let's go inside of our zombie or a hostile entity in general, and then into the inflict damage to the player. So here we'll add another function called void do knockback, and let's change this to do knockback to self, right? And then here we'll copy paste in all of this code, and we'll change other to just move. Okay, so and now inside of the on tap or on tap down, we're gonna, after the change health by, we're gonna call inflict or do knockback to self. Let's restart our game. Let's go find a mob. Okay, we've got one here. Now let's try hitting it, and okay, it does opposite knockback. That is because our do knockback to self logic does this in the same implementation of logic for the actual player knockback. So that will work if we change this greater than to smaller than. So what exactly are we doing here? So we're getting the player's X position. We're checking if the player's X position is smaller than the player's X, or not the player's X position. We're checking if the current entity's X position is smaller than the player's X position, meaning if it's on the left, then we are, doing knockback to the left. If not, we're doing knockback to the right. Cool. So the exact opposite of what we're doing here. So now it should be working. Let's see. Right, we have a zombie. Now let's try hitting it. And yeah, so knockback does work. So now we have one more thing to fix. But to see this clearly, we're gonna have to go to the game methods and then set the block size back to 30. And let's restart our game and then wait till it to be night. Okay, so we have a spider here, but as you saw right there, when we went to the left, what happened is that that spider fell down. So when it falls down, it doesn't actually, remove the component. It's going to exist forever. So even if we go up here and then kill the spider, the game still thinks that there's one extra spider there and doesn't spawn to the full mobcap potential. So, eventually if we go to the right and, make all the actual mobs fall down, the total mob count will not go down because the mobs that fell down will not, ever die. So we're gonna have to make some kind of logic so that if the chunk index of that specific, mob disappears from the current rendered chunks, we're gonna have to delete that mob. So let's go inside of a hostile entity, and then we'll create a new function called despawn logic. And let's first get the chunk index of this entity. So we're going to do vector2. Okay, not vector2. The chunk index will be of type integer. So chunk index equals, we can use the game methods dot instance dot get index position from pixels, and then we're gonna change this to the position, and we're gonna cut this and then put it inside game methods dot instance dot get chunk index from position index, and then paste this in here. So what are we doing? We're first getting the game methods dot index position from pixels, which returns the index position from the pixel, which is basically just dividing the current position by the block size, and then we're passing in that index position to the get index from position index. So this will give us the chunk index. Now here we'll check if let's say, okay, now we need the current rendered chunks, or the chunks that should be rendered. So let's do global game reference dot instance dot game reference dot world data dot chunks that should be rendered. Now we're going to do dot contains, and then we're going to pass in chunk index. If it contains this chunk index, it's totally fine. But if it doesn't, so we'll put an exclamation mark here. So if the zombie is still existing after its chunk, or after what chunk it was in disappeared, we want to kill it. So kill entity logic. Okay, oops, we shouldn't have done kill entity logic, but we'll just set the health to 0 so that, it would automatically die. And now we'll add our despawn logic to both our zombie and the spider. So right under animation logic, we'll add despawn logic, not descendants, despawn logic, and same for the spider, despawn logic. Oops. Cool. Now let's restart our game. Right now everything should be working. Okay. Right, we have mob spawning. Now let's leave this chunk. And if all of those mobs die, the total mob count should be set back to something super low. And now the next night, if mobs spawn, everything has worked. Yep, and we get 3 mob spawns. Yep, so that's working. Now let's create gravity blocks. Gravity blocks will be blocks that will fall when there are no blocks underneath it. This will apply for sand in our game. We'll create a class called gravity block and extend it from block component and collision callback. We'll keep track of if the block is colliding down with the collision callbacks, and in the update, if the block isn't colliding down, meaning there's no block underneath it, we'll increase the Y position, making it fall, and also update the actual chunk list so that the changes get saved. We'll create a sand block class that extends from this and add it to our get parent for block. Okay, so let's begin by creating our gravity block inside of resources. So gravity block dot, and this will be like a hostile entity. So this will be a class that will be a parent for some classes, or some actual implementations like spider or zombie, which extend from an actual class that is like the base for everything. In our case, we'll be extending our gravity block from a block component. So let's create the class gravity block and extends block component. And then we also want to detect collision inside here. So we're gonna also have to extend it from collision callbacks, right? And we need to actually provide in some of the parameters for the block component, like the block, okay. So we cannot exactly assume that the only block inside of a game will be a sand, right? Maybe we'll add different blocks, like maybe gravel in the future. A gravel will also be a gravity block, and then block index and chunk index. So usually if we only had one type of gravity block, we would just pass in the super the block as block. But maybe we'd have different blocks. That's why we're going to be requiring all of the things. So required super dot block. So we're not providing it as blocked right away. We're not providing it as sand right away. And then required super dot block index. And then finally required super dot chunk index. Cool. So the only collision inside of our gravity block will be for to detect if the actual gravity block is colliding in the bottom, right? We don't care about any other collision. So let's create a variable for that right away. Is colliding bottom, and we'll default this to false, right? And then let's have an on collision. So let's go inside collision callbacks. Again, if you forgot, you hold control, hover over collision callbacks, and then click on it once. Right? Now inside on collision, you can just copy this and paste here. And we gotta change some things. So we gotta make the tag actually override import vector2 from flame components. Then we gotta remove everything inside the body and actually call super.onCollision. Right, cool. And here we'll somehow detect the bottom collision, and if it's an actual bottom collision, we'll set this to true. And I don't really want to type all of this again, so we have already defined it for our entity. So let's go inside of our entity, control, then click. Now inside the on collision, we can copy this logic. So intersection points, this one, and let's paste it inside of the logic inside of our gravity block. So we're going to put an if statement here and then paste this. And if yes, is colliding bottom equals true. Cool. Now let's go inside of the void update. So here, you guys know what the void update does. So this will take in a double DT. Also gotta pass it in for the super. So super.update and then DT. Okay, so all of our logic for our gravity block will be in, if it's not colliding down, right? If it's not colliding down, or actually if it's colliding to the bottom, it's just going to be looking like any other block. We will not be having any other extra functionality for it. But what's special about a gravity block will be all of its functions when it's not colliding at the bottom. So we'll put an if statement here. So if it is not colliding to the bottom, we're going to do everything. So first we want to make the block fall, and to make it fall, we're just going to add the position.y to some value. So let's say 10 or something, 9. So if we wanted to fall 9 blocks per second or 10 blocks per second or whatever, let's first define that. We'll have an integer, blocks per second speed. We'll set this to 9 for now. And then first we're going to multiply this by block index. Actually, not the block index, our block size from gamemethods.instance.blockSize. Right? And we want it to travel this distance over 1 second. And to do that, we'll just multiply it by dt. Cool. And of course, every time, everywhere we're setting the collision back to false. Every time we're doing something, like in a zombie, we're doing set all collision to false, so that it would actually run the collision again, then it'll actually update. So we also have to do that here. So we're going to set the collision to false. So is colliding bottom to false again. So is colliding bottom equals false. Okay, cool. So now just to test it out, let's create an instance of this. So, a block with a specific functionality will always go inside of our blocks folder. Let's call it sandblock.dart. And this will be just a class called sandblock. And this will extend not from block component, but from the new class that we just created, gravity block, which is a block component with some extra functionality. And then now for the constructor, okay, not the constructor, we have to provide in all of the stuff here, like we first need to require the chunk index, super dot block index, and the required super dot chunk index. Then we know what the block is here. So we'll just give the super as block dot sand. Oops, we gotta import blocks first. Dot sand. Right, so that is it. Now let's actually add this in as a parent. So, every time we want our blocks.sand is being added to our game, we want this to be added instead of just another block component. So we can do that by going inside blocks.dot here, and inside the get parent for block, we'll add a case just as we did for all of these. For sand now, blocks.sand, and we're going to be returning the sand block. Right, let's see how this is gonna work. Let's run our game. Okay, our game has loaded up, but before everything, let's go inside of our game methods and then set our block size back to the original one. And let's auto restart our game. Okay, so something is definitely a bit off. Right, so the sand is not exactly working, and this is because of our collision detection. Right, so let's go inside of our gravity block again. Inside of resources, where is that? Okay, and here we won't be using is colliding bottom, right? So as we just saw, that's not an exactly trustable way of to check if there's a block underneath, but we can use another method that we had created before. So game methods dot instance dot adjacent block exists. So it's actually, I mean, not this function, but inside of this we are using get block at direction. So this will return the block at whatever direction of a block index that we specify. So as a block index, we will provide in the block index of the actual gravity block, and then we'll do direction at bottom and then get that block. So we'll check if it's null. If it is null, then fall down and stuff. That's a way better way of actually doing this. So let's do game methods dot instance dot block at direction. The block index will be block index, and then for the direction, let's give direction dot bottom, and we'll check if this is null. But there's one problem with this. So the block index is not exactly, does not always point to where the block currently is. It usually does, because our, blocks are usually static, meaning a block can't move, right? So the block index only tells the game where we actually want to position our block at the beginning. But if you move the position of that block again, like without breaking it as we're doing for sand, it won't update the block index. So our block index is not exactly reliable that way. So we're gonna have to create our block index again. And as we know, the block index is basically just the position divided by the block size, right? So the block index only applies when the game is actually creating the positions for our block components, right? So we'll remove the block index from here and make game methods or instance dot get index position from pixels. So this is the function that we created, and inside here we're just dividing the actual position by the block size. So that's cool. We're just gonna do for the click position, we're just gonna pass in position, easy, and dot bottom. Right, now it should be working a bit better. Let's see. And yes, so our sand does not exactly automatically fall down. So let's break something here. And if we break that, that sand falls down. Cool, that's working. But that's it's way too quick. So let's change the speed up a bit. We're gonna change this to blocks per second multiplied by game method or instance or block size actually. And then we'll change the blocks per second to like 5. So now everything should be a little bit more tame. Okay, let's try breaking this. And yeah, that is fine. That's definitely a bit slower, but not ideal. It's still a bit way too fast. Let's try 3 blocks per second. Oh my god, there's zombies here. Okay, right, okay, that's good. Now let's try breaking it again. And it works. But there's one more thing. If we leave this chunk and then come back again, this will revert to being here. That is because once we are actually changing the Y position, we're not updating the actual chunk list, right? So what's happening is we're breaking all of these blocks. Okay, those updated, but this block actually falling from there did not update. So the game still thinks that the sand is still here, right? But we don't want that. So every time the block actually falls, we want to update our chunk list. So how do we do that? So let's use our game methods again. So game methods dot instance dot replace block at world chunk. So this will replace whatever block we provide in here and with our block index. So actually not with the block index, at the block index. So for the blocks, we're gonna pass in blocks sand, and the block index will again be the current block index and not the block index at the beginning. So let's copy this. Where was that again? Okay, yeah, here. Get index position from pixels position, and then we're gonna pass it in here. Right, now let's hot restart our game. And let's do one quick thing. Let's go up to our world data and let's uncomment, actually no, let's comment the -1 and +1 so that only the current chunk renders. Right, okay, let's hot restart until we get a desert. Alright, we've gotten a desert. Now, okay, I'ma break this block. So, okay, oh my god, the zombies. Okay, let's first kill these. Oops. Okay, anyway, let's break this block right here. So that went down. Now let's leave this chunk. And if we come back here, right, it is still there. That is because it didn't exactly successfully update. But before that, let's actually set our mob cap to 0 because the mobs are being super annoying. Constants mob cap equals 0. So none of the mobs will actually spawn now. Okay, anyway, let's try that again. So let's break this block and go into the other chunk. And let's go back here. But as you see here, that block is still here. That is because the world chunks did not successfully update. So let's actually copy the same thing and then do it inside of a is colliding bottom here. So this gets called when a sand successfully hits the bottom, right? So after this gets hit at the bottom, we are setting this to sand, right? That's totally fine. But this block is still a sand. Okay, so we broke this block, which caused this block to go down here. And once this block went down here, we set the block at this chunk. We updated the chunk list to have a sand block here, but we didn't delete the sand block from here. That is what was causing the issue. So we're gonna do something here. We'll set the game methods or instance dot replace block at world chunks. Then at block index we'll set it to null. That will empty the actual our sand at the block index. But of course the block index is not a reliable way. That is unless we update it. So we're going to do block index equals game methods dot instance dot get index position from pixels, and then we'll pass in position. And I'll explain this in just 1 second, but let's see if this actually works. And again, we cannot exactly change the value of block index because it's a final, and let's just remove the final keyword. Now we should be able to actually change it. So let's see. Let's break this block here. Right, so all of those fell. Okay, not successfully, but still whatever. Right, and it actually updated the chunks. Okay, but still there are tons of issues that we need to fix, but let's see. Okay, that totally shouldn't be happening. So let's see what the issue is and then fix it. Okay, so to fix this, let's first remove this from here because we don't want to constantly update it. It's fine if we just update the world chunk when it actually lands, right? And let's do a little something here. We change this to blocks because it doesn't have to be blocks.san, it's the same thing. So let's make this block index, and we're going to update block index right after this. So let's say we broke a block, right? And this sand, let's say its block index was 0, 0 and it fell down. So when it falls down, this will get called. So it's going to replace the block at 0, 0 with okay, this has to be null actually. So it's going to replace the block at 0, 0 with null. So it's going to delete it. And then it's going to update the block index. So now it'll be, since, you know, this sand fell down, it's going to be 0, 1. And now we'll add this block to that block index of our updated block index. Right, now it should be working. Let's see. Okay, let's break this block. Right, now let's go to the left and back again. Right, now let's break this one here. Right, okay, cool, so that works. And finally, one more thing, we only want to detect the collision if what this is colliding with is an actual block. So if other is of type block component, only then do the collision, because if not, it's gonna actually break our game in some places. So let's try that out again, just some random stuff. So if we dig down here and then we place a sand block on top of us, it shouldn't collide with us, and it doesn't. Cool. Lastly, we don't really want this to look for the active block index, so let's just change this and then change it to the normal block index, because now we have made it so that the block index updates every time it hits the ground, right? So now everything should be working. Let's hot restart again. And let's try breaking this block here. Right. Now if you leave the chunk and come back. Okay, so that's working. So now let's create our respawn screen. So this will be a translucent red container with a column with a text called "You died," which will be in a Minecraft font, then a custom button. And we link this to an observable value, just like we did for our inventory and our crafting inventory, so that if it is false, it won't display the respawn screen, and if it's true, it will. So if you click on this, it will set that value to false. So if you click on this, the screen should disappear. Right. And we'll eventually link that screen to appear when the player is dead. And we'll make it so that once the respawn is clicked, it's going to create a new player component and add it to our main game. Okay, first let's go design our screen. And we'll create a new folder in our libs called screens, where we'll have all of our screens. So, screens. Eventually, we'll have tons of stuff related to Flutter now, like the launcher screen, which will be made of Flutter, not Flame, the create new world screen, the select world screen, etc. And the respawn screen will also be made in Flutter. So we're adding it to screens. Right, and let's call this respawn screen dot. This will be a stateless widget. Respawn screen. Right, and we're going to be returning a container. We want this container to be at the full size of our screen. So let's get the screen size here. I'm gonna do size screen size equals game methods dot instance dot screen size. This is a method we created. Now we can use this here, and in the container we can just give the width and height as screen size dot height and width. So screen size dot height width mean height screen size dot width. Let's temporarily give it some kind of a colors dot pink or something very vibrant colors. Okay, amber's fine. Now let's add this to our game layout. Let's go here. Okay, not game methods. Um, Up here. Okay, and we'll add it here. Respawn screen. Constant. Let's all restart our game. Okay, it's not exactly working. Presume that's because we put the width as wrong. Let's see. Uh, go back to our screens. Respawn screen. Okay, so we gave the width as height and the height as width. Okay, so screen size dot width and screen size dot height. Okay, let's hot restart our game. Okay, so that's working. So why did we exactly add this to our game layout? So, this will be just like our inventory or, things like that. Wait, let's go inside game layout again. Game layout. Yeah, so this will be exactly like a item bar, not item bar widget, like the player inventory widget or the crafting inventory widget. So these can either be seen or it can be hidden, right? So it can either be a container or the actual widget based on an observable value. We'll have a similar thing for our response screen. So for now, when we're designing this, it'll always be on top of the screen, but we'll eventually change it so that when a value called player is dead is set to true, only then the respawn screen will be seen. And if it's false, the respawn screen won't be seen. It'll be invisible. Right. And let's change this color to red. And okay, we don't want it to exactly be, solid full red because we still want to see what's going in our world, right? We cannot see anything. We're going to do dot with opacity and then do 0.5. So this will make it a little bit translucent. Let's see. Okay, cool. This is good. Now we want a text saying here, you died, and then a button saying respawn. Okay, so let's create that. This will all be in the child of this container, right? The child. And then, we want a button here. I mean, we want a text here and a button on under that. So that means that we're aligning it vertically. So a column, it's inside of a column, children. And first we'll create the text. You die. Okay. Okay, we're going to give it some style. Text style. Let the font be something really big. So 40. The colors dot white is fine. And we want the font to be our Minecraft font. So let's go inside of our inventory widgets and into the inventory item and number widget. And here we have this here. So we can just copy both the font family and the shadow because we also wanted to have a shadow. So let's copy all of this. And we'll paste this inside of our respawn screen. Right. And okay. Shadows. Okay, this is outside of the actual screen or the actual text style. Now let's format everything. We can't really see anything that's going on. Let's temporarily make this a constant and remove this. Okay, so we have a text saying you died, which is 40 pixels in size, and the color is white. Actually, we don't need to define this. The font will be the Minecraft font, and it has a shadow going a little bit into the bottom right. And we don't want it to be just a little bit. We're gonna change it to 3. Let's hot restart our game and see how this looks. Okay, so that happened because we apparently did need to um have the color as white. Let's change this back to 3 to 3. Oops, not 13. 3 and 3. Let's hot restart our game. Alright, that's looking good. And I guess we can change the font size up to like 50 because we have tons of space to work with. Cool. And now let's actually create a Minecraft style button. Now this will just be a image with the actual, button style or that stone texture. And then we'll put it around a gesture detector so that we can detect clicks. And or let's put it on an inkwell so that it'll be, better suited for just clicks. And then we'll provide in the actual function that we want to do inside it. Okay, if you didn't understand that, it's totally fine. We're gonna do that, right? And let's go inside launcher, inside of our images folder, and then into the respawn button. So this is how we want our button to actually look like. But we won't be directly adding this here. Because, eventually in our game, we'll have tons of buttons that's similar to this, right? This is currently just an image. So we want to create a widget with, if we provide in a property called, let's say, text inside of that widget, it's going to give us a button like this with the text as that. I mean, we could totally use this, but in the future, it'll be, definitely better if we created a new widget that will create, something better like this. So we can do that by, and again, this image is just for reference and not to be actually used. So let's go into our launcher and then into the background button.png. So this is the background image for the button that we'll be using. So we'll create a widget called, let's say, custom button or Minecraft button, and that will be an image widget, right? So this one, and then inside here we'll have our text, and we'll also wrap the entire thing around an inkwell or a gesture detector so we can actually detect clicks. And okay, so let's create our new custom button. So let's go inside widgets and let's create a new thing called, okay, not here. Let's go inside widgets again. Let's create a new folder called, where is widgets? Oh my god. Okay, yeah. Widgets is here. Let's create a new folder called launcher, and inside here we'll be adding this button. Let's call it Minecraft button dot. Okay, this will be a stateless widget, and let's call it Minecraft button widget. Okay, and as I said, we'll be returning an image of that image. So image dot asset, and let's copy that image. Launcher, then button background, right? Copy relative path, and then we paste it in here. Quotation marks, and also we need to fix up the slashes. Cool. Now when we do this, it doesn't give our image a specific size, so we have to wrap this around a sized box with the size that we want our image to be, and then wrap our image around a fitted box. So let's first wrap it around a sized box. Okay, and let's get our screen size here so we can think of a responsive size. So size screen size equals, now we can use a game methods get a function, game methods dot instance dot get screen size. Oops, it's just a function, or a get a function. And let's say the width will be okay, we're gonna multiply the width, okay, the screen size width, actually screen size dot width 0.4, so 40% of the screen's width. If this doesn't work and doesn't look good, we'll change it, of course. And we can give the height as something like 20 or 40, right? So we just want the width to be responsible, the height is fine. And we want our image widgets to fit into this constraints, right? So we're going to wrap this around a gesture detector, okay, not a gesture detector, a fitted box. Okay, now let's go into our respawn screen and add this onto our screen. Respawn screen, and at the here we're gonna add a Minecraft button widget. Cool. Let's all restart our game. Okay, so we have the button appearing. So, okay, first things first, it's a little weird with the width. We'll change it to half of the screen size, and we'll also change the height. So let's go into the Minecraft button widget, control click. Let's say 55% of the screen's width, and then 55 pixels height. Okay, this should look good. And yeah, okay, that does look better. Now, for every instance of this, we want to take in a string from the constructor, and then we're going to be creating a text like this inside of here. Okay, so let's first define the property. This will be a final because it will never change. String, and then let's call it get or text. We'll just call it text. And we will require this from the constructor. Require this dot text. Okay. Now let's format all of this up by putting commas everywhere. And as stack actually, so we can't put a child for a actual image.asset. So what we're gonna do is we're gonna wrap this image.asset around a stack. So we'll first wrap it around a column and then change the name of the column to stack. So why are we wrapping around the stack? Because we want a button, actually we want a stack, a text to be on top of it, right? So we have the base widget here, and on top of that we want a text. So simply we'll do text. Okay, we're gonna set the text as what the text will be in a constructor. Then let's give it some style, text style, and let's go into our respawn screen and actually copy all of that here. So let's copy all of this and paste it inside of here. But for the font size, we'll keep that as 25 or 30. Color, okay, gotta be white. Minecraft font and some shadow. But this is a fairly small one, so we can change the offset back to 1 1 so that it'll only have that 3D effect a little bit. Now let's format everything up and also make this a constant. Okay, and we have an issue. Oops. Okay, now let's finally go inside our respawn screen and then give it a text. So for now, let's just give the text as respawn, and let's hot restart our game. Okay, so it's appeared here. We want to align this to the center and also change the size up a little bit. And then, we don't want it to be white, maybe a shade of gray or something, because it doesn't, we don't want it to pop up like that. Okay, so we'll change the font size from 30 to, let's say, 45. And then we'll align this. So we'll wrap that text around an align widget and then give the alignment as alignment dot center. What does this look? Right, that's looking fine. But it didn't exactly align it. That's because we have to first wrap it around a positioned dot fill, right? So let's wrap it around a widget, name it positioned dot fill, and now it should work. And it did. So why it didn't work is that when we actually put the aligner centered, it didn't know it could occupy all of this space. So if you had given a block of space and you were trying to fit a block at the center of this block, you wouldn't we wouldn't be able to know where we are fitting it because it fits exactly that position. So what we're doing is we changed the size of, we told the button that, hey, you can occupy all of the space here, don't worry. So now then if we did align, we were able to align it to the center. Now let's make the color like gray or something, right? Maybe this is too dark. Let's maybe change it to a lighter shade of gray, definitely. So gray of maybe like 300. Exclamation mark, actually not exclamation mark. We can no longer have the constant keyword here. And then we're going to change this to constant because that's fine. right? That's still a little bit too dark. Maybe we just want a slight shade of gray, like not totally white, but not exactly a bit dark. Okay, yeah, that's totally fine. Now we need to actually detect clicks on this, right? So right now this is just an image with a text, but it's not a button. So to make it a button, we're gonna wrap this entire thing around an inkwell. You guys can do gesture detector too, but I'll go with inkwell. And we can give an on tap to this. So let's say print haha button clicked something. Let's not restart our game and let's go into the debug console. Now let's click on this button. So we call the print statement haha button clicked. So when we usually create a button in Flutter, we're gonna be, let's say, button widget or text button. What do you call it? Yeah, text button. We provide an on pressed to it. So let's do that. So the on pressed is of type void function, but we're gonna be creating something called void callback. So let's go inside here, and then this will be a field void callback, and then we're gonna name this on pressed, and we'll require this. So this allows us to pass a function from our wherever we are calling this button into this button. So this is a function, so we can totally just remove this and then pass in the on pressed that we get from the constructor. So it's that easy. So that's what a void callback does. It's like a function. See, void callback equals void function. Right. Now let's go inside here and we provide in the on pressed. And since it's a void function, we can just do this, then pass in anything. But we cannot have the constants keyword no more. Let's change this to constants, and this cannot be a constant. Okay. So here we can do whatever specific to this button what we want to do. Like for now, let's just try printing. Does this work? Let's not restart the game. And if we click on this, it says, does this work? Alright, so our void callback is working. Let's remove this for now. And then let's actually align this to the center. So this is a column problem. So let's go inside the column. And we'll change the main axis alignment to main axis alignment dot center. So the main axis alignment is the, okay, the main axis alignment would be at the vertical axis for a column and at the x-axis for the for a row, right? But if we make it center, it's gonna align every one of its child to the center, right? Now we can just give our actual Minecraft button a little bit of padding and everything will be fine. So let's give some padding, maybe 20 pixels. Okay, definitely not 20 pixels. Gotta be like 70. So that's a good bit of space between these two. Okay, cool. So now let's make it so that the actual disappears or reappears based on if the player's dead. So this is fairly easy. We're gonna go into the, okay, so let's first go inside of our inventory dot, and then we have a value called inventory is open, which is an RX bool. So we'll have something similar, and then if we change this to true, we'll make it so that the actual respawn screen actually opens. We'll put this inside of player data, because if the player is dead, we want to open the actual screen. So we're going to change this to player is dead. Okay. And this will be false. And in the respawn screen, what we're going to do is we only want to display this if the player is not dead, or actually the player is dead. And we want to update it. We want this widget to rebuild every time the player is dead, observable value changes. So we'll wrap it around an OBX. Actually, not like this. We're gonna cut all of this out. And we're gonna type in OBX. And for the builder, we're just going to do this and then paste a widget. Cool. And then here we'll define our logic. Like if the player is dead, Then show this. If the player is not dead, show nothing. So just a container. So let's do, to access the actual, player's dead, we gotta do game methods dot, not a game methods, a global game reference dot instance dot game reference dot world data dot player is dead. Now, if it's, we gotta do dot value to actually get the boolean. So if it is dead, show this. If it's not, show a container. So here, container. Right. Now let's not restart our game. And we don't get anything. That is because we have defaulted the player is dead value to be true. Actually, not true, false. But let's change this to true. So now if we hot restart a game, it should be appearing here. And it is. And we'll set it back to false when we click on this actual button. So let's do that. Inside the respawn screen, in the on press, we're just going to set its value back to false. So that thing actually disappears. Not the thing, our screen. So dot value equals false. I'll restart our game. Now if we click on here, the screen should disappear. And it does. Alright, that's working. So now let's make it so that when the player actually dies, the respawn screen appears. And when we are in the respawn screen, the game will be paused. So that, nothing happens when the player is not actively playing the game. And the game only resumes when we respawn. Okay, so let's first make our game pause when we are in the respawn screen. So first, let's go inside of our respawn screen. And then we need a little bit more freedom inside here. So we want to know whenever we are currently inside the respawn screen. So let's remove this operator right here and then make it curly braces. And let's go down all the way to the end of the OBX and put the curly braces there too. And semicolons now because we're no longer using that operator. And here we're going to be returning this. So return. Okay. So this now is the same thing that, what we just had, but we have a little bit more, freedom to do stuff here. And let's actually put this inside of an if statement. Let's cut this and then have an if statement inside here. If this value, so if the player is actually dead, we want to return this container. So our actual respawn screen. So let's copy all of this. Let's cut it and let's paste this inside here. And we want to return this. So return. And let's remove all of this. And then we'll have an else. And if the player is not dead, we want to return a container. Cool. Now let's restart our game. Everything should be working just as it was. Okay, we have our respawn screen, and if we click on respawn, it disappears. Right, cool. So what did we do now? We changed the, we didn't want to directly return a widget, but we put the curly braces and then we returned it. And we put an if statement to actually check if the player was dead. If the player is actually dead, we're returning the screen. And if the player is not dead, we're returning the container. So it's the exact same thing. But we have, a little bit more freedom to add stuff here. And we can, okay, so this, everything inside here will run when the player dies, right? So at the beginning, when the player actually dies. So let's put a print statement here. Player died. Or, we'll eventually link our respawn screen to appear when the player dies. But for now, let's just assume that we have. So it's a good indication of whether the player has died. So player died. And we get that when the screen firstly appears, right? So when the screen appears or the player has died, we want to pause our game. So let's go inside of here, right? And here we're just going to somehow pause our main game. So first we need access to the main game. So let's do a global game reference dot instance dot game reference. Oops. And now we have everything inside of main game. And now let's go inside main game. Control P, main game. Okay, so inside of the main game, we have access to a function called pause engine. and another one called resume engine. So this makes our lives super easy for us. So this basically just pauses the engine, meaning the engine loop won't run, and nothing will happen unless we resume our engine at some point. So let's cut this from here, and let's go inside of our respawn screen again. So respawn screen with Control P, and here we're gonna do pause game engine. So when the player's dead, or at the beginning when the actual screen appears, we want to pause the engine. And when we get off the screen, meaning we are inside the respawn, so when we click on the respawn button, the screen is going to disappear. And right after that, we want to resume our game. So let's copy all of this again from the beginning. So global game reference .instance.game reference, and let's paste that in here. And we're gonna do resume engine. So we're pausing the engine when our respawn screen appears, and we're assuming it when we're clicking on respawn. Right, so let's see if this works. So a good indication of whether it works would be to see if actually, okay, so we have some problem. Invalid value, only valid range is 0, 16. Okay, I think that's because we're pausing our game right at the beginning. So let's go inside of our player data, inside global, and we'll set this to false. And so it defaults to being false. So when we start a game, nothing's gonna happen, the screen's not gonna appear, and we don't get the error. So let's go inside main game now. Control P, main game, and here in our delayed section, we're gonna actually set a player is dead to true. So world data dot player is dead dot value equals true. So it only happens after a period of time. So we're not interrupting any kind of functions that maybe going on and around in the background. Okay, so that has appeared, and as you can see, the animation does not play. Right, if the game was running, the animation would run in the background, and then our health would slowly go off, go down or decrease or deplete or whatever, but it's not. And our time is also not changing. So this is a good indication that our game has been paused. So now if we resume or respawn, we see that everything else happens, right? So our animation is back on track and everything else happens. And the sky has also changed. Cool. Now let's link our, respawn screen appearing to our player's death. This is fairly easy. Let's just go inside for player component, Control P player component. And just as we did for our hostile mobs, we can do this with the onRemove function. So override, and void onRemove. So this will get called when the player component is being removed. And we know the player component gets removed when the player actually dies, right? So when the health goes down to 0, what happens is that the player component disappears. So let's test that out. So if we fall off here, our health should turn to 0 and the player component disappears, right? And disappears means that it gets removed, and when the component actually gets removed, it fires the onRemove. So inside of here, we can just set our show respawn or the player is dead inside of player data to true. So let's access the player data, global game reference dot instance dot game reference dot world data dot player is dead dot value equals true. Is that easy? Now let's hot restart our game. Actually, let's go inside player data and then default the health be actually something like 9 or 5 or 3, I guess. Now let's see. Okay, so when we hot restarted our game, we went straight to being in the respawn screen. Okay, never mind. So that is because inside of our main game, all the way here, we set our player is dead to true in after this 1 second delay. So let's remove that. And let's see that again. And actually, on second thought, that doesn't actually change the entity health. So yes, it doesn't. So let's go back here and then change that. That was totally pointless. So 10. Let's hot restart our game and then just kill our player with fall damage. So I've got our player to 2 hearts, and if we fall off now, we should die and the component gets removed, and we have entered the respawn screen. Now let's respawn, but when we respawn, nothing happens. So when we respawn, we want to add our player component back into our main game. So let's go inside of our respawn screen, and we want to do this logic inside of the on press of our respawn button, right? So here, let's access the main game first. So global game reference or instance.game reference. And we're simply going to do a game reference dot player data or dot add. Then the player data inside of our game, actually not the player data, the player component. So inside of our main game, we have initialized something or initialized a variable called player component as player component. But we have one issue, right? When we restart our game, we want our player component to start from a new instance. For example, after we've done lots of stuff, we might have made some changes to our player component, like maybe um, maybe there could be some things that changed in this instance. So we want to like restart this from the start, right? So like in the beginning, we are creating an instance. So when we respawn it, we also want to create a new instance and then add that. So maybe if we respawn, we're going to start at the same position that player component does. And let's, okay, actually, we're going to see that happen. So you'll exactly know what the problem is going to be. So let's just add that player component. So global game reference or instance dot player component. Right, so we're just accessing the main game and then adding the player component inside that again. So let's die again, or let's go inside of our play component, and just to make our debugging easier for us, let's go inside here, and then in the onload, we're going to set the health to 3. So health equals okay, let's actually put it as 1, so that we start at a really low health, so that it'll be really easy for us to die. And okay, oops, we do respawn, totally forgot about that. So let's go inside of our player component or our player data inside global, and we'll set the hunger value to like 8 so that it doesn't regenerate our health. Okay, good. So this is what I was trying to do, but totally forgot how it worked. Right now, if we fall here, we should die. Okay, let's break one more block. Okay, so we are inside the respawn screen. Now let's respawn. And as you just saw, okay, so this is a really good example because, we respawn with the same player component, right? Because we're adding the same player component inside of a game again. And that player component has the same health, the same hunger, actually not the same hunger, the hunger is global, but the same health and everything. But we don't want it to be like that, right? So we need to add a fresh new component to our game. So we're gonna remove this, and we're first going to re-initialize our play component. So we're gonna do play component equals play component, and then add that again. So we are actually assigning a new instance of play components to the play component variable inside main game, and then adding that here. So it should start with a fresh health and fresh lots of things like the position, size, etc. So let's try dying again. Okay, now let's respawn. And cool. So the player has started here. But there's something seriously wrong with this. Because the camera is no longer attached. Right? That is because let's go inside of our main game. Control P, main game. And okay, so we have done camera.follow component, player component at the beginning of the creation of the component, right? So, or the beginning of the creation of the game. So when we add a new component, what happens is, okay, first when we remove the component, when the player has died, it like totally breaks this logic for the camera to follow the player. So when we add a player again, it doesn't work. So we're gonna think of a different way to do this. So we're gonna be doing this inside of our play component. So every time an instance of play component is created, so inside the onload, we're gonna access the main game. So global game reference dot instance dot game reference, Now we can do .camera.follow player, and then for the component we can put this. So this just points to this current instance. So this current instance that has been created inside of our main game. So we're doing the same thing, but now it's going to follow the component every time we have a new player. So let's try that out again. Let's dig a few blocks to the ground. Okay, now let's respawn. And as you can see, the camera did follow the player. Right, cool. And but one more thing, we started the hunger at 8 again, because when the player gets respawned, we're not setting the hunger back to 10. So let's do that. We can do that inside the onload, no issues with that. We're gonna copy the game reference again. And so every time a player is added into our game or re-added, we're gonna set the hunger and everything to full. So play component dot not play component dot world data dot player data, then dot hunger dot value equals 10. So we're just setting it to 10, right? And that should be everything working, but it isn't. Okay, so we have a problem. So we are actually adding the player, or something goes on in the background of the game. So we're adding the player before the actual widget appears. So before the widget appears, we cannot change the player hunger to 10. So if the hunger widget does not exist and we are trying to rebuild that, because we have linked this to this our hunger value, it's going to break our game. So that's exactly what happened. So we're going to remove this logic from here and then just add it inside of our respawn screen. So when we respawn, we're just going to change the hunger to 10. So global game reference dot instance dot game reference dot world data dot player hunger dot value equals 10. Let's hot restart our game. Now everything should be working, right? So now let's dig down. 1, 2, 3. One more. And okay, we've died. And now if we respawn, we should have a fresh new play component spawning, and the health should be back to 10, and it is. Cool, so everything's working. And let's finally go inside of our play component and set our hunger back to, actually not a hunger, our health back to 10, or let's just not make it 1. And let's go inside of our world data and then uncomment these so that our world generates like usual. And last thing, let's go inside of the sky timer and then set the default sky, or the sky at the beginning, to morning and not evening. So we changed that for debugging our zombies, right? Now when we hot restart our game, we should start at the morning, and we do. Cool. So one more thing, the sky changes super quickly. That is because we have to change one more value inside of our constants. Control P, constants, and we'll change the total time in a day from 20 seconds to 300 seconds, so 5 minutes. And then we'll change the mob cap to 3. So 3 mobs or 3 hostile mobs will always exist in the day, or not at the day, at the night. And actually we have one last thing to do. So let's go inside of our player data, inside global, and set the hunger back to 10, so that it starts at 10 hunger and not 8. Cool. Now let's work on world saving. So if we make changes to a world and quit the game and then join back anytime later, those changes will still exist. We basically just need to save the world data instance of a game, which contains all of the data that is specific to a world, into our disk, and then load it again whenever we need to play in that world again. But how do we actually save an instance of a class into our disk? With Hive. Hive is a lightweight local database which allows us to save any data into the storage of a device with a key which we can provide to access it. For example, if we wanted to store the string hello, we do put 1 hello. Put is a method we use to store a value, and 1 here is a key. A key is like the value by which we can access the stored data later. So once we execute this, the value hello will be stored in our disk under the key 1. And we can retrieve this value at any time after by doing get 1, which will return to us the value hello. But before that, let's actually figure out where we'll store our data. In Hive, all data are stored inside boxes. We'll have one box in our game to store all of the worlds that the player might create. We'll call this box World Data Box. To use a box, we'll have to create it at the beginning of our game, and we can do that by doing hive.openBox. Then we'll provide in the name of our box World Data Box at the main. To get this box to actually store data in, we can do hive.box, then the name of the box, World Data Box. And now this is where we can get the get and put method. So anytime we use a put method on our World Data Box, it'll get stored inside the World Data Box. Now let's look at another example. So here we are accessing a box called My Box. Let us assume this has already been opened at the beginning of the program with the open box method. A good analogy for a box is to relate it to a folder and the key as the file name and the data as the content of the file. So now we are putting the string David under the key name. So it'll be like a file name is being added with the content as David to our MyBox folder. The data type for value is not limited to just strings. It can be lists, maps, integers, and even world data. But it is not as simple as doing worlddatabox.put key then the world data instance, because Hive does not exactly know how to convert our class into the format it uses to store data. It does for all of the built-in data types in Dart, but not for the new ones we create. So to actually store the custom data objects like world data that we create, we need to register adapters for it. Adapters tell Hive how to store data of a class like for our world data. So here's an example with a custom class called person. We have a string field inside a person called name and an integer age. To tell Hive that these are values that need to be stored, we add the Hive field decorator with a number ID for it. When making the adapter, Hive creates a conversion stub for all of the fields with the Hive fields tag. We need to make sure that we have different numbers for all of the fields. And we have the Hive type decorator. This takes in a type ID which should be unique for this class, meaning we cannot create another adapter with that type ID. So if we wanted to create a new adapter for a class called animal, we'd give the Hive type as 1 because we have already used 0 inside a person. Now to create the adapter class, we need to run this command. But we cannot assume that Hive automatically knows where all the custom classes are. So in every file with a custom class for which we want an adapter for, we'll add a line at the top, part filename.g. In this case, it would be part person.g. because the file name is person. Now if we run the command, our adapter classes will be created. And to actually use this adapter, we need to go up to our main and then do hive.register adapter and then add the created adapter person adapter. Now going back to our world data, the fields itself are custom classes. So we have to make adapters for every custom field that we directly or indirectly use. So let's get Hive up and working. So let's go inside the pub.dev of Hive. And Hive is not the only package that we need to actually get our database up and running. So we need some other packages too, like ones that create the command for actually creating the adapters, then others for initializing Hive and stuff. So let's go inside of the quick start. And this is the actual Hive docs. And here you can see all of the instructions and all the documentations for everything. You guys can look through this if you want. And yeah, so here in the add project section, we have the dependencies. So we have Hive, which is this one here, and then another package called Hive Flutter. And we'll be using Hive Flutter to initialize Hive. And Hive needs to be initialized because, where do you think the boxes will be stored in? So the boxes will be stored inside the documents directory of an app, or not an app, of a device. So if you're on PC, we need to find the document directory of the PC. If we are on a mobile, we want to find the document directory of the mobile and stuff. So we can easily initialize that by, with the Hive Flutter package. So let's copy this and then paste it inside of a dependency section of our pubspec.yaml file. So let's go here and then under fast noise, let's add this. Cool. Let's remove this indentation. And we won't be specifying a version. Right. Now we have another two dependencies for the dev dependency section. Now this will be responsible for the actual command that we'll use to create the adapters. So let's copy this and paste it under Flutter lens, because yeah, and let's remove the version again. Now let's run Flutter pub-get, or I'll just save this file, same thing. Okay, Flutter pub-get has done running. Now let's go inside main.dart. And before everything, before we do anything in our game, we want to initialize Hive first. So this will be like, jumping or jump starting the engine of a car, right? So let's do Hive. And now we can access Hive. And okay, so we have multiple Hives here because we have different packages. So one is Hive, so Hive/Hive, and other is Hive Flutter. We want this from Hive Flutter. So let's import this. So we've got the import package Hive Flutter/Hive Flutter. Make sure that you have this exact same package. And now we can access a method called init Flutter. So this initializes Hive with the path for get application documents directory. So as I said, all of our boxes and all of the data will be stored inside the documents directory of a device. So if we do init Flutter, it'll automatically find the documents directory and then initialize Hive. So we can, do everything. And as you see here, it's a future. So let's await this. And yeah, cool. Now just to see if everything is working, let's try storing and then reading from a box. So let's do this after we have loaded all of the images, because it's cleaner here. It doesn't really make a difference, but still. So let's first open a box. So let's do hive.openBox, and then we'll paste in the name of a box. Let's say world data box. And what does this do? So opens the box. If the box is already open, the instance is returned and all of the provided parameters are being ignored. So what does that mean? So we're thinking of boxes like directories or folders. So let's say we did world data box and all of our data was inside world data box. And let's also imagine that we are running our game or this app for the first time ever, so that inside of the documents directory, we won't have a box named world data box, right? Because let's say we just installed the game. So what openbox will do is it's going to create that folder if it doesn't already exist. And it's not exactly a folder, but let's just keep on with this analogy of it being a folder. So if that folder does not exist, if our world data box does not exist, it's going to create it. So we'll always have this, and this is a future. So let's await this again. So now we have successfully created a folder or a box inside of our documents directory. Now to access that box so that we can add or read things from it, we can do hive.box, then the name of a box. So world data box. Now inside of here, okay, so the hive.box returns a previously opened box. Right now we have access to the get and the put method. So we'll use the put method first, and then, so as you see here, the put actually saves the key value pair. So key will be how we're going to reference to that value that we just stored, and then the value will be the value. So as you see here, they are both dynamic, meaning the key can be a string like this is my key, or it can be a integer like 2 or 2.3 or whatever. So let's actually just make this an integer. So let's say 1. And under the value 1, let's save the string hello. Okay. And we don't need to await this or anything. But okay, it says here it's a future, but we don't really need to await it. But We can just in case, but we don't really need to. Right, now let's actually not run our app. Let's comment this as a group by selecting it and then holding Shift Alt, then A. Now let's not restart our game, or actually we haven't run our game, so let's run it first. So what's going to happen is we're going to first initialize, Flutter with the documents directory. We don't really need to know what's going on here. We just need to do this. And here we're creating a folder called World Data Box. Since this is the first time that we are running our game, it's going to create the folder. But if next time, if that folder already exists, it won't do anything. And after this, what we're doing is we're awaiting a value, and not we're awaiting a line of code that accesses that folder. We're just calling it a folder again, but it's actually a box. It accesses that box and then puts the value hello referenced with the key 1. So it'll be like we're creating a file named 1, and inside of 1 we'll have the value called hello, and that is just an analogy. It's totally not at all how it works, but yeah. Okay, so our game has built, and then we see nothing here because we have not exactly used the run app function to actually run something, but we can assume that this has already been run. Right, let's just make sure by printing something like saved the value, and let's sort of restart our game, and let's go into the debug console. Okay, so we get the print statement saved the value. Cool, so everything's working without any errors occurring. Now the value hello, or the string hello, has been put under the key 1 into the world data box inside of the documents directory. So even if we remove this, and let's say I shut down my computer and came back again, that value will still be there. So now at any time we can actually get that value. So now let's try getting that value. The value is a string, so let's do string value, or let's just say value equals. Now we need to access the box again to access the get method. So hive.box world data box. Now we use the get and then pass in the key. So 1 was the key, right? And now let's just print value. And okay, so we've removed the line of code that actually adds in the value, because once we've done it, we won't have to do it again. It's a permanent thing, right? Now let's restart our game, and then we hopefully should see hello. Right. And this will still print hello if we shut down our computer and come back after a while later, because we saved that value to our documents directory into our disk. And now just like that, we'll have to save our actual instance of world data into our disk. Like, let's say this is the unique ID, and let's actually remove this, and we'll have to pass in the instance of world data. And this currently will not work because we didn't register an adapter for it. But when we did, when we did string hello, Hive already knows how to convert the string into the format that it needs to actually read and write data, but it doesn't know for world data because it's it's something that we created. So we'll have to add the Hive type, Hive fields, and then add an adapter for it, and then register the adapter to get this all working. Now let's add a world saving feature to our right world lists, or our right world chunks, and our left world chunks, so that if you make changes to a world, and here's a cave that I've made before, and if you add those and then click on this button here, which is basically just an icon button which saves the current world data into a key. So if you save this and hot restart the game, you're gonna get the same thing, because the world list is actually stored, right? So we'll be doing this by creating a type adapter for the world data, and then adding the seed, because we want the seed to be a field, then the right world chunks and the left world chunks as a field. And the left world chunks and the right world chunks are a list of blocks, right? And blocks is a new data type that Hive and Dart in general is not familiar with. So we'll also have to create a type adapter for that. Okay, so let's actually create an adapter for world data so that we can actually use the put method to write data into this key and also use the get method to get that data. So for that, since this is a custom class, we need to define an adapter. So let's go inside here, control, and then click. And first we need to define the Hive type. So this will be a decorator, Hive type, and then we'll give the type ID as 0. So we'll have multiple different adapters in our game, like maybe an adapter for a new class, maybe like the inventory manager, the crafting manager. So we'll have new adapters like that. And for each adapter, you have to give a Hive type. So this is like its unique address. So this parameter can be used to keep track of old field IDs, which must not be reused. So this has to be unique to whatever adapter we're creating. So we give the type ID to this as 0. So if we create a new one, we'll give it as 1 or so on. We should never repeat this. And here, we'll now define all of the fields that should be stored. For example, maybe we don't want to store some fields like, we don't want to really save the mobs. So we don't really want to make this a field when we are saving the game. So if we save the game, we don't want to save the current instance of mobs because it's okay if we restart from a new fresh instance. Same for, let's say, all of these. So, this is not something that we can store either. So chunks that should be rendered. This is defined by the player's actual index. So we don't really need to store this either. So we'll define all of the fields inside of the world data that should be stored with the decorator Hive field. And then for each Hive field, we need to give not an instance, an index. So 0. So we want to store the seed. So this is a value that should be stored. So we adding the Hive decorator to this, and then we're giving the index as 0. Now let's actually add the Hive fields to our right world list and not right world lists, our right world chunks and our left world chunks. So we also want this to be stored because this defines how our world will look, right? All of the blocks and stuff. So let's do Hive field and 1 because we already used 0. Now finally Hive field 2. So now when we actually save our world or use a put method, all of these values will be stored and all of these values will be left as blank or what they usually start off as. Right. So we have defined how, the basic structure of our actual adapter. So this is a Hive type of 0 and then these are the fields that should be stored. And now to actually create the adapter, we first need to part this. So let's do part, and this will be done at the top of the file. And what's the name of a file? World underscore data. So we do world underscore data, and then we'll have a dot, then g dot dot. Now we will run the command that will actually create our adapter. So it'll look inside all of the files and all of the, okay, so it'll look inside all of the files and folders inside of libs, and then find a file which has the part keyword with this string. So world data.g dot dot. And let's say we are doing this in another file. Let's say we're doing this for our inventory manager. So if yes, inside of inventory manager, we'll be parting it as whatever the name of the inventory manager is. So inventory manager file name.g dot dot. Now let's run the command so that our actual adapter will be created. So let's go inside terminal and type in Flutter packages pub run build runner build underscore runner, then build, then a tag, delete conflicting outputs. You don't really need to memorize this. I don't know either. I was just reading from something I wrote down somewhere. So you can just refer to this one here every time you want to run the command. So now let's click on enter. Okay, so this has done running, but as we see here, no adapter file has been created. So, what will be an adapter file? So it'll just be a new file here with a black and white dot logo, but as we see here, nothing has happened and a command didn't fail either. And that is because we forgot to save this. So let's save this and then run the command again. And good news, you don't have to type it all out again. You can just press the up arrow key and it will, come back to the last command that you just ran. Or, oops. This usually works, but it doesn't for now, but it should definitely work for you. But for now, I'm gonna just copy this and then paste it here. Okay, now let's run it again. Okay, so this has done running. And as you can see here, we have the black and white logo and a new file called worlddata.g. And the error at the part line has gone away because there is an actual file that's been created. And this is the adapter that has been created by a command. So it's a class called worlddataAdapter. And you don't really need to know anything about what's going on in this code, but it's you can maybe get some ideas about it. Like here we have the 0, which relates to seed, because we set the Hive field of it as 0, then 1 right whole chunks, then 2 left whole chunks. So every time we add a new field, we are gonna have to, remake this adapter and stuff. So this is basically just how Hive it's going to read and write our data and stuff. So yeah, we don't really need to worry about this. But now to actually, use this adapter so that we can read and write world data instances, we're going to have to go into our main and then register this adapter. We will do this right after we have initialized Hive with a function called hive.registerAdapter. And then here we can pass in an adapter. And this takes in a type adapter, which is exactly what our world data adapter is. So let's enter. And yeah, that is it. And this is not a future or anything, so you don't have to wait it. So now we have registered our adapter. So now let's try something else. Actually, before that, we just, added a key 1 with a value as hello, a string or something, right? For our last example. So let's say we wanted to remove all of that. So let's access the box. And we have hive.box world data box. And then to delete everything inside of a box, you can do dot delete all. And or let's not do dot delete all, let's just do dot delete from disk. So this will just delete this entire box from our disk. And I'm pretty sure you gotta await this. So let's do that. And let's hot restart our game. So okay, everything works and nothing has changed except for the fact that our world data box folder, just following the analogy, has been deleted. So now let's remove this and if we hot restart it again, our world data box has been created, since it didn't because we just deleted it with the delete from disk method. I didn't really have to do this, but just to make sure that everything inside of a world data box was instances of world data, I did that. Right. So now here, let's try putting a value or an instance of world data with the hive.put method. So let's first access our box. So hive.box, then the name of our box, world data box. Actually, let's do something else. So every time we are actually typing out the string for world data box, maybe like in a really critical area, we accidentally had a typo and we spelled it wrong. Let's say we did WRD data box, like word data box. This would completely break our game. So let's cut this or just copy this name and then go inside of a constants inside utils, Control P, constants, constants, and let's create a constant that will be of type string called world data box. Now this will just be the string. So now we'll have interlicense to actually do world data box, and then it'll actually do this. So we cannot spell this wrong in any way, right? So in every area where we're having the string, we'll just do world data box and world data box. So this is the same thing, but a little bit more secure. Now let's try putting our world data So let's try 1. Let's just put the, key as 1, doesn't matter. And world data. For the seed, let's give 188, or let's say 1, 2, 3, 4, 5. Okay, so this should technically work because we have registered an adapter for world data. So let's hot restart our game. And okay, let's see. Go to the debug console. Okay, everything seems to be fine. So now let's uncomment this, actually comment this, and then try reading this value. So let's print hive dot box, then world data box dot get 1. So this should print instance of world data if everything went right. So let's hot restart our game. And okay, it does say instance of world data. Cool, so that's working. So now let's uncomment this. Let's select it from the beginning of the slash till the end of the slash, and then hold Shift Alt and A. And let's go inside game layout, and let's actually cut this. Let's go inside game layout, and where we are actually passing in the game widget, for the world data, we will pass in the instance that is saved in our disk. So let's remove the print statement actually. Let's paste this and then remove the print statement. So hive.box, world data box, we gotta import all of this, dot get 1. So this is the world data instance that has been saved to our disk. Let's hot restart our game. And let's see if everything works. And it does. Cool. So let's try hot restarting this multiple times. And as you just saw, this actually changed. The terrain changed. So our saving mechanism is not working. That is because we don't really have a saving mechanism at all. So we want to make it so that when we press the save button, the current world data instance gets saved at some key. Okay. It might sound a little bit complicated right now, but I swear it really isn't. So let's go inside layout and then actually create a button. Let's call it quit and save button dot. This will be a stateless widget. Quit and save button. And let's go inside of our images here, and then into the GUI, actually not the GUI, into the launcher, and actually not the launcher either. Never mind, just ignore what I just did there. We're going to be creating an icon that will actually be there. So let's return an icon button. So we want an icon of some sort, and then if we want to click on it, or if we click on it, we want some sort of a method to happen. So that's why we have an icon button, and then this takes in a widget. So icon, and for the icon, let's pass in icons dot save. Enter, and let's make this a constant. And when this is pressed, let's do something. And let's actually first display this onto our game layout. So we want this to appear on our GUI. So let's go inside game layout, Control P, game layout. And at the end of this, we'll simply add this constant, quit and save button. Let's hot restart our game. Okay, so we've got our button at the top left, and let's actually make this appear at the top right. So let's go inside of our button, inside of layout, and let's wrap this around a position.fill, wrap with widget, position.fill, and then we'll wrap it around an align, wrap with widget, align, and then we'll give the alignment as alignment dot top right. Cool. And then let's actually change the icon to, from save to exit. Oops, not exist. Exit to app shop. Let's hot restart our game and see how this looks right now. Okay, so we have it appearing in the top right, but we have this debug symbol that's kind of blocking it. So let's go inside of our game layout. Actually not a game layout. Into the main. And then here, where we actually returning the material app, let's set the debug show checked mode banner to false. Now if we hot restart our game, that shouldn't be appearing. And it's not. Cool. Now let's make it have a gray color just to match the theme of our GUIs. So let's go inside of the quit and save button. And inside the icon, let's give it a color, colors.gray. Right, let's format everything up by putting commas everywhere and saving the game. Okay, so we have it appearing here, but it's a little bit too light. So let's give it gray of, let's say 800. So this should be a really sharp gray, and it is. And now we can, a sharp gray, a dark gray, and we can remove the constant keyword because it's no longer something that's constant. Let's also give it a width and a height, and we can do that by going to size, and let's give the size as 50. So 50 pixels in the width and 50 pixels in the height. Let's see how this looks. Okay, cool, we have it, but it's kind of aligned really to the left. That's because of how icons work. So let's wrap the entire icon button around the padding, and let's give only padding. So edge insets dot only. To the right, we'll have 20 pixels of padding, and to the top, we'll have 20 pixels of padding. So we'll have some padding to the top and the right. Now we should have it appearing somewhat a little bit to the bottom left. And yeah, we do, but I guess we don't really need the top padding, so let's remove that. Okay, now let's see it again. Okay, that's perfect. So every time this button is clicked, we want to save the current instance of world data, or a world data, into what we are reading from. For example, so let's go inside of our main, or not a main, our game layout. So here we are reading from the key 1, right? So at the beginning we are reading from it, and then as we play throughout our game, the values inside world data will change. For example, we picked up a grass over here, and then we changed the actual right world array. So, when these happen, it's not going to actually change the actual instance of world data that we'll be getting it from. So to actually make it so that it updates, when we click on the save button, or this is the button that we'll click to actually leave our game. So whenever the player's leaving the game, we want to save the game. So to save it, we're simply going to do hive.box, world data box dot put. Then we'll get the value of what we are reading from, so 1, and then we'll pass in the current world data instance. So it is whatever we had in the first with all of the changes that have been made, right? So that is a way of updating our, actual world data. So let's go inside of the quit and save button, Control P, quit and save button. And inside the on pressed, let's first do hive.box, world data box, and then we're going to put it to the key 1. So it's going to override whatever is inside of key 1. So at the beginning, we had an instance of world data, and we read that at the creation of our game, and then we made some changes to, okay, so we copied the world data as that, and then we made some changes to the copy world data as we, progressed in our game, like picked up the sandbox and we made changes to the actual chunk. We made actual, inventory, changes to the inventory and stuff. So that changes will be occurred inside of our world data. So we're going to override the current value of 1 with the current world data. So to actually get the world data, we're going to do global game reference dot instance dot game reference dot world data. And it's that easy. So let's hot restart our game. And one more thing, currently we only have the fields as seed and right world chunks and the left world chunks. So the only things that will be saved is how the world generally looks like. Let's hot restart our game and let's go here. Okay, and we've got our world. Cool. Now let's try breaking something like these grass blocks and let's leave the game, or currently we won't be leaving the game. This will just save the instance. So we have got an issue. What is it? Let's go inside the debug console and let's resume this. Okay, so we've got some issues. Unhandled exception. Hive error. Cannot write unknown type blocks. Did you forget to register an adapter? Okay, so this is really expected. So let's go inside of our resources, actually our world data first. And as you see here, the right world chunks is a list of a list. And lists are types that Hive already knows how to read and write to. It already has registered adapters for it. But blocks is something that we created. It doesn't know how to read and write data of type blocks. So just as we did for our world data, we are going to have to register an adapter for blocks. But blocks is an enum, right? And that's totally fine. We can still do the same things. So let's go inside blocks and then do all the preparations to actually create an adapter. So we're going to do a Hive decorator. So Hive type and then type ID will be 1 this time because we already used up 0 for our actual world data. And we need to give the fields as each one of these. So let's start. We're going to do Hive fields 0 and let's copy this. And okay, so you might have thought that these decorators only apply to classes, but no, we can also do this for enums, right? So we have a Hive type ID 1 because we already used up 1 for our world data, and then we're gonna be defining all the fields as every item inside of our enum. So let's keep on doing this. 0 1 0 2 actually 3 and you gotta absolutely make sure that you don't type the fields in wrongly because that would totally break our game. 4 5 6 7 8 accidentally typed a 9 there. 9 10 11 12 13 14 15 16, almost there. 17 18 19 20 and finally 21. And let's save this so that everything gets formatted, and let's make sure that all of the Hive fields are correct. So we have the type as 1 and then 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. And now we also need to part this file so that we can create a similar type adapter for it. So just as we did in world data, we're going to part file name.g. Same for inside blocks. So here we're going to do part. What's the file name? Blocks, right? Now .g. Now we need to run the command again that will create our instance, or not an instance, that will create our adapters. So let's go here into the terminal and let's try the up arrow key, and that doesn't work for me for some reason, but it should for you. So try copying this and then pasting it again. So copy and paste. Okay, so we have Flutter, packages, pub, run, build runner, build, delete conflicting outputs. So this is the command again that will create our actual adapters. So let's enter. And okay, it has done running, but I made the same mistake again. I didn't save the file. So I'm gonna do that again, but hopefully you saved the file before running. Okay, so it has successfully ran. and our world adapter has been created. Not a world adapter, our blocks adapter. So here you can just go through here and then you see something that does things with our fields. We don't really need to know, we don't know anything about this, but you can just, read through this if you'd like to. Okay. Now we need to register this adapter just as we did for our world data adapter. So let's duplicate this down, Shift Alt, down arrow key, then blocks adapter. So now if we quit our game, it should be able to actually modify that right world list with our blocks because we have registered an adapter for blocks. Right, so let's try it out. Okay, so remember this, we have a desert at the right, birch forest at the left with a flower, 2 cactus, and a dead bush. So let's save this. Okay, I've clicked it once and no errors occurred. Now if we restart, if it didn't work, we should just end up with a whole new world. But if it did work, we should end up with the same world. So let's hot restart our game. And yeah, as you just saw, we got the same world. So just to prove it to you again, let's break some blocks. 1, 2, 3. This is quite a distinct pattern. So remember this, let's save our world or restart our game. And okay, so we have got the same thing here. So our world list is successfully saving. So let's go over everything that's happening. So in the beginning, we are copying our world data from a saved instance of our world data for this specific world. Then we are making changes to the current world data that's running. And then, after loads of times when we have made changes to our world data by, making changes to our world, putting things in our inventory or whatever, we are overriding the world data that we first copied from to the world data that is currently existing now. So let's try that again. So we created a kind of cave thing here. And if we save it and hot restart our game, we should end up with the same changes. So, so we have the same thing, right? And this will also work if you shut down your computer and come back later. This will still be here. Now let's make a few changes to our actual saving and reading data so that the actual key will be the seed of our world, because the seed is actually something that will be really unique and random. So we'll also create a function that will return us a random value. And then we'll also make our inventory save. So if we break a leaf, we have 1 leaf in our inventory and then 1 stick. So if we save this and then hot restart our game, we should start off with again 1 leaf and then 1 stick. Cool. And this will be the same even if we shut down our computer and then come back, later, and then it'll still be the same. So right now, when we are creating a world, we have to provide in a seed. So, this is something we have to manually type in, but let's make it so that this will be a random number. So let's go inside of our game methods and then create a function that will give us a random seed. So here, let's go all the way down. And this will return an integer. So return type integer. And then let's call it get random seed. Okay. And, we could do one thing. We could do integer random, or let's just say integer seed equals random dot next int, and let's say we'll give a huge value like 10,000, or let's say 100,000 or 1 lakh. So if you do this, there's a problem. So the value could be anywhere between 0 and 100,000. But we don't want this. We want our seed to be an exact number of digits. So this is actually pretty easy. We're simply going to add 100,000 to whatever value we get here. So now we'll definitely guaranteed get a 6-digit number. So the maximum value we could get is 199999, right? Because next int calculates a value that is greater than 0 and smaller than the value you have placed. So now we have a method of getting a fixed random number, a fixed digit of random number. And here we'll just return the seed. Okay, cool. And now let's go inside main game or main or whatever. But right now we won't be exactly implementing this. So, later in the future when we use our game launcher to create a new world, we'll make it so that we'll use the game methods or instance.getSeed function to actually do it. Now let's make one small change into our quit button. So quit and save button. Here what we're doing is we're doing hive.box world data box dot put, then the key is 1. Now we cannot, we definitely cannot rely on 1 here, because eventually we'll have different worlds, and when we do 1 comma global game reference or instance dot game reference dot world data, we're just replacing what's inside 1 and not what the current world is selected. But this works for now, because inside of a game layout, we're just getting the value that is inside of 1, right? But let's change this a little bit. So let's first go inside main and then reset everything. And you guys know how to reset everything. Let's first not run our game, because that will cause some issues. Oops. Shift Alt and then A. And we'll bring this back. Actually, nope. And after we're opening the box, we're gonna just delete it. So hive.box, then the box name, world data box dot delete from disk. So this will entirely delete our box from the disk. So let's hot restart our game. Okay, so it has done running. So now we can assume that the box has been deleted from the list, or not the list, our our document directory. Now we can add a new block here, not a new block, a new instance of all data. So what we make this a little bit different. We'll make sure that what we are adding as the key is the seed for this. So let's first import game methods or instance dot get seed, or what was the actual function name? Get seed or get random seed. Okay, let's actually cut this and then put this inside of a value. So integer seed equals this, and then the key will be seed, and then the seed will also be seed. And this is fine, because we definitely, it's a really small probability that we'll get a random seed that is the same as another random seed that the player already has. So this is a good unique way of setting a key for it. But now inside of our game methods, let's go here. Control P, game layout, actually not a game methods. Here we cannot do get 1 anymore. We have to put the actual seed of the world, because we have put the key to be the seed. But for now, let's not do this. And let's go inside of here into our main and then just run this. So, okay, it has done running. So we have successfully put an instance of world data with a seed as seed, and then the key as whatever the seed is. So now we have another method inside of our world data box called values. So values will return an iterable. Let's just print this. So this will be all of the values inside of our game. So let's try this. Let's hot restart our game. And we should get some value. So instance of world data. Okay, not values. We want the keys, right? So let's try it again. So now we have saved the key as the actual seed that we got. So let's see. So 168971 was a random seed. So now we can go inside of the actual game layout, Control P, game layout, and put this here. So this is the key that we saved that world as in. So yeah, we'll eventually automate this process entirely when we create our launcher. And we're just doing this so that it'll be a little bit easier for us to make changes in the future. And so that we don't get too far into anything that it becomes too hard to change. And let's actually comment all of this out. And then finally, let's go into our quit and save button. And then here we'll change 1 to the current world data seed, because we know that the key is also the seed. So we can just do world data dot seed. So when that button is pressed, we are overriding the old value of world data or unupdated data into all of the changes that the player made, and we get the key as the seed. And that is the exact reason why we made all of these changes. So now we have a great way of actually getting a relation between the key and the instance. Okay, now let's go inside of inventory, our inventory manager, and then we need to create an adapter for this. But first, let's go inside of world data, and just like we have 2 fields here, 3 fields actually, the seed, the right world chunks and the left world chunks. So a field is everything that has to be stored when we actually use the put method, right? And we also want the inventory to be stored. So let's go all the way down to our inventory manager and then give it the Hive field decorator. And we'll put 3 here because we've already used up 0, 1, and 2. Cool. But this would usually work if this was just a string or something. But this is again a custom class that we have created. So even though this is a field, we still have to create an adapter for the inventory manager too, because it doesn't know how to read and write values of inventory manager. And by it, I mean Hive. So let's go here and then let's create an adapter for this. So we'll first give Hive type as 2 because we have used up 1 for our blocks and then 0 for our world data. So we need a unique value. So we're putting up 2. And we have a slight problem here. Now, okay, the only thing that we want to save here is the inventory slots. We don't care about anything else. So you would think that we could just do Hive field and then 0 something. But again, we have a problem that inventory slots is also a field that, or also a type that we have customly defined, and it's not something that already exists in Dart. So Hive does not know how to read and write for that. And the fix for this should be fairly simple. Just create a new field for this, right? Just make a new adapter for this. But we have a problem that we have one of the fields as an Rx. And Rx is not an integer. So, we cannot really create a new adapter for the Rx type too. So we need to, think of some other way to actually store our inventory slot data. So let's create a new list. Oops, let's remove this. A similar list. Let's duplicate this down. Shift Alt down arrow key. And just inside of here, we're going to create another class called class inventory slot save. And here we'll have our dynamic block and then an integer count. We will require this from the constructor. Or what are we doing here? Okay, we're going to do inventory slot. Okay, we also need the index or not. We don't really need the index. Let's require these from the constructor. Inventory manager, or sorry, inventory slot save. And then let's not exactly require this. We just assign it to a default value. So equals 0. So this, unlike our inventory slot, is, we can actually make this an adapter. But we cannot make the inventory slot an adapter because we have a different type of value for which we cannot have an adapter. Right. So what we're going to do is we're going to save our inventory, whenever the player clicks on the save here, as a list of inventory slot save. And then at the beginning of the creation of the game, what we're going to do is we're going to copy that inventory slot save list into our actual inventory slot list and then, display it like that. And it's totally fine if you didn't exactly understand what that means, but you will definitely get it once. But so first things first, we're gonna make the inventory slot to inventory slot save, and let's rename this to inventory slot save. Okay, And this will be an instance of inventory slot save again, and we don't really need to pass anything here. So we're just creating a list 36 long of instances of inventory slot save. And then let's actually have something inside of the inventory slot. Now, as I said, we will be storing our data of each inventory slot as an inventory slot save. Okay, so let's say I had, okay, so we have a wooden sword here. So when we actually leave the game or click on this button here, we want the actual inventory slot saves block to be set to items dot, or let's not change. Okay, it's fine if it's block. It's block to be set to items dot wooden sword and then count to 1. And then at the beginning of the creation of the inventory slot, we're simply going to replicate that same thing into here. So we need to require this. We first need the inventory slot to actually, copy it, right? So inventory slot save, let's call it inventory slot save, and then require this. Oops, not reactive. Required this dot inventory slot save, and let's pass this in where we're actually creating the instances. So for the inventory slot save, we're going to be passing in our new list inventory slot save of the index. And now, we cannot exactly access this here, so we're going to have to change the whole thing to a late. Okay. And why late? Because we cannot access the inventory slot list inside an inventory slot list initializer. We can only do this inside of a function or something, but we don't really want to complicate our code like that, so just late. Okay, so what's happening? Right now, what should happen is we're passing in our inventory slot save lists or all of the elements inside of that into our inventory slot, and then at the beginning, what we want to do is copy all of the items inside inventory slot save into our current block or count. So let's say we want the block to be the inventory slot save dot block. So we're doing this inside of the constructor because the constructor gets called at the beginning of the creation of that instance. So when we're actually creating this list here, so constructor block equals inventory slot save dot block, and then also for the count dot value equals inventory slot save dot count, right? And let's actually do a little bit of something. Let's set the count to 5 and then the block to blocks dot dirt or diamond ore or whatever you want. But okay, this is fine. Let's go inside the crafting manager. So here, let's also add the inventory slot save. It doesn't really matter here, so we're just doing this so that it doesn't give us an error. Inventory slot save, inventory slot save. So now what should happen is when we hot restart our game, our entire inventory should be filled with some things. Let's see. Okay, we don't see anything. That's because let's go inside of our main and then actually, oh, we are running the app, but okay, this is a little bit weird. Let's debug this. Never mind, that was just an error or just some fluke. It's working now. So what happened is each one of our inventory slots and the crafting slots has been filled up with 5 diamond ore. So why did this exactly happen? Now I'll begin to explain everything that we just did. So Control P, inventory, right? So we have inventory slot save, a class called inventory slot save with a block and a count. The only difference is that the count here will not be in RX, so that we can actually assign it as a Hive field. So when we are closing the game, we will define we will save all of that changes inside of this list, inside of our inventory slot save. So we have this as a Hive type. So we'll have this as the Hive field. So 0. And notice how we're not saving the inventory slots, but the inventory slot save, because that is the only thing we can save because we don't have a value of RX. And we also have to make this a Hive type 2. So Hive type, and okay, we have 2 here, so 3, and both of these are going to be fields. So Hive field 0, and these both are going to be fields because we want to save all these values, right? So Hive field 1. Okay, so again we are creating an adapter for that because we're using this inside of a field, and we cannot use custom classes unless we have defined adapters. Okay, now when we actually save this, what's going to happen is that nothing's going to happen. We're going to save an instance of this, and at the creation of our inventory slots, we are requiring an inventory slot save. That will be the corresponding inventory slot save to the inventory slot list. So we're doing inventory slot save of index, and then for each one of those at the beginning of the creation of an inventory slot, we're just setting the block and the count to that value, right? We can change this back to 0 and the block to nothing. But we have one last problem. We want the inventory slot save, the values inside of here, to update every time something changes. So let's say right now, if we hot restart our game, we're going to start off with a clear inventory. Nothing's going to happen. And yeah, we get a clear inventory. But if we add a new item, we want the actual value of the corresponding inventory slot save to change. Only then when we actually save our game will the actual value get saved, so that next time we open the game, the block and the count of the inventory slot value will be set to the values that once was when the game was saved. So we need some kind of logic that will make sure that every time the actual value of inventory slot block or count is changed, we can check for changes in count, because we know if anything changes in count, we know that either a block got added, a block got removed, a slot got updated or something. So we're going to check for changes in count. So count dot listen. So listen allows us to just check for constant values that will come out of count. So if count changes, this function will get fired, and then here let's call it value. The new value of count will be passed to here. So all we are going to do is set the inventory slot save dot count to the value. So to the new value of count that has just been changed, and we're also going to be updating the block inside of the inventory slot save. Because if the value changed, if the count changed, probably something weird occurred, like maybe we threw an item out which caused the count to go back to 0. So the block changed back to null or something like that. So we're doing count.listen. So this actually just fires, the function inside here fires every time the value of count changes, right? And we can do that because count is of type Rx. And every time it changes, we're just setting the value of the actual count to count of our inventory slot save to the current value of count, and then the block to the current value of this inventory slot. So now if we start our game, it's going to read the data from here, and then every time the data changes inside of the inventory slot, it's going to change the data inside of the inventory slot save. And when we close our game, we're going to start off with those saved changes again, right? Now we need to create adapters for this, so we have to part this file. Part, what is the name of a file? Inventory .g . Now let's go inside of world data 2, and then okay, we have added this as a field, right? So let's go over everything that we did before actually creating the adapter. So inside of inventory manager, we created a field not for our inventory slots but for our inventory slot save list, and we've done this because we cannot exactly save use a Hive field on Rx type, because we cannot exactly define a type adapter for that, now can we? And we just linking our inventory slot to this saved class. So every time the inventory slot starts up, it's going to copy the values from here, and every time the values inside the inventory slot changes, it's going to add that values to here, so that when we actually save our game, those values also get saved, right? So now let's create the actual type adapters. So okay, again the up arrow key does not work for me, so I'm gonna copy this and paste it in here. Let's save our game, not making that mistake again, and enter. Okay, it has done running, and we have the type adapters inside of our inventory.g.dot file that just got created. So we have a inventory manager adapter, and if we scroll down, we also got our inventory slot save adapter because we also defined that as a Hive field. Cool. And now let's also check for our world data. And here, as you can see here, we have a new field called inventory manager because we made that as a new field, right? Now, since we made this as a new field, we cannot exactly read from our old values. So, okay, let's see if that's true. Let's hot restart our game. Oops, so apparently we died. Okay, so type null is not a subtype of inventory manager in typecast. That is because we added a new field called inventory manager, but when we are actually reading the values or something like that, the inventory manager did not exist because when we created the instance of world data, we didn't have a field of inventory manager inside world data, now did we? So we're gonna have to clear everything inside of a box again. So let's remove run app so that it doesn't really run our game. And then let's clear our box. So hive.box world data box dot delete from disk. Let's hot restart our game. And now that box should be deleted from the disk. But okay, before that, we have to actually define the adapters for it. So register adapter, inventory manager adapter, and then finally our inventory slot save adapter. Inventory slot save adapter. Cool, let's hot restart our game again. Okay, and we still get an error. Okay, let's just comment this so that we don't open it, but we just straight up delete it from the disk. Okay, so that is still occurring. So we can use another method called hive.delete from disk. So what does this do? This deletes all of the boxes from our disk. So we shouldn't be getting that same error again. And we don't. So now we have cleared everything from our disk. So we gotta do everything from the start again. We gotta open this box so that that folder gets created inside of our documents directory. Then we gotta get a random seed, right? Then let's actually, create the instance of world data inside of our box. So hive dot box world data box output. The key will be the seed, of course, not the speed, the seed, and the value will be just an instance of world data. So world data, and with the seed as seed. Cool. Now let's hot restart our game. We shouldn't get any errors, but we do. So the type null is not a subtype of inventory manager in typecast. Okay, so let's try changing the world data box to something else so that we target a whole new box entirely. So I think we kind of did something wrong with that old box. So nothing should go wrong right now. Okay, so now we have hot restarted our game, and everything our new instance of world data should be added inside of a new world data box. So let's comment this so that we don't add a new one, and then let's just confirm it by printing everything inside of a new world box. So box world data box dot keys. So now we should get the actual seed. Okay, so we do. And let's paste this inside game layout here so that we actually get this seed here. So now everything should be good to go. Let's remove these comments here, and let's hot restart our game. Okay, we are in a world. Okay, before everything, let's go into our main game and then remove all of this code here because we don't really need this anymore. So let's hot restart our game again, and now we shouldn't get all of those tools in our inventory. And we don't. Cool. Now let's try breaking this leaf and adding it to our inventory. And let's save our game. Okay, I clicked on it and no errors occurred. Now let's try hot restarting our game. And now let's see if the leaves are still inside of that inventory. And it is. Cool, so that's working. But let's try it with something else. Let's break this wood right here. Let's turn that into planks. And the planks into sticks. Okay, now let's I'll try leaving the game and we get an error. Cool, this is actually expected. And let's see what the error is. Okay, unhandled exception. Hive error. Cannot write unknown type items. Did you forget to register an adapter? And this error we can fix. So that error is happening because, let's go inside of our inventory. Control P, inventory. Our inventory, block can either be an enum of items or block. We have an enum of blocks as a registered adapter, but we don't have the same thing for items. So we want our items to also be a registered adapter. So let's do all of that again for our items. So we have, let's go into our control P, inventory. Let's see what is the last inventory type or Hive type that we did. That was 3. So now we can do 4 for our items. So let's go in here. At Hive type, let's say 4. Okay. Now we'll just keep on copy pasting Hive field. We'll start from 0. Let's copy this and then go up till the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, we're reaching the end, 20, 21, 22, 23, 24, 25, and yeah, that's it. So let's make sure that we haven't repeated any of the indexes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Right, cool. Now to create the actual adapter for this, we gotta part this. So part, what is the actual name of this file? Items. So .g dot. Let's save this. Let's go inside here and then run our command again so that our actual adapter will get added. So copy, paste, and enter. But before that, let's save everything just in case and enter. Okay, so we've got an error. So we've got an issue. Contains the following errors. Items dot directives must appear before any declarations. Cool. So I think that's because we did our part under here right after we defined the enum tools part. Okay, so now the squiggly lines under part has disappeared. So I think this is the correct way to do it. So let's run this again. Terminal. Oops. Oh god, now I gotta copy it again. Oh, never mind. Now the up arrow key is working for some reason. So now let's enter this. Okay, so that ran successfully and we have got our items adapter. Cool. Now let's register this inside of our main. Up here, Hive.register adapter, then our items adapter. Cool. Let's hot restart our game now. Okay, so we've got our leaf And let's try getting our hand on any kind of an item. So let's move on here. Let's see if we can find a desert or something, because it's easier to craft a stick like that. Okay, so we've got a desert and let's break this dead bush. And we have a recipe so that if you put one dead bush inside of the inventory, you'll get one stick. So we have a stick inside of our inventory. So that's an item. So now if we leave our game or save this, we don't get any errors. So our save has been done successfully. So let's hot restart our game and then see if it works again. And we should start off with 2 leaves and a stick. And we do. Cool. And it seems that we are in the air for some reason. Let's see if that was just a random error. And it wasn't. So we gotta fix that. Actually, never mind. I just hot restarted our game again and it seems to be working now. Cool. So now our inventory is saving and our actual world terrain is also saving because we had broken these leaves down and they are still not here. Cool. So now let's work on saving the player's hunger and health so that when we leave the game at a particular hunger and health and then join back, we'll have the same hunger and health. We'll do this by making the player data a field inside of our world data. So right now, let's fall down here. So our health is now 7 and the hunger is 8. Now if we save this and then hot restart our game. So we start off with 7 health and 8 hunger and not full health and full hunger. Cool. So pretty simple, right? We just need to add our player data property inside of world data as another Hive field so that, when we read and write our data, this will be included as one of the fields. But not really. It's not exactly that easy because here again, just like our inventory manager, we are using RX doubles and RX bools. So we cannot, create another adapter for this and another adapter for the RX integers because yes. So we need to figure out some other way and that would be the same as what we did here. So we created a new class called inventory slot save with the properties as the same but without the RX part. And at the creation of the actual thing here, like here this will be our player data, and this here let's say it will be our player data save. So our player data save will contain an integer of health, okay, not an integer, a double of health, a double of hunger, and a bool of is player dead. And inside of the creation of the player component, which will be the inventory slot here, we'll just do the same thing. So we'll assign the values to that and then also add a listener to it so that every time the values inside player component changes, we want the value inside the player data save to also change. So let's do something like that. Right, so let's create the class player data save and let's create the fields double player hunger, or let's just call it, okay, player hunger is fine, player hunger. We're going to set this to 0 just, or by 10 we'll set it to 10. So oops, not hunger, so it'll start off as 10 and then the player health then 2 and then player is dead, or this will be a bool, player is dead, this will be false. And we need to make an adapter for this because this will be a value inside of our world data that we need to save, or a property. So let's first add that. Just right above our player data, we're gonna do player data save equals player data save. Okay, so we won't be creating the actual we won't be making the player data a Hive field, but we would be making the player data save a Hive field, and then we'll pass in this player data save inside of player data and then make the player data like create its stuff accordingly. So let's create a constructor. Actually, let's first define the player data save property inside of here that we're going to be requiring. So player data save, player data save, and let's take this in as a parameter from a constructor. Required this dot player data save. Okay, and oops, lost the curly braces and the parentheses. Okay, now we want to initialize the player health or the player hunger, and the player is dead based on the player data save. So we're gonna remove this and then do player data save dot health, and this is just a double, so to make an OBS we're gonna do dot OBS. And since we cannot exactly access this inside of the initializer, we're gonna have to make this a late property, right? And same for here, we're gonna change this to player data save dot player hunger dot OBS and make this a late 2. Same for the player is dead property. So player data save, player data save dot OBS, and then finally we'll make this a late property. And let's actually go inside of the constructor and then define the actual listenable for this. Actually before that we seem to be having a problem here. Okay, sorry, player data save dot player is dead dot OBS. Okay, now let's go into our inventory, and inside of the inventory slot, inside of the constructor here, we're first setting the values to whatever value we had there. Okay, we don't really care about that right now, but what we care about is actually listening for changes inside of the health and hunger. So if the health or the hunger changes, we want to change the player data saves health and hunger, so that when we actually save our game by clicking on here, that value gets changed. So let's go here. Oops, not here. Okay, but before that, inside of the player data, we are gonna pass in our player data save as player data save, right? And then we're gonna have to make this late property, and we also have to make the player data save okay, not an override, a Hive field, just as we talked about. So 0 1 2 3, and then this will be the 4th field. Okay, and that's it. Now let's go inside of the player data, and we're gonna actually add the listenable. So we gotta listen to what values, the player health and the player hunger, and then if it changes, we want to set the new health and hunger to our player data saves health or hunger. So let's first listen for changes for the health. So player health dot listen. This will be the value, the new value of the player health, and then we're just gonna set it to player data save dot health equals player value. And yep, that's it. Now for the player data health or our player health, player hunger, sorry, I'm gonna listen to this, and this will be the new value. And for the new value, so every time this value changes, we're gonna get the new value. And here we're gonna do player data save dot player hunger equals value, right? So that's it. Now since that we actually added a few things here, once again, yeah, so since that we added a new field inside of player data save or our world data, we're going to be running the command to actually create our adapter again, and same for here. So let's go inside the player data, and then since this is a field inside of world data, this also we need to create an adapter for this too. So let's make this a Hive type and 5 this time, because we have used up 0 1 2 3 4. Let's confirm that going in by going inside main and then saying 0 1 2 3 4. Okay, so now we have the 5th one, so let's go inside the player data, and all 3 of these will be fields. So Hive field 0, Hive field 1, and finally Hive field, oops, 2. And to actually make the adapter, we're gonna have to part this. So part, what's the name of the file? Player data. So player underscore data dot g dot dot. And okay, now let's save everything and then go into our debug console, our terminal actually, and then press the up arrow key to actually get our last command that we ran. And then let's just click on enter. Okay, our command has done running, so let's go inside playdata.g.dot. And here we have the player data save adapter. Cool. And let's also go inside the world data.g.dot and let's see if a new field has been added. So yeah, player data save. Cool. Now we need to actually register this adapter. So let's go inside main and do hive.register adapter player data save adapter. Cool. But now the current world that we have does not have a field in its world data as the player data save. So, that's because we created the instance when we only had a few things inside of our world data, and then we just created the player data save field right now, right? So this will give us errors. So what we have to do is we're gonna comment all of this out. So Shift Alt A. Then we're just going to delete this box. So Hive box. Then let's call the box okay, world data box, of course, and then delete from disk. Cool. Let's hot restart our game and then hope that we don't get an error. Right, we get this error, but I think we can fix this by uncommenting player data save adapter registration. And okay, that didn't work. So let's remove this comment. And rather than deleting from the disk, let's just go inside of our world data box and then change this to 2 so that we get a new box. Cool. So we can uncomment all of this. So since we have a new box, we don't have any worlds inside it. Let's actually comment out our run app again so that we don't run into any weird errors. And here what we're going to do is we're going to uncomment this too. So we're going to select from there to here and then hold Shift Alt, then A. We're getting a random seed and then we're adding that world into our, an instance of world data into our world data box. So let's hot restart our game. Okay, we didn't get any errors. Cool. And now if we go into our debug console, we should have gotten the print statement for the actual seed. So all the way down here, this is the seed 106119. And we need the seed for our game layout to actually get it from our disk. So we'll pass in the disk here for our main game world data. Now let's hot restart our game. Actually, oops, we did a mistake. Let's go inside of our main, uncomment run app, and then also comment in this so that new worlds don't get created. Okay. Right, now let's hot restart our game. Okay, so we are successfully put into our game and then we have 10 health and then full hunger. So let's try just getting our health to something low. So let's just dig down. And let's try falling in here. And then right after we fall in here, let's save the world. Actually, our hunger has gone down, so we don't have to, do it quickly. So we are at 9 hunger and then 7 health. So let's save the world. Okay, so no errors occurred. That's a good sign. Now let's hot restart our game. So we should start at that same values, and we don't. Okay, so that is because let's go inside of our player component. Player component. Okay, and here we, when we are actually in the onload, we don't set the health to anything. So yeah. So when we're inside the onload, or when any entity perhaps has the health always set to 10. So when we actually add a player into the game, the health is being set to 10, but we don't want that. So inside our onload, we're simply going to set our health to whatever health we have inside of our player component data, or our player data inside of world data. So we're just going to do health equals world data. Okay, we can't access the world data. Of course, I'm so stupid. The global game reference dot instance dot game reference dot world data dot player data, then dot health, or oops, health dot value. Okay, so at the beginning we're setting the health to the actual health so that it doesn't like just pop up to 10. Right, so now we should have 7, and we do. Right, so let's try falling in again and then losing some hearts. So now we have 5 hearts and then 9 hunger. Let's save. Okay, now let's hot restart our game. And yeah, we get 5 hearts and then 9 hunger. Cool, so that's working. Now let's also add the sky timer as a Hive field inside of our world data, so that if you leave the game at a particular time, so let's save this, and then if we hot restart our game again, we should arrive at the game at that same exact time. And we do. So to save our current sky time, we just have to make our sky timer property inside of world data another Hive field. So let's do that. And we have our Hive fields up till index 4. So this will be the index 5. So at Hive field index 5. And since sky timer is a new class that we created, we also have to create an adapter for that. So let's go inside here. And okay, so first let's create it for sky timer. Right, so this will be a Hive type. And let's go into our main and then assess how many Hive types we have already. So 0, 1, 2, 3, 4, 5. So this one will be our 6th one. So let's go into the sky timer, type ID 6. And the only two things that we'll save in here will be the sky timer in seconds and then sky time. And this is the reason why we didn't make this a component. Because if it were a component, we wouldn't be able to save the time in any way, right? But since we made our own timer with a double and then adding our DT each frame of our app, we have, found a way where we can just save this double to actually get the current time and stuff. So that's why we did it this way. So Hive field 0 and then Hive field 1. And that's it. But one more thing, one last thing. Since sky timer enum is also something new that we defined, we have to create the Hive type for it too. So let's put a comma here and then format it first. And let's do at Hive type. We have till 6. So this will be the 7th one. And let's define the Hive fields. So 0, then 1, oops, and finally 2. And we need to create the actual adapter for it. So we have to part this. So part, what is the name of this file? Sky underscore timer dot g dot dot. Cool. Now let's go inside of our terminal, save our file first, and then run the command to create the adapters. So let's just click on the up arrow key and enter. Okay, it has done running. So let's go here and into skytimer.g.dot. And as you can see here, we have the sky timer adapter as well as the sky timer enum adapter. Cool. And if we go into the adapter for our world data up here, we should see the new field sky timer. Right. And now before registering these adapters, let's go inside main and then delete our boxes first. So let's first comment these two, Shift Alt and then A, and let's delete all of the boxes. So Hive dot delete from disk. That is because now we have, since we created a new field, the existing instances won't have that field, and then it's going to create some weird bugs. So every time we add a new field, we're just clearing the disk. Okay, so we get a problem here. Type null is not a subtype of sky timer in typecast. Okay, so let's just comment all of this by selecting it, then Shift Alt A, and hot restarting our app. Never mind. So that was not the fix. So let's do what we did a moment before, and let's just go inside the constants and then set the world data box name to something else. So we get a brand new box. Now let's go inside main.dart and then uncomment this first line so that we create a new instance and then we add it to our box. Let's hot restart our game. And before that, we have one thing to do. We have to register the adapters. Hive.register adapter, sky timer, adapter. And then finally, let's duplicate this down, Shift Alt down arrow key, and then sky timer enum adapter. Cool. Let's hot restart our game. Oh, okay. So we get an error. That's because we forgot to remove hive.delete box from disk. And since that happened, we know that all of the boxes inside of a documents directory got deleted. So now we can go inside constants and then, just we have no reason to do this, but let's just change it back to world data box. Since everything has been cleared, we can expect this to be an empty box and for it to not exist at all. And it'll get created when we do hive.openBox. Right, let's restart our game now. Okay, so that apparently doesn't work. Okay, we have no reason to do it anyway. So let's change it back to 3. That's really odd though. Okay, so we ran it and we didn't get any bugs. So let's comment this out again. Yeah. And let's uncomment these. So, and let's actually comment out run app again, Shift Alt arrow key. So now if we run this, we'll get the actual seed because we're printing all the keys inside of our world data box. So this is the seed 118928. And we'll simply add that to our game layout. So game layout. And for the seed, we'll paste this in here. Cool. Now let's go inside main and then uncomment run app. Cool. And let's restart our game. Okay, so it's morning and I'll wait till it's evening. Or let's just temporarily go into our constants and then set our total time in a day to something like 50 or 30 and hot restart our game. And the problem with this is that we might forget to change it back and then it'll totally mess up our game, but it's totally fine if you remember to change it back. Okay, our game has loaded up. And so now in exactly 10 seconds, the sky should change into evening. Right. And now let's save the game. Cool, I clicked on it. No errors occurred. Good. Now if we hot restart our game, we should start at the evening. And we do. So that's working. Now let's create the launcher screen. So this will just be a stack with the base widget as a panorama widget. And the panorama is just this 3D effect right here. And then on top of, that stack or that base widget, we have a column with the Minecraft logo image, 2 buttons, custom Minecraft buttons, one for single player, one for multiplayer. Multiplayer currently does nothing. And then at the bottom we have, this is an experimental game made for education. Check out the actual game Minecraft, just to give credits. And if we click on single player, we're gonna go into our game. And we'll eventually make it so that it goes inside of a world select screen and not into a game directly. Okay, so let's go inside of the screens folder and then create our file for the menu screen. So all the way up here, actually that was pretty close. And let's create the file menu screen dot. This will be a stateless widget. And let's call it menu screen. And inside of the build, let's return a scaffold, because this will be like one of the main things. Like, it won't be inside a scaffold, it'll be a scaffold on its own. And then for the body, let's just pass in a Minecraft button widget the text as load world, and then the on pressed as nothing for now. So let's hot restart our game. And at the beginning of our game, we don't want to go straight inside the actual main game. We want to go inside of the menu screen. And then in the menu screen, when the player clicks on play world and then selects the world, only then we want to load up our world. So let's go inside main, control P, main. So here we're returning a material app with the scaffold as game layout. So we're going to simply, not the scaffold as game layout, the body of the scaffold as the game layout. So we're going to simply remove this. We're going to remove the game layout and then pass in our menu screen. So menu screen, right? And we made a mistake. Since we already have a scaffold here, there is no need to, actually have the scaffold inside of a menu screen because it's already there, right? So now let's hot restart our game and then we should go straight inside menu screen. And we do. So if we click this button, we want to go inside of the actual game. So let's make it so that that happens. So this is fairly easy. We just need to, let's first go inside of a menu screen. So inside of the on pressed, when it's pressed, we simply need to navigate to our game layout. So that will just, make our game exist. So let's do that. To actually navigate into our game layout, we're going to do navigator dot push replacement. So the actual core stack will be removed. We don't want to, push it. Pushing it would just make sure or just create it so that our new screen, which will be our game layout, will be on top of this screen. We don't want that to happen. We want this screen to disappear entirely and that screen to come on. So that's why we're doing push replacement. And then for the new root takes in a material page root or a root. So we're gonna have to do material page root, and builder, we're gonna just return our screen. So let's return game layout, not a screen but a widget, and this takes in the context. And let's make this constant because why not? Comma and a comma. So now if we click on this, we should go into our game layout, which is our game. And no, it doesn't. We have an issue. So no material widget found. Okay, that is pretty odd. Let's go inside. Okay, I think that issue is because of a scaffold again, but I'm not too sure. Let's just try and debug this. Scaffold, and we gotta change this to body instead of home. Let's try this again. And no, that's not because of a scaffold. So no material widget found. That error usually occurs if we don't have a material app as one of the parents, but we do. So that is very confusing. Okay, so let's try something. Let's remove the scaffold again because we know that is not the issue. And since we're using push replacement, my best guess is that we don't have a scaffold for the game layout anymore. So let's try and wrap our game layout around a scaffold. Scaffold. And body. Now, since the parent is also a constant, we can remove the constant keyword from the child. and then add it to the parent. Oops, not body. So way off. Constant. Cool, let's restart our game. Okay, now let's click on load world. And we arrive at our world. Right, nice. Now if we click on the save and quit button, or the quit and save button, we wanna go back to our menu screen. So this is also pretty easy. Let's go inside save or quit and save button. And then after we have saved our world, so saving world, overriding the instance inside of the seed key. And after we have saved it, we simply want to navigate back to our menu screen. So navigator dot push replacement. New route will be of type material page route, where we'll return the actual thing or the widget that we want to show. So context menu screen. Oops, menu screen. Right. Let's format everything up. Commas, and this can also be a constant. So navigator or push replacement, context material page route. In the builder, we're returning the menu screen. Right. Let's restart our game. And so now if we click on the save button, we should go back into this screen here. So let's click on here. And we don't, so no material widget found. Okay, so now you guys know how to fix this. Let's go inside quit and save button and then wrap this menu screen around a scaffold. Because I have no idea why that's occurring, but whatever. So let's wrap this widget around a scaffold body. Okay, constant. Or I think the problem is, let's actually try to fix this. I mean, this is currently fixed, but it's kind of weird, like always returning a widget with the scaffold attached. So if we try and leave now, everything's working, but let's try and fix this issue. So let's remove the scaffold from inside of here. Yeah. And then add the scaffold individually inside of the base widgets, like the menu screen. So scaffold, I'm gonna change the child scaffold. Oops, not a scaffold, the body. And now we no longer need the scaffold here because we're gonna make this change to our game layout too. So let's wrap our stack inside of game layout with another scaffold. And we'll change the child to body. And let's go inside of our quit and save button, and we can remove the scaffold that we're returning from here. Not constant menu screen, constant menu screen. Oops, how did I mess that up? Okay, right, now let's restart our game, and then we hopefully shouldn't see any errors. Okay, yeah, so we fixed that issue without any weird remedies and stuff. Okay, so cool. Now inside of our menu screen, we want to figure out how to do the panorama. This is really easy. So let's open up Chrome and then go into panorama. So this is the pub.dev of the panorama package. This is a 360-degree panorama viewer. And it's really easy to use. So you just need to create the panorama widget and then pass in an image as the child, and it automatically creates a panorama like this. Okay, so let's import this into our game. Let's copy, or let's go inside examples, and then not examples, into installing. Copy this, and let's go inside of the pubspec.yaml file and add this as one of the dependencies. Let's fix up the indentation. And right, so now let's save the file or run flutter pub get. Okay, it has done running. Now since we added a new package, we're gonna have to stop running our game and then run it back again. So let's wait for it to terminate and then let's run it back. Okay, our game has built. So now let's go inside of our menu screen and then actually add the panorama. And okay, we're going to be doing this. Okay, let's first remove this Minecraft button widget from here. Or let's actually make this a scaffold or a stack. So let's wrap this body. A body around a stack. And we'll actually wrap it with a children widget like column so that we have access to the children's property and not just a child. And then we'll change this to a stack. And we're making this a stack because we want the panorama to be at the bottom and then our GUI and buttons and stuff at the top. That's why we're doing it as a stack. Let's not make changes to the button widget actually. We'll simply add the panorama as the first widget inside of the stack so that it would appear behind it. Cool. So let's go here and go inside the example. So let's search up for, oops, not print, panorama. And as you see, we have a panorama widget. So you just have to type in panorama. And then we would need a value called anim speed. This is the speed by which the panorama moves. We're going to change that to 1. Okay, that is fine. We don't really care about any of this. But for the child, we'll give an actual panorama. So let's do panorama child, and let's go all the way up to our images and then into launcher. And then as you see here, we have an image called panorama.png and it's a long image. So we can copy its relative path and then go here and then create an image widget. So image.assets and then paste this in here. Let's fix up the slashes. And that's it. It's that easy. Let's hot restart our game. Now we should see the panorama at the bottom. And we do. But it's not exactly moving. So, we want it to move slowly like this. But you can drag it out here. So you guys can just experiment this with if you'd like to. And this is like super cool in 3D. So, okay, first things first, we don't want this interactivity. We don't want the user or the player to interact with the screen like this. We only want it to automatically move like this. Okay, so this is actually really cool. Okay, anyway, let's go here and then make the bool called interactivity, which is a property, to false. So since I set the interactive property to false, I no longer will be able to drag this stuff and then create that 3D stuff. Okay, but we want it to move to the left or right in a systematic programmatic way. So what we're going to do is we're going to add the anim speed and then we're going to set it to 1. So it'll be like, it'll move very slowly. Let's see. Okay, so as you see, the panorama is moving to the left very slowly. Cool. Now let's add our other widgets like our actual, Minecraft logo up here. Then a create world or play or single player world option here. That will be our load world. But for now, we're just starting up a straight up world, right? If we click on it, we're starting up a world, but we don't want to be it like that. When we click on a button, which will be like, let's say, just imagine this text as play single player or single player. So if you click on that, it's going to take you to a world selection screen where you can access all of the worlds that you created and then click on them or, for whichever one you actually want to play. So let's do that. So first we want a logo here, then one button for actually, let's say, play single player, and then maybe one for multiplayer. We won't have multiplayer implemented yet, but just in case. And another button for maybe quit. Right, so let's just have one for single player and multiplayer. And a logo. And this will be one on top of each other, so it's a column. So let's remove this Minecraft button widget and then add a column. And as the children of the column, we'll add this one. Cool. And now we'll change this to single player. And let's add a similar button, Minecraft button widget. This won't do anything for now. multiplayer, and inside the on pressed, you won't have anything because it's just for show. Okay. Now we need the actual logo to be on top. And you can get the logo again inside of our images, inside of launcher. And then here we have an image called logo.png, and we have the Minecraft logo. So let's copy its relative path all the way down here. Oops, not all the way down, into our menu screen. And then make an image widget. So image.asset, and then let's paste in the actual path. Oops, multiple things went wrong here. And let's fix up the slashes. Okay. Right, now let's restart our game and then see how it looks. Very horrible. So we want the column to extend till all the space it has, and then make everything kind of like space evenly or something. Or let's do something. Let's set the main axis size to main axis size dot maximum. But this shouldn't exactly change anything, but yeah, it did it because this is inside of a stack, and then inside of a stack we need to tell Flutter how much space it can have. So we're simply going to wrap this entire column around a positioned.fill widget. So positioned.fill, and then here we can do a little bit of something like we'll wrap the column around an align and then give the alignment as alignment dot center. So now this will align everything to the center. Okay, and so we want equal space between the Minecraft and our two buttons, and equal space under it. So let's say X amount of space here and then X amount of space here, and then we'll have some padding underneath. So how do we have equal space between something and something in a responsive way? With the expanded widget. So what we're gonna do is under here we're gonna add an expanded widget. The child, as it doesn't matter, something just for the sake of it, we're putting a container. And let's do that again under our two buttons. So here, so what this is going to do is, if we have two expanders inside of a column, it always has to be the same size. And there's another rule that is going to occupy all the space that it has. So it's going to try to occupy all the space while making these two have the same size. So now we have got this here. Cool. Now let's add some kind of sized box between single player and multiplayer, so that we get some kind of padding. So here we'll just add a sized box with some height. Size box, let's say height equals 40 pixels. Let's make this a constant. Let's hot restart our game. Okay, and maybe that's a bit too much. I'll stick with 30. Let's hot restart our game again. Right, that's good. Now let's have a disclaimer under our actual column, just saying, hey, this is a game I've made for fun, and then I'm not intending to copy the actual Minecraft made from Mojang or whatever, just in case, you know what I mean? So let's go all the way down here. Let's add text, and for the text we'll say this is an experimental game made for education. Check out the actual game in okay, check out the actual game Minecraft. Just in case. Okay, and here we'll style this a little bit. So inside of style, we'll do text style, and then we'll give this a yellow color so that this can actually be seen. Colors dot yellow. Let's make the font size fairly small, like 10, and the actual font be the Minecraft font. So font family Minecraft font. Right, let's make this a constant, and let's restart our game. Okay, so we've got it here. This is an experimental game made for education. Check out the actual game, Minecraft. Cool. And let's actually give a little bit of padding to the bottom because it kind of looks super weird. So edge insets dot only, and we only want bottom, so we'll add the bottom parameter. Oops, not bottom, bottom, and then maybe like 10 or okay, 10 pixels. Oh, that's exactly the size of our entire text. So I don't think putting a 5 would be 10 would be like really nice. So let's remove the constants from here and then add it to our parent, right? And then let's actually do one thing. This is kind of sticking out at the moment. Let's oops, what did I just do? Okay, this is kind of sticking out at the moment, so let's actually give it some opacity so that it'll be a translucent yellow rather than a full-on in the eyes yellow. So yellow dot with opacity 0.5, and of course we get this after we made this a constant, because when we do with opacity we cannot have our widget a constant anymore. So let's hot restart our game. Okay, so that's a bit too dark, so let's change this to like 7.5. Okay, and yeah, that's good. Now if we click on single player, we're gonna go here, right, and back into the screen, right? So that's working. Now let's make it so that when we click on single player, it takes us to the world select screen, where we have first of all a dirt background, and then a column of first a text saying select world, then another container like thing which occupies 70% of the screen's height and then is slightly darker compared to the background, and then finally a row of two buttons, back and create world. Back takes us back to the menu screen. So here this programmatically looks for every world data that we have inside of our box and then creates this preview widget for it. So this is just a row of, again, an image, then a column of the world name and then seed. So the world name will also be a new Hive property that will add to our world data. So if you join this, what's going to happen is it's going to join that world, right? So let's actually create the file for our world select screen inside of screens. World underscore select underscore screen dot dot. And this will be a stateless widget. Let's call it world select screen. And then we need to be returning a container. So return container that is with an image of, I'll show you the image. Let's go inside of images, then into launcher, and then into dirt background. So inside of a world select screen, we want this image to be the background. So let's actually copy its relative path. So what we're going to do is we're going to be setting a container to be the screen height and screen width amount of size. And then we're going to be adding a decoration for that container. And inside of the decoration, we can add an image. Right, so let's go down to our world select screen. And then we first need to have the width and height of the screen size. So let's actually get the screen size first. So size screen size equals game methods dot instance dot screen size. Cool. And let's make the width screen size dot width and the height screen size dot height. Now we can expect this container to be the full height and width of the screen. Now let's give it an actual decoration, and inside the decoration we'll be able to fit an image in here. So we're going to give it a decoration and we'll do box decoration. And we have, tons of stuff inside of box decoration. Why we can put the color, we can put the image, border radius, but all we need right now is the image. So now whatever image you will put in here will cover the entire container. So this takes in a decoration image. So let's pass in a decoration image. And this is image provider. So let's give asset image. And inside of asset image, we'll paste in that path that we just copied earlier. Let's fix up the slashes. Cool, let's format everything up. Let's just spam commas everywhere. Just kidding. Okay. Now we need another property. So maybe the player is in some kind of screen that so that this image does not exactly fit fully inside it. So to make sure that this image is like flexed into fitting into the screen, we're going to set a value called fit inside of decoration image to box fit dot fill. Okay, now we can make everything constants. And right now, let's go inside of our menu screen. And then inside of the single player button, what we're going to do is we're not going to be returning the game layout, but we'll return our screen. So, world select screen. Right, let's all restart our game and then go inside here. Okay, and if we click on single player, we should be taken to this screen. And as you see here, we have the dirt background fully implemented. Right, so let's go inside the world select screen again. And let's actually wrap this around a scaffold so that we don't run into any issues later on. Scaffold, child, body, and okay, right, that's it. Now we need a column. So this column will first have text at the top called select world. Then we will have a huge container like thing where we can, scroll through all of our worlds. And then at the bottom, we'll have a row of one Minecraft button saying back. So if we click on this, we'll go back to the menu screen. And then another one called create world. So, currently we can programmatically create a new world by doing hive.put a key dot then generate world or whatever. But we're going to be, making that happen with a GUI. So that'll what we're going to be doing after the create new world button, but we don't really care about that right now. So let's give this container a column because everything's going to be inside of a column. Okay, and for the child, okay, for the first child, let's pass in the heading. So we want like a text at the top saying select world. Okay, so text, and here we'll have select world. Let's give the text style, so text style, style, text style. We're going to give the color as colors.white, so it'll be super bright. Then we want the font to be our Minecraft font, so Minecraft font. Maybe let's set the font size to like 20 pixels. And we also want the shadow. And let's actually, to get the shadow, let's go inside of our actual button that we created all the way down in widgets. We should have a button here somewhere. Right, inside a launcher, we have the Minecraft button. And then here we have the code for the shadow. So let's just copy this and paste this inside of our world select screen. So shadow and paste. Okay. Yeah, so that's it. Let's add all the commas, and we have an issue. Okay, so we don't really need shadows here then. And then let's go up here and save everything. Okay, now if we see here, okay, we have the select world text appearing. Right, that's good. And let's give it some sort of padding. Let's remove the constant from here and then add the constant here. Don't worry about this whole constant issue because eventually we'll have stuff that would not fit to being a constant, so this error will go. Not an error exactly, it's a warning. And let's actually wrap this text around some padding with some top padding. So top padding, or let's just give symmetric padding so that it'll apply both to the top and bottom. So vertical, let's give 10 pixels. Cool, let's hot restart this game. And now we can remove the constants from here because our padding will also be a constant. Right. And let's go inside single player. And yeah, okay, we have that. Now we want a huge darkness of a box, like that will occupy 70% of the screen side. So it'll be like a little bit of darkness here, and here it'll be the background for all of our worlds that we can scroll through. So let's, okay, you probably will only understand it if I actually create it first. So let's create this container. So this will be a container. We want the width to be the screen width, so screen size dot width, and height to be the screen height multiplied by 0.7, so 70% of the screen size. So screen size dot height multiplied by 0.7. And for the color, what we're going to do is, okay, so we want a fairly darker, opaque or translucent thing to be happening here. So we're going to give colors dot black, but we don't want it to be exactly fully black, right? We're going to make it see-through. So with opacity 0.4. Okay, let's hot restart our game. And now we should see a, oops, single player. And yeah, so we get this container which is a little bit darker than everything around, and here it'll be the background for our actual scroll view. Okay, cool. Now let's add our two rows. Actually, not our two rows. We'll have the row of two buttons, so one for back and one for create new world. So all the way down here, row children Minecraft Minecraft button widget. Text will be back for this one, and in the on press, let's not have anything for now. And then let's duplicate this down. Actually, let's put the cursor here, shift alt down arrow key, and then for this we'll have create world. Okay, let's hot restart our game. Now we should also get our row, and we do. So we don't want this to be happening exactly. So what we're gonna do is let's go inside of our Minecraft button widget first, and then do something about the width. We're gonna set the width to 0.4, okay, because we don't want it to be that big actually. So now let's see if that's fixed. Okay, so we have both our buttons here. Now we have some alignment issues to fix. So we want everything, so the text here, this container, and this row to be spaced evenly apart each other. So let's go inside of the world select screen into the column here, and then we'll set the main axis alignment to main axis alignment dot space evenly. So now everything should be spaced evenly. Let's see. And it is. So we have equal padding, so we get this kind of new padding effect between all of this, right? And then we also want that same thing to apply for the row. So this button and this button will be equally distant from each other and not like together. So let's go inside here. We'll also set the main axis alignments to main axis alignment dot center, actually not center, space evenly. Cool, let's hot restart this game. And yeah, so we have this. So right now let's actually add the functionality for the back button, because that wouldn't be too complicated. We simply want to go back to the menu screen. So here we're just gonna navigate to the menu screen. So navigator dot push replacement material page route, and for the builder we'll have the context as parameter first, and then we'll be returning our menu screen. We can make this a constant because why not? And then a semicolon here. The navigator dot push replacement context material page route builder context constant menu screen, and that will happen when we click on the back button. So let's see, single player, and then if we click on back, we go back here. Cool. Now we won't have any functionality for the create world button just yet. So now let's work on the actual widgets that will be inside of here that will represent each world. So let's create the widget for this inside of widgets. Actually, yeah, we'll create it inside of launcher. Let's call it world preview widget, because it will kind of be like a preview to what world it will be when clicked on it. Okay, so this will be a row. Okay, so first we'll have two expandeds at the left and right. So whatever will be the middle widget inside of the row will be spaced at the center, right? And then let's say we want the main part of our actual world preview to be 60% of the screen's width. And inside of here, we'll have an image and then let's say the world name and the seed. So you know what world you created. Okay. So let's make this a stateless widget. World preview widget. And let's return a row actually. So our main part of this will just be a row. And for the children, let's first have a container. We're just putting this to actually see how much space we want our actual widget inside of this to occupy. Let's give the colors to something distinct like amber. That's fine. And let's give the width. But before that, we need the screen width and size. So let's get that. Size screen size equals game methods dot instance dot screen size. And here we're going to give the width to screen size dot width, and it's actually define a height variable. So integer, not an integer, double height. So this height will be the height of this world preview widget, and let's say that will be a responsive size of the height divided by 7. Okay, and let's give the height as that too. And let's add this inside of our world select screen. So inside of this container, I'm just going to do child and then paste in our world preview widget. Cool, let's restart our game. And we have this here, right? And right now this occupies the full width of our app. So let's make it so that it only occupies like a good portion of it, like 60%. So let's go inside of the widget again. Minecraft or world preview widget, and then we're going to multiply the width by 0.6. So 60%. Now it should be a little bit better. And actually, you don't have to hot restart the game every time you want to see the changes, but okay. Now we want to make it have equal space at the right and the left. So you guys know how to do this. For the first item in the row, we're going to give an expanded and a child as a container or something. It doesn't really matter. And for the last item in the row, we're going to give another expanded. Right, let's hot restart our game. So now we should see, actually, why did I hot restart our game? We could have just saved it. Okay, so we have equal space at the left and right. So here will be, okay, we have a container here. So here will be a image and a text saying whatever the name of the world is, and then the seed of the world. So let's take that both things from the constructor. So let's define final string and world name. Let's require this from the constructor. Require this dot world name, and then we also need the seed, and the seed is an integer. So final integer seed. Oops, not seed. Why did I do seed? Okay, anyway, let's require this. This dot seed. Cool. And inside of here, let's remove the color. And okay, now we'll work inside of here. So let's just ignore the part, everything inside it. Let's just ignore everything that we just did and then just work on here. So we want a row because we'll have an image widget, and to the right of that, some text saying some details of the world, right? So let's make this a sized box because we don't need the color property anymore. And then since we're just defining the width and height, we can make it a sized box because why not? And for the child, we're going to give a row. Okay. Now for the first child in the row, we'll have an image that will correspond to what a world looks like. And you can get that image inside of all the way up at launcher inside of images. And here we have an image called new world icon.jpg. So this will be the actual image that will display there. So let's copy that, go all the way down here, the world select screen. And okay, before that, let's actually give the parameters for world preview widget. So world name, let's say world name, haha. Okay, not the haha. And the seed as seed. or one. Okay, it's a string. What do I mean? Okay, now let's go inside of our world preview. Okay, now we'll add our image. So image dot asset, and then let's add in the path quotation marks first and fix up the slashes. Cool. Now if we hot restart our game, we have to hot restart this time, and let's go into single player, and then okay, we have that image appearing. Now to the right of this, we want a column, and the first item in the column will be the name of the world, and under that we'll have the seed. Cool. So to the right of this, okay, so after this image we'll have a column and children. So we'll have a text saying the name of the world, so world name, and under that we'll have the seed of the world, so text seed. And seed is a string, so we want to change it to no, seed is an integer, we want to change it to a string. So let's put quotation marks, and then we want to format this up a little bit, like let's say seed equals, then we want to put our seed, so we'll put a dollar sign and then seed. Cool. Let's save and not hot restart, so it should appear here. And then it's just that we cannot see it because it's like black here, and then it doesn't really match up with the background. So let's give it the same style that we did for our world select. So let's go inside the world select screen, copy all of this, and actually since we're using this style multiple times in our game, let's actually save this style somewhere. Let's copy this and then go inside game methods, and then let's create a getter function that'll return a text style. So get okay, Minecraft text style, and then we'll simply return this text style. Cool. Colors, okay, maybe not that. Okay, colors, and then this can be a constant. Now every time we want to get the text style, we can simply do game methods.instance.minecraft text style. So that's exactly what we're going to be doing inside of a world preview widget. So here we'll give the style as game methods.instance.minecraft text style. Cool. And then same for the seed text. So style game methods dot instance dot minecraft text style. Right, now let's hot restart our game, or let's just save it. So hot reload, and we should see those appearing, but we do not, so I guess we have to hot restart it. Yeah, because we made changes inside of our game methods. Okay, now let's go inside single player, and yeah, we have the world name and seed. So we want the world name to be, slightly grayer, and the seed to be, grayer than that, so a little bit more dark. And this, we want a different font size for seed too. So how do we actually do this? We cannot exactly edit this Minecraft text style directly, right? Actually we can. So we can use a method that is that is inside every text style dot, it's called dot copy with. So every new property that you put in here will be copied to the actual text style. So if we put the font size as, actually let's give the color. If we give the color as colors.gray 300, it's going to copy or replace the actual color inside of our Minecraft text style with whatever we have as the property inside of our copy with. So now if we go in here, yeah, as you see, it's a little bit darker. Let's make it 400 gray, so it's a little bit more visible. And let's also add the copy width for this one. Color, we want this to be a darker gray, so we're just going to do gray. And we're going to give the font size as 10, so it'll be super small. Now let's see. And yeah, so we have it, but that's actually a little too small, so let's make that 15, I guess. So let's just hot reload it this time by saving, and yeah, I guess that's good enough. Now we have a problem that we want all of our widgets inside of the column to be aligned to the left. So we can do this with a cross axis alignment property. Cross axis, because the main axis of the column is vertical, so the cross axis will be horizontal. So to do cross axis alignment, we're just going to set it to cross axis alignment dot start. So it'll start from the left. So let's see, it should be aligned to the left right now. And why did I restart it? Okay, we have it. Yeah, that's good enough. And let's give some padding between the actual image and our column so that, it doesn't look super weird. I'm gonna wrap this image asset around a padding widget, and we're just going to give a padding to the right, so only right. Hot restart our game. Didn't have to hot restart again, but whatever. So yeah, we have the widget here. Cool. Now if we click on it, we want something to happen. So we have the access to the seed, and the seed is actually the only thing that we need to load up a world. What does that mean? So let's go inside the game layout. So inside of the game layout, we're just doing game methods and then passing in the actual seed of something that we stored inside of our world data box, right? So the seed is the only thing that we need to actually run our game. So rather than typing in a seed here, let's require it from the constructor of a game layout. So integer seed. Let's require this dot seed, and then let's remove this from here and then do seed. Cool. So where are we getting the errors? Okay, nowhere. So let's go inside world preview, and so whenever this is clicked, we want the world corresponding this to load. And let's assume that this will only get created once an actual world data of it lives inside of the world data box. So anyway, so if we click on this, we want the world with this to load. So we're just going to be navigating to our game layout and then passing the seed as this current seed. That easy. And okay, let's go inside of a world preview widget, and then since we want to detect clicks, we're going to wrap the entire row around an inkwell or a gesture detector. I'll do inkwell, and we'll give an on tap, and if it is tapped, we want to load up our game. And loading up our game is super easy. We just need to navigate to the game layout. Navigator dot push replacement and context material page route. Builder will have a context parameter, and we'll simply return the game layout. But this time the game layout requires a seed, and then we're passing the seed as a seed of this current world preview save. So before that, let's actually hot restart our game and go inside main, and then we have a sprint statement here. That seed will break our game because we don't really wait, actually Hive dot, okay, we have the sprint statement here. Why did that not print? Let's try it again. Okay, that is weird. So we have a .html import somewhere. So let's find that. Import .html. Right, okay, it's inside world preview. Let's remove that. Okay, so anyway, so right now the seed of this is 1 2 3 4 5, and when it tries, when we actually click on it, it's going to create the world with that seed, but that will not work because we don't have an actual world data under that key inside of a world data box. So what we're going to do is we're going to go inside of the actual world select screen and then pass in the seed up here, actually down here, as the seed that we got from our printing. So let's put that. So now even if we click on it, it should work. Let's single player, and then let's click on it, and then it loads up that world. So let's save this and then quit it. Now, yeah, so now we can go in here anytime we want. So when we make a new world with create world, it's going to add the world preview for that here, and then if we click on it, it's going to load that up. Right. Now let's actually work on making this a list instead of just a static thing inside of this container. So we'll be doing that inside of a world select screen, right? And then for the child, I'm gonna remove this and then make it a list view, right? And then inside of the list view, we have a children property. And inside of the children, we can just paste in how many ever widgets we want. So I just pasted in like, 500 different instances of world preview widget just to test it out. So let's see. Go inside single player. And yeah, that is working. But okay, we notice some issues here. We want some padding between our world preview saves so that it doesn't look super congested as it does here. So we're gonna go inside world preview stuff. So world preview widget, and then wrap the row around padding. And we only want vertical padding. So vertical padding, oops, not vertical, edge instance dot only. Then oops, not only symmetric actually. So symmetric, vertical, and then let's say 5. So 5 pixels at the bottom, and then 5 pixels at the top. And let's see how this looks. Yep, that's really well. Oh, it's looking good. Now let's actually make it so that it loads up based on all of the worlds that we have inside of our world data box. Okay, so this might be a little bit confusing. So let's go inside of our world select screen. And so what we're going to do is at the beginning of the creation of the widget. So let's go inside the beginning of the creation of the widget. But for that, we have to make the stateless widget into a stateful widget. So let's do convert to stateful. Okay, just we did that for the access to the init state. So the init state is a function inside of this one called init state. This will get called at the beginning of the creation of this widget. Okay, so here what we're going to do is we're going to like iterate through each instance of world data or everything that we have saved inside of world data box. And then for each one of those, what we're going to do is we're going to get the seed, and then we're basically going to create a world preview save widget for it. And then we're going to create a list and then pass in that list here. I know that is a bit confusing, but I swear it's not. So first, children actually accepts a list of widgets. So we won't exactly define it there, but we'll do it here. We'll have a list of widgets. Let's call it, what do we want to call it? Let's just call it children actually. Children. Right. And then this will be an empty list. And then inside of here, we're just going to pass in children. So we're going to iterate through everything inside of our box first. Look for all of the worlds. And if it is an actual world, what we're going to do is we're going to get the seed and then add an instance of world preview save, or what's it called again? World preview widget inside of children. Okay. So let's iterate through every one of our actual world data. So dot box. The name of the box is world data box. Dot asmap. So wait, not that. So let's, okay, we have tons of different methods inside of this. And one of this is toMap. So toMap just converts everything inside of our actual, box into a map. So it'll be like a map with the key as, we'll get a map with the key and the value. So if we do dot asmap dot for each, so we get the integer key, which is the seed, and then the value, which will be world data. And it doesn't really know it's a seed, so we're gonna have to do seed and then value, or let's call this world data. But we know it'll definitely be an integer, and yeah. So we're iterating through everything inside of our world data box. For now, we only have one world data instance. So for each instance, what we want to do is we're going to add a widget of world select or world preview widget with the world name as, let's just say, default name or whatever. And for the seed, we'll pass in seed. And that's it. So now if we hot restart our game, we should see this programmatically implemented. So if we go inside single player, yep, we get default name or whatever, and then seed 118928. And we didn't like type this in, we programmatically generated this. So at the beginning of the creation of the widget, we first had a list of children, which was empty. And then inside the init state, which gets called at the beginning of the creation, we iterated through each value inside of our world data box. And then for each one, we created a preview widget instance with the seed as its seed, and then we added it to the children, and then we simply added that children to the child of our actual list view. Cool. Now we need the world name property. So one last time, let's go inside of, okay, so this is also a value that needs to be saved. So for the last time ever, let's go inside of our world data and then create a new field. Let's call it final string. What do we call it? Let's say final string world name. Okay, so this will also be required at the creation. So required this dot world name. So now we have to remake the adapters because we made a change to here, and then this also has to be a field. So how many fields have we created? 5. So this will be the 6th field. So Hive field and 6. So now what we're going to do is, after we have implemented this correctly, we're going to go inside of a, actually let's do that first. We're going to go inside of a actual preview, world preview widget, and then for the okay, not a world preview widget, select screen, so world select screen, and for the default name or whatever, we're going to do world data dot, and we actually need to make sure that it's a instance of world data. So we'll just check if world data is of type world data. I mean, this will be fine as long as we only put things of type world data inside of a world data box, but we just did this so that it would know the actual type of this. So now if we do dot, since we have put an if statement here to check if it's a world data, now it knows it's a world data. So now we can access the world name, and then we'll simply pass in the world name as world name. Cool. So now what we're going to do is we're going to have to remake the adapter for our world data. So let's save everything, pause this actually, and let's go inside here, terminal, and then run the last command that we just did. So up arrow key and enter. Okay, that's done. So now let's actually go inside of our constants, control P, constants, and then change the world data box to 4 so that we're looking inside an entirely new box, and this box is completely empty because the stuff inside of our old boxes had like instances of world data with no field such as the world name, so it's going to break our game. That's why we're creating a fresh new box, and then let's go inside of our main temporarily. Let's comment off run app, and let's uncomment these so that an actual instance of this gets created, the world data seed, and then here we can add the world name. So let's just call it new world test. Let's hot restart our game, test, and this should run successfully, and it did because we didn't get any errors. So now let's comment this out, actually both of this, and then uncomment run app. So now we don't have to do anything finicky like going inside the game layout and then passing in a seed where it has the stack as the main game, but it automatically does that now. So that's what we have done inside of our world select screen, right? So now if we go inside single player, we see the new world. So new world test, right? That's working. And the seed has 185480. So let's try joining this. So this is an entirely new world. Let's try making some changes to it, like this or something. And let's leave the game and join back. And there seems to be an issue. Let's actually hot restart our game. That issue just happens like, there's a 40 or 30% chance of that issue happening. And since it's not consistent, we can't exactly fix it. And yeah, we have the changes that we've made here. Cool. So now let's create our create world screen, which we'll get navigated to when we click on create world. And this also has a dirt, background. Then it's a column with a create new world text, a text field where you can type in things. And inside this text field, we have an autofill feature so that you don't have to type in the seed or the world name, but you have an option to edit it, right? And so we have a description for that too. And then if we click on create world, we get navigated to the actual player screen, and then our world will be created here. Okay, so let's now create our create world screen, and we'll have a file inside of screens for this, and it'll be super similar to our world select screen. So that'll be a scaffold, And inside the scaffold, there will be a container with the screen size as the width and the height. And then we'll have a decoration to actually set the background for it. So let's make it create world screen dot dot. This will be a stateless widget. So create world screen. Right. And we're gonna try to replicate everything that we did there. So we have a scaffold. Then inside the scaffold as a body, we have a container. And I think we can copy paste that container without having to do any major refactoring. So let's copy this and paste inside here. Cool. And now we also need the screen size. For that, let's put some brackets here so that things don't break. Okay. And let's get the screen size. Screen size equals game methods dot instance dot get screen size. Cool. Now let's just see if this works by going inside of a world select screen and then adding the on pressed for a create world button. So we'll have something super similar to the on pressed of the back. So let's copy this and paste it in here. And the only thing that'll be different is the actual widget that we'll be transporting to. So oops, accidentally did some brackets there. Okay, so constant create world screen. Right, let's hot restart our game. Okay, let's click on single player. Then let's click on create world, and then we should be teleported to a screen with just dot background. Cool, that's working. And again, let's go inside of our world select screen. We're actually already there. And we'll have a column as the child. And inside of the column, we'll have things like the text saying create new world. Then we'll have a text field so that we can actually, take in the player's input for whether, what name we want to create a world for or world in, then the seed and stuff. So let's all start, begin to create that. So let's put some brackets here again and just to format everything up. And here in the end, we'll have the child. So this will be a column. And for now, as a column, let's just have a text. And as a text, we'll say create new world. And for the style, we'll pass in our default style. So game methods or instance dot Minecraft text style. Right? Now, how does it look? Okay, right. That's cool. Now let's actually add the text field. So we'll make a new widget for this inside of widgets. And we'll load this inside launcher. Let's call it Minecraft text field dot. And as you know, this will just be the decoration for this will just be like a black rectangle with a gray outline. So let's make this a stateless widget. Minecraft text field. Okay. And we're going to be returning. For now, let's just return a container. And inside this container, we'll have a text field. But for now, we're just designing the text field. Okay. So a container. Then, okay, we want to give the height and width. But let's not exactly decide what the height and width will be for every Minecraft text field. But what we're going to do is we're going to be taking in the parameters, final size. And so now we can decide in the parent how long or small we want our actual text field to be. So let's require this size, and then we'll give the width as size.width and height as size.height. Cool. Now let's have a decoration for it. Let's make this box decoration. And we're first gonna add a color to it. So we want this to be black colored. So colors.black. Then another thing that we want is the border. So the border, we'll put it as border, or actually let's do border.all. So, at all sides of this actual container. And we'll give the color as we want a gray border. So we'll give the color as gray. and we actually define the width of it too. So let's give the width as 3, so 3 pixels. So it'll be a little thick. And let's just add this inside of our create world screen, right? And just as another child inside of a column, we'll add the Minecraft text field. And now we can define the size. So let's give the size as, first we need to, okay. So let's give the width as, let's say 70% or 60% of the screen's width. So screen size dot width multiplied by 0.6, and height as, let's just have a constant value for this because it doesn't really matter because the width is what we really want to be responsive. Okay, now let's go inside of the create world, and yeah, okay, that's good. But let's actually change the height to maybe 70. That should look good. And I didn't have to hot restart that. Hot reloading it would have worked fine. And that is too big. Okay, let's try 55. Hot reload this time. And okay, that's looking good. So let's assume this text field will be for the world name. Okay, but the player does not know that. So we want to make sure that we have some kind of texts here and there that will tell the player what each one of these is for. So let's wrap this entire Minecraft text field around a column. Okay, let's give a column here. And then in this column, notice how this is separate from our main column. So here we'll have a text field or just a text saying the world name. Okay, and then we'll give the style as the default text style that we have created. So game methods.instance.text style, right, comma. Now let's hot restart our game or just hot reload it. Okay, we have it here. So the reason why we have done this is because now we're going to change the main axis alignment of our main column with all of the create new world and this column here. We're going to set that to main axis alignment dot space evenly. So now if we hot reload this appears here. So if we had this text field inside of our main column, what would happen is that we'd have create new world here, world name here, and then our text field underneath here. But we want this text to be paired near this. That's why we have done it like this. Cool. And let's actually give this cross-axis alignment because we want this to be aligned to the left. So we'll give the cross-axis alignment as start. So cross-axis alignment dot start or reload. And yeah, that's good. And let's actually just give a sized box, but actually let's define the sized box as a variable here. So sized box, or let's just call it space equals sized box, and we're just going to have a height of like 20, so 20 pixels, and we'll just add this wherever we want a little bit of padding to, because making a padding widget or wrapping all of the widgets that need some padding inside of a padding widget would take a long time. So we can just do inside of after the text world name and then before the Minecraft text field we can add our space. So now what will happen is that if we hot reload our game, we'll get some space between them, right? And now let's also tell the player what a little bit more detail into what this means. So we're gonna have another text under here, and we're gonna make this world, or okay, so here we'll type in what our description for this is gonna be. So your world will be saved to this name. Okay, right, so that's it. And let's give the style as our default style again. So game methods dot instance dot Minecraft text style. Cool. Let's hot reload the game, and we have this here, right? But we don't want this to be this big. Okay, we want this to be like slightly smaller so that it doesn't overpower this exactly. And let's also add our space under our Minecraft text field so that we get some padding between these. Let's first do that. So here space, and here we're going to do dot copy width And let's try a few things and then let's see what works. We're going to change the color to colors dot white dot width opacity 0.7. So this should make it okay. Yeah, that's fine. And let's also change the font size to like, let's say 14 or 13, and that is too small, so let's try 17. And yeah, okay, that's cool. So now this will be the text field for our world name. Now we need something similar to this. That will be for the seed, because it's, let's say the player's friend found a seed which had really good generation, and then he wanted to, or he or she wanted to share that seed to this player. So we would just type in the seed here. So we want to give the player an option of typing out of seed. So let's also, for this, we'll just duplicate everything that we have inside this column down there. So let's select all of this and shift or down arrow key, and then let's put a comma here. This will be seed. And okay, size is fine. And okay, we'll change the description to the terrain. This value will define the terrain generation. Cool. Now let's hot reload our game. And then, yeah, okay, we have the other thing appearing, and seed, this value defines, or let's make it defines, oops, the terrain generation. Cool. And now just as we have inside of our world select screen, let's have a row that will have two Minecraft button widgets, one for the back. So if the back is clicked inside of the create world screen, we want to go back to the world select screen. So the only difference is we'll have the menu screen swapped here with the world select screen, and then another one create world. This one will be just the same. So rather than pushing this create world screen into here, what we're going to do is we're going to be saving this world instance, or a world instance with the seed as what the player has typed and the world name as what the player has typed into our box. So let's actually copy this row and paste it inside of our create world screen. Cool. And we need to import Minecraft button widget, and let's replace menu screen with world select screen, so that when the player actually clicks on back, it will go back to the world select screen and not the menu screen, because that's not what we want. And let's remove the on press here entirely, and let's save. So hot reload, and yeah, okay, that's working. Let's try clicking on back, and then we get sent to our world select screen. Now let's click on create world, and then we get sent to our create new world. All right, now let's actually make this text field functional. So let's go all the way down to our widgets, and then into launcher, then Minecraft text field. And then all we're going to do is, okay, we've already defined the actual style that our text field should be in. So now we'll just define, the actual functionality of a text field. So we're just going to add a text field with no particular decoration, right? Just a simple text field that you can barely see except for the blinking cursor, right? So let's do text field. And let's see what happens if we just do this. So, okay, we can type in here, but we have some, major issues. So let's fix all of that. So I typed in there, but you weren't able to see it because the text color is in black and not white. So we want to make it have the white color so that we can actually see it. And then let's also make it have the Minecraft font. Okay, so let's do all of that. So inside of text field, let's first have a style. This will define, the style of the text that the player types inside of the text field. So text and okay, actually text style, or let's just do game methods dot instance dot Minecraft text style. So this is a text style that we have defined. And then, okay, now as you see here, we are typing in the Minecraft font. Cool. And this actually gives some padding between the actual container and the child, because as you see here, it's kind of like, really congested up to the left, and that doesn't look too good. So we can do this by going inside container and then adding a padding. Let's do constant edge insets dot all, or maybe not a constant. We'll do 5, or maybe 5 is too much, 3 pixels. Okay, constant again. I don't know why I changed that. Okay, now as you see here, there's a little bit of space. That's a little bit too less, so I guess 5 should do. And yeah, now we have more space. But as you see now, it's been aligned to the bottom. That is because we added the padding to everywhere. So let's actually make this symmetric and then only apply to the horizontal. So horizontal. Oops, let's first remove this. Horizontal, as now we can put anything we want, let's say 8 pixels. So now it won't really affect the alignment, and yeah, right, that's looking good. Now the cursor is actually blue in color. We don't want it to be blue. Let's also make that white, but that would create, we want some kind of contrast between the actual cursor and the text. Like if this were white and then you put it somewhere here near D or I, you probably wouldn't be able to see, or differentiate between the cursor and the actual text. So let's make it so that the style, we're going to replace the color of the style. Okay, we're going to do dot copy width, and we're going to replace the color to colors dot gray, and let's say not too dark shade of gray, so 300. And yeah, as you see here, now this you can actually differentiate between white and gray, right? Now let's change the cursor color to white, and we can do that with the cursor color property inside of text field. So cursor color, colors dot white, and now as you see here, it is the white color. And one last thing, we do not want this blue underline here. So what we're going to do is we're going to go here and then set the border, or okay, to actually access the border, we're going to have to go inside the decoration. So this is of type input decoration, and here we'll just set the border to everything null. So let's do input border. So the border accepts a type of input border. So right now it has some kind of default value that we don't really want. So what we're going to do is we're going to do input border dot none, and let's see if that fixed it, and it did. So now we no longer have the blue line under here. So now we want some kind of way, like inside of a create world screen. So let's go inside there, create world screen, Control P if you forgot. So instead of a create screen, when we click on create world, we want to get the text inside of this text field for the world name, and then the text inside of the seed to actually get what's inside here. Like let's say we add some seed here, so, or the player typed in some seed, and we also want to get the seed inside of, or the value inside of this text field to actually create the world. So how do we actually get the value from here? Easy. We can do that by assigning a controller to a text field, and with a controller you can control anything that any functionality of the text field. And before that, let's make this a constant. Okay, this too. Now the text field has this property, controller, and this accepts a text editing controller. So with the text editing controller, you can change what's inside of the text field and everything. So let's do final text editing controller, editing controller, and then text editing controller, and let's require this, and then we'll add the controller as a text editing controller that we take in from a constructor. Now we have 2 exact errors inside of here. That is because we have to provide in the text editing controller property. So let's first create that, and we're going to be changing our stateless widget into a stateful widget, because we need access to some functions like void init state and void dispose. So so the init state gets called at the beginning of the creation of the widget, and disposed when the widget is destroyed, or just destroyed is a hard word. Okay, so let's make the text editing controllers. So text editing controller, we'll have one for the world name. So world name equals text editing controller. Right, now for our seed, so let's duplicate it down, Shift Alt down arrow key, then seed, and okay, let's make it seed controller so that we don't confuse it with any future values or future variables that we add in here. Cool. And one more thing, we want to delete our seed controller and our world name controller, or not delete exactly, dispose of our controllers when the widget is being removed. So we're gonna, okay, we can do that with the world name. Okay, let's do late. Okay, so let's first go inside of the void dispose. Because yes, so void dispose. This gets called at when the widget is being destroyed, right? So just as I told, so called when the object is removed from the tree permanently. It's called super.dispose2 because our actual stateful widget has some functions here for the dispose, because we don't entirely want to override that. And now inside here we can access the method of our world name controller called dispose. And let's do the same for our seed controller. Right, now we just assign the controllers here. Text editing controller, this one is a world name, so world name controller. And finally one for the seed, so text editing controller equals seed controller. So now what we can do is, let's go inside of the onPressed of our create world. Here we print two values. So one, world name controller dot text. So dot text gives the string that is inside of the actual text. For example, if we typed in hello here, if we did world name controller, which we have assigned to the actual text field, and then which we have access to inside world or create, this screen here. So if we did world name controller dot text, we'll get a string hello. Let's just make sure of that. So let's print this, and also for the seed. So seed controller dot text. Let's hot reload our game. Let's go inside the debug console, and then let's type in hello here. Okay, 8764. Now if we click on create world, we should get some print statements, but we didn't. So let's, okay, that's because we haven't saved some things. Let's hot restart our game actually. And let's go inside single player, create world, and then let's type in hello here and see it as 1 2 3 4 5 whatever. And if we click on create world, we get hello and 1 2 3 4 5. So now we have a way of actually getting what the player has typed in inside of the text editing controllers or the text fields. But one more thing, so if we go into our create world, we don't have a world name or the seed set. So maybe the player does not want to add a custom name to the world or a custom seed. So we want to add the feature of making it autofill. So when the player actually goes inside the create new world, we want the world name to be set to new world and the seed to be something random, right? So that we, it's only an option for the player to actually, add a new world name or seed. So it's not mandatory, right? So we can do this by going inside of our init state. So we want to set the world controller or a world name controller dot text to something. So just as we did, printed these values, we can set them to something too. For example, let's do world name controller dot text equals haha, I can do this. And let's hot reload our game. Now if we click on create world, the text changed into haha, I can do this. So just like this, we have to set the world name as a default value. Let's say new world at the beginning of the creation of this widget. Same for the seed. For the seed, we'll have something random. So we know how to, get something or fire a function at the beginning of the creation of a component, and that is inside of our init state. So override void init state super.init state, and then here we'll just set the world name controller.text equals what we want to default it to, new world. And then finally for the seed controller.text equals we want to get a random seed, so we'll do game methods.instance.get seed or get random seed, and then this is of type integer, so let's turn it into a string. Right, now let's hot restart our game. And if we go into single player and then create world, as you see here, we have new world set as default, and then we have a random seed. So if we go back and join again, we get a random seed again and again and again and again. Cool. So now if we click on create world, we want to actually, create the world instance inside of a, Hive box. So let's go inside here and then let's do Hive dot box. You want to access the world data box, the world data box, and then we'll put something, and the seed is going to be, or the key is going to be the same as the seed. So let's do string, or it'll be an integer, seed equals. So to get the seed, all we have to do is get what is inside of the text editing field, right, or the text field. So we can simply do seed controller, dot text, but this is of type string and not integer. And there is no function to create or a method to create it into an integer. So what we're going to do is do int dot parse. So the integer has a function called int dot parse, where we can pass in, it's actually small I. So yeah, so int dot parse, and then we'll pass in the string. So seed controller dot text. So for example, let's see what the int dot parse does. So parse source as a possibly signed integral literal and returns its value. So if we did int dot parse 1 2 3 4 5, it'll return to us an integer 1 2 3 4. Okay, if we had 5, it would be 1 2 3 4 5. You get the point. So this is a way of converting strings to integers, right? And for the key, we'll pass in seed, because that's how we do things. And then for the value, an instance of world data, seed as seed, and world name as what the player has typed in inside of the text field. So world name controller dot text. Cool. Now let's see, we have some problems for some reason. Size import. Okay, something's wrong here. Okay, let's go up here and then remove this import from fi. Okay, now everything's working. Let's all restart our game. So now everything is done and should be working. Single player, create world. Let's set the world, name to this is my world, and let's click on create world. Now I clicked on create world. So now if I go back, it should appear here, and I do get it. So this is my world, and I can join this and play in here. So I'm gonna just make sure that everything's working by breaking this log, picking up it in my inventory, leaving, and then joining back. And I should have that exact same thing, and I do. So let's leave this game and then try to join our new world test. And we have a different terrain and different sand block for that. Cool. I mean, different inventory. All right, so let's leave this. So world saving is working perfectly fine, even with different worlds. And finally, one last thing. So if we create a world or click on create world, we want to actually get, navigated back to the world screen, so that after we click on create world, we wouldn't have to go back and then do the same thing again. So just after here, gonna do navigator dot push replacement context material page route builder will context, and then we're gonna do return. We're gonna be returning. We're gonna go back to our world select screen. So world select screen, and yeah, so we have some problem here. So let's go all the way down. Too many positional arguments. Okay, that is so weird. We probably did something wrong, so let's try doing that again. Maybe a bracket's missing or something. Right, okay. Navigator dot push replacement context material page route. Actually, I think we have some import issue going on here. Right? Yes, there definitely is. Oh, okay, never mind. My bad. We were doing this inside of the world data. Okay, that was so stupid. We were supposed to do it here. So let's do it again. Navigator dot push replacement context. Then for the root, we'll pass in material page root. And for the builder, it'll accept a context. And we'll return the world select screen. And let's make this a constant. Now let's restart our game. Cool, let's go into single player, create new world, create new world. And if I click on this right now, the world should create, and then we should go into our world select screen, and we do. So we have our new world here, right? So that is everything done. And before leaving, let's make one small change inside of main. So if you are actually running this inside of the mobile and you want this game to be in landscape mode, you can do await flame dot device dot set landscape. So this will set the device to landscape mode, right?